In the last course module, we had a very thorough look at all the important basics of Flutter and Dart. Now, when you're building Flutter applications, things will occasionally go wrong. You'll have errors. And in addition, thus far, we only tested our app on an Android emulator, but in reality, you of course want to test your application also on iOS simulators and on real devices. Therefore, in this module, we'll have a look at how you can run your app on different platforms, so on Android and iOS, and on real devices, and how you can test your app there. We'll also have a look at error messages, because things will occasionally go wrong. You will have some errors in your code, and reading and understanding error messages and fixing errors is a crucial part of development, so we'll have a look at that. And then there sometimes also are errors without error messages, because they might be logical errors in your code, which are hard to spot and fix. For this, we'll have a look at the Visual Studio Code debugger, which you can use and how to use it to walk through your code in detail and have a look into your code whilst it is running to really understand where a problem might be stemming from. Now that all helps us with fixing issues in our code, but sometimes the UI doesn't look the way it should look, or we're not sure whether we're updating some part of the UI unnecessarily. And for that, you will learn how to use the Dart dev tools and the Flutter inspector, which are tools that allow you to visually debug your app, so understand the user interface and why it looks the way it does look, and also get a brief insight into how to debug or measure performance and get a feeling for that. This is it for this module. Let's dive right in. Thus far, we only tested our application on an Android emulator. And that is generally fine, of course. Android is one of the major platforms you typically develop for. But of course, you might also want to test your app on an iOS simulator if you are developing on a macOS system, because you can only build iOS apps on macOS systems, unfortunately. Or maybe you don't want to test your application on an emulator only, but also on a real device. And we'll have a look at all these other use cases or these other ways of running our application over the next minutes. So here's the Android emulator, and I created it with the help of the AVD manager, as I showed earlier in the course. Started through Android Studio, you can open that AVD manager and spin up your emulator there. So that is what we already did. How could we now launch this app on a real Android device though? For that, you first of all need to prepare your Android device. And that means that you need to open your settings on your device and there choose these developer options. However, you might not have that option in your menu. In this case, go to About Phone and there tap on that build number 7 times. Now that might look strange, but this actually gives you this developer options menu item here. So tap on that build number here 7 times. I already activated it, so that's why I get this message. And once you did this, you should have the developer options here. Now there, generally make sure that it's turned on. And then there's one specific option you need to enable, and that is USB debugging. Make sure that USB debugging is switched on. Thereafter, connect your device, your Android device, with a USB cable to the machine you're working on, so you're developing this Flutter app on, and now you should be able to boot that Flutter app onto that device. Now here actually, in this Flutter app which I have here, I now can choose my device in the bottom right corner, here in Visual Studio Code. I now have the choice whether I want to use the emulator or my device here. And in Android Studio, you would also have an option of choosing where to boot it. If you're not sure how you can choose that, you can always simply quit the emulator so that you only have the connected device as the only device on which the app could be installed and run, and then the Flutter run command or running it with the debug command here should automatically pick the connected device. So here I selected the connected device in the drop-down menu, and with that, I can run the app as I always run it. So either with the Flutter run command or in Visual Studio Code here with debug start without debugging or in debugging mode, but I will go without debugging since this is a bit faster. And now the app will be built as it was before, and it will then be shipped onto the real device and will be installed and launched there so that you can test it there. Now let's wait for that to finish. So here's the app running on my real device, on my real connected Android device. And of course there I can interact with it just as I could in the emulator, which is good. You should see the same result here. Now when developing an app, testing it on real devices is really crucial and something you absolutely have to do. Because whilst the emulators are really good and really, well, emulate real devices, it's just a simulation. Nothing can replace a real device. So testing on a real device, and if possible on different real devices, is something you should do as part of every app development process. So that was Android, emulator, and the real device. Now what about iOS? Now important, to build an iOS app you need the macOS operating system. That is a restriction applied by Apple. You can't build your Flutter app for iOS on Windows or Linux. You need macOS. If you are on macOS, then you can of course also test the app on a simulator or also on a real device. Now for that you need Xcode, and I showed you how to install Xcode in the first module of this course, so you should be able to launch Xcode and see that welcome screen there. Now in there, open another project, click that button, and then navigate to your Flutter project folder, and there to the iOS folder and choose that runner Xcode project file. Open that as a project in Xcode. Now here you could write code, but that's not what we'll do. We'll stick to Visual Studio Code for that. But here we can also configure this so that we can run it on a simulator. And there's one important thing you need to set up. Click on this project icon here, or on this root icon here, this root element in the left bar here, where you can get by clicking this folder icon here. So click on that so that you have this view. And then here you might see that signing for runner requires a development team. For that here in this drop-down, you should choose a team, and normally you should have one. If you don't have a team here, click on Add an Account and add your Apple account with your Apple ID here to Xcode. So here you can either create a new one if you don't have one, or you log in with an existing account. Now, important, for developing iOS apps, you need an Apple developer account, and you can activate one for your Apple ID, which you probably already have, by going to developer.apple.com and there click on account. Now here you now have to log in with your Apple ID, and a process should start which turns you into an Apple developer. Whilst you need to agree to some terms, what you don't need to do to develop apps is pay. You will have to pay a fee to really publish your app to the Apple App Store, but for developing and testing your app, you don't need a paid account. So no need to pay, you just need a normal Apple developer account. Once you have that, you should be able to select your team here in Xcode and use that for this project. Now once you did this once, you should be fine. And now you can run your project either through Xcode by selecting a simulator here and clicking the Run button, or select a real connected device if you have one. But you can also do it here from within Visual Studio Code by going to the terminal, and there in your normal system terminal, you can run open -a simulator.app. And what this will do is it will bring up an iOS simulator. Here it is. Let me close Xcode. We don't need that anymore. Let me move the Android simulator over there. And now here is the iOS simulator. And again, you could have launched that through Xcode as well if you wanted to. Now this is booting up, and as soon as this simulator is done booting up, we can select it down here. Oh, well, actually I can already do that. So you can select your simulator here in the bottom right corner of Visual Studio Code by clicking on that bar here, then select the iOS device, or as before, shut down all other simulators, disconnect all other devices from your machine, and it should automatically pick this one. And once you did all of that, just as before, you can again run your app there with the Flutter run command or through the debug menu here in Visual Studio Code and start without debugging, for example. And now this will also build the app, but it will now build it with the help of Xcode, because now an iOS app is built, and once it's done building the app, it will ship it onto the simulator. So let's wait for that to finish. Here's the app running on iOS now, and one thing you might notice is that it looks exactly the same as it looks on an Android device. The reason for that is that Flutter does not automatically adjust the styles to the iOS look. It does not automatically give you that iOS look. Remember that with Flutter, you in the end use a framework that controls every pixel. It's not using native device or native platform user interface elements. So a button here is not compiled to an iOS button for iOS and to an Android button for Android. Instead, a button always looks the same because Flutter draws it onto the screen. It's not using some platform primitive, not a built-in UI element. And therefore, these apps look similar. Now, later in the course, you will indeed learn how to adjust your look though. Other than the font family is actually different automatically. But you will learn how you can adjust your app to look like an Android app on Android and an iOS app on iOS, if you want that. Or you create your own look for all platforms. Whatever you need. All that is possible with Flutter, and we'll of course have a look at all these options throughout the course. Now, more important than the look is, of course, that it works correctly. And that is the case here. So now we can also test the app here on the iOS simulator, and we're just fine. Everything is working correctly. Now, what about a real iOS device then? So this here is now a live recording of my connected iPhone. So now I want to launch the app on that iPhone. And once you connected your iPhone or your iPad to your macOS device, on that device you should be prompted whether you want to trust the connected device, and you should of course choose yes there. And you should then be able to select your device here in Visual Studio Code in the bottom right corner by clicking on that bar as well. Now, I'm actually not able to choose it here. And if that's the case for you as well, you can also use Xcode, open that project again, which I showed you earlier. And then here in the drop-down, select your device, and you can simply now launch the app on the real device here by clicking that play button. That also works, and it will also build your app here and ship it onto that device. So let's wait for this build process to finish then. And here's the app launching up on my iPhone now. By the way, don't worry if that first launch takes a while. That only happens here because we're still having a development mode app, which is not optimized at all, which has a lot of overhead inside of it to speed up development. Now, this is the running app though, and just as on the Android device or on the simulator, of course, I can interact with it. Now, the look is the same as on the iOS simulator, of course, not adjusted to iOS for the reasons I explained. But the important thing is that we now also can test our application on the iOS device. And just as with real Android devices, of course, if you plan on shipping your app to the Apple App Store, you should also test the app on as many real iOS devices as possible. So you learned how to launch the app on different simulators and devices. For the majority of the course, I will work with the emulators, and they're mostly with the Android emulator, simply because Android is the system everyone is able to follow along. iOS apps can only be developed on macOS systems, and not every student has a macOS system available. So Android will be the focus of this course, or the Android simulator will be the focus, I should say. We will nonetheless build apps for both platforms. And since we'll work a lot with simulators, you should know how to use them. For the Android simulator, you have this control panel here on the right where you, for example, can rotate the device. Now, important to also apply the rotation effect here, you need to open your settings here or scroll down, bring up that status bar on the emulator and make sure that device rotation is turned on. With that, by pressing these buttons, you can simulate that the device is rotated and then also confirm that your user interface looks good in landscape mode. Of course, in this course, I'll also extensively cover how you can render different user interfaces, different layouts for different device sizes and device orientations. So that is one important thing you can do here. There are other things which will become more useful once we later also work with maps and so on. Here, if you click on these three dots, you have even more options of configuring and fine-tuning this. On the iOS simulator, you can also rotate the device. You have all your options up here in the toolbar or in this top control bar here. There under hardware, you can also rotate the device or you use one of these shortcuts here. And there, for example, you can also control the soft keyboard and enable that, disable that, so that you can either use your real keyboard on your MacBook, on your macOS device, once we have some text inputs here, or that you use the soft keyboard on the screen. Simply play around with these settings to get a feeling for what you can do there and how you can control these emulators for testing the app in the way you want to test it. Now that we know how to launch the app on different devices, let's dive deeper into which tools we have to effectively debug it. And with debug it, I mean things like solving errors, finding logical errors in our code, and also things like checking what is responsible for rendering the user interface in the way we see it, as well as some performance monitoring. We can do all of that very conveniently with the help of Flutter and some special tools Flutter gives us. So in our code here, what could go wrong? There are different kinds of errors you can get when building a Flutter app. One of the most common errors, and thankfully also a kind of error that is relatively easy to fix, is the syntax error. For example, you might forget a semicolon from time to time. In such a scenario, when you start your app with or without debugging, doesn't matter, you should automatically get a complaint here, and you can have a look at the errors you're getting, which you should also get here in your IDE, and also here in Visual Studio Code in the Problems tab if you go there. So there it should already hint you at some of the obvious errors you might have in your code. So that's relatively easy to fix. In addition to that, you might also have errors which aren't recognized by your IDE, but which pop up when your app runs. For example, we might have an error where we add 3 to our current question index, and the result will be that we exceed the range of available indexes right after answering the first question. Because we increment the index from 0 to 3, we only have 3 elements in the list. As you learned, the list indexes start at 0, so the index 3 would target the 4th list element, which we don't have, and therefore this will cause an error. However, the IDE doesn't pick up that error because it doesn't analyze the data we're working with and so on. We will get an error though once we run our application. So here, let me launch the application and then show you which kind of error we get and how you can resolve such errors on your own when you get them. With the app running here, once I click a button, we get to the result screen because we don't even try to access an element with that index. That changes, however, if I try to add some code here. So here, if I take my questions and I want to print the question item for the chosen question index, then this again will be code which is accepted by my IDE, which is not detected as a problematic code, and which therefore will now, however, cause an issue once our app runs, because now I'm doing something invalid here when our application is running, so we will get a runtime error. So let me restart the quiz here. And now, whilst we don't get an error message here, sometimes you also get error messages projected right into your app user interface. Whilst that is not the case here, we do get an error here in the debug console. And that's good, because whilst this always looks scary when you see it the first time, it actually holds useful information that allows you to fix that error. Now, the important thing you have to know here is that for Flutter errors, the most helpful messages or the most helpful things are always located at the top at the beginning of the error message. So let's scroll up all the way to the beginning of the error message. And then here we see that a range error was thrown. Okay. And that we have some invalid value, which is not in the range 0 to 2. The value seems to be 3, something like this. Maybe at this point of time, you already have an idea what could be wrong. And with time, you get more and more experience and you see more and more errors. And then it's pretty clear that a range error always means that you tried to access some element in a list or in a map or anything like that, which doesn't exist there. But in case you're not entirely sure what happened, or you know what happened, but you have multiple lists in your application and you want to find out which concrete code snippet caused the error, you can look a bit further down, and then you see that it was located in the myAppState class and there in the answer question method, and it even gives you the concrete line number 68. And then you can go to your code. You can even click on that line here, by the way. You can click on that line and you see, okay, this is the line that caused the error, and now you can analyze what's the problem. And here, of course, the problem is not the line itself, but the line before that, where I set the index to an invalid value. Now, this is how you should work with such error messages and how you should read them. Don't run away when you're getting an error. Read the error message. The most important part is located at the top typically. Analyze the file and the line at which it is pointing you and find out what could be wrong there and take this as a starting point for searching the error. Now, sometimes you have a really hard time finding an error, especially if it's not an error that throws an error message, but if it's some logical error. Now, what would be an example for a logical error? An example would be that we indeed add 2 here because maybe we mistyped and will now never get an error message because I commented out that line. And in our widget tree, we also won't run into a situation where we select the wrong question because we render the result screen once we're out of questions or once our index exceeds the question's length. So we'll never get an error message here. And still, we have the wrong behavior. When we test our app on the device, we seem to skip a question, and we only got 2 questions until we reached the result screen. So something is wrong. But here we got no error message. So how can you now narrow down the issue and find out what's wrong? There are 2 ways of doing that. The quick and dirty way is that you use print. Here, for example, you could print question index to find out if something's wrong with that index. So we could do that here. And if I save that and I now click through my question or through my answers again, then we see that the question index is 2 and 4. And that might already be all we need to know to find out, oh, something's wrong with the index. Why is it increasing by 2? It should be increasing by 1. So this might be one way. Using print in your code is a nice way of printing out the current state of a given value and find out if it has the value you would have expected. But if you have more complex problems, using this print debugging can be too cumbersome. And therefore, you should use the more powerful built-in debugger. For that, quit the running app and now run the app in debugging mode. So start debugging, not start without debugging, but start debugging or use the respective shortcut. Now this will also launch the app, but as you can already tell, in a different mode. Here in Visual Studio Code, it automatically enters the debugging view, which you can also activate manually here under View, Debug. You can always go back to the Explorer if you want to see your files. But in View Debug, you now can do more than just add a couple of print statements. For example, what you can do now is set breakpoints. You do that by moving your mouse cursor to the left side of the line numbers here in your editor view, and then you can add a breakpoint by simply clicking there. Now, a breakpoint will halt the code execution whenever it reaches this code line. And you can then even look into the values of variables and properties and find out if everything has the value you expected and so on. You can also, if you want to, place breakpoints here in your widget tree. Simply try a couple of different spots and see where code execution stops. So now let's wait for this installation to finish, for the build process to finish, and let's see how the breakpoints work. Here the app already stopped. It launched the app and it stopped right away because I placed a breakpoint in my main.js file in my myAppState class in the main build method, therefore, right here when the widget tree gets built. And now you can use the controls here in the top right on this bar to move through your code. With this icon here, you move to the next line of code, so to the next instruction to be precise. With the arrow next to it, you can step into, for example, a function call so that you don't skip it and just proceed with the result, but that you really can go through each step in the function. And if you are in such a function, for example, you can use this arrow here to step out of it. So here I'm in the build method of the quiz widget now, because I stepped to the next step. We see that now here build was called. And the cool thing is we can now step into this. And if you hover over things like the context here or over questions, you can see what's in there. You can inspect this, you can find out what values are in there, and if that all has the values you did expect. For example, we can find the current question index value. You can also add values to the watch list here on the left so that you can watch how they change as you progress through code. So here, for example, I could add question index, and now you see it currently has a value of 0, and we can check whether it stays that way. Now, once you're done for the moment, you can always press the play button here on the left to continue code execution until the next breakpoint is hit. And you see right now question index is not available because we're not in that code snippet anymore. Now, however, if I press a button, I'm taken back to the editor because I also had a breakpoint in answer question. I placed that earlier. And here we can now see what the total score is, for example. We can see what the question index is, and here we might then already spot our mistake, for example, our logical mistake. Again, we can step through our code step by step if we want to, so that we progress, well, step by step. We always can see which variables we currently have in the method we're at the moment. So score, for example, or this, which refers to the overall class, where we can therefore inspect all our properties of that class, bunch of internal properties managed by Flutter, but then also, for example, our underscore questions or our question index property. And with these tools, you should have everything to deeply analyze your code, what's going on there, what's changing, why it's changing, and hopefully spot logical mistakes. Now, if you're done, you can always press the play button, and if you want to get rid of breakpoints, you simply click on them to clear them, and now your code won't stop there anymore. So that's the debugger. By default, I would recommend that you run your app without debugging though, because the debugger injects some extra logic into the running app and simply makes the app a bit slower. And therefore, you have a faster development cycle. You can work on your app faster, see updates faster if you start your app without debugging. But dive into debugging mode whenever you have a complex problem where you want to find out what's going wrong. Now, that all were tools, however, that helped us with finding and fixing errors in our code. But what if we want to have a look at our user interface and find out why elements are positioned the way they are positioned, or find out how performance of the application is? For that, we have yet another tool we can use. And for that, in Visual Studio Code, you can hit Command-Shift-P or Control-Shift-P on Windows to bring up that command panel. And there, if you type Dart DevTools, it should give you that option of opening the DevTools. Hit enter there. Maybe you also were prompted for it before in the bottom right corner. That's also possible. Once you hit enter there, a new tab should open up in your browser here in Chrome. And that now is a web page that is connected to your running emulator and gives you some live insights. For example, here on the left, you see the current widget tree that you see graphically here in the emulator. Here is its data representation, so to say. And you can click on widgets there to learn more about them. Here, for example, you see the text that's inside this text widget, which is clearly the question text here at the top. And you can learn more about its settings, like the color, if it has a specific style, and so on. And you can do that for all. You can do that for all these containers and so on to learn how they are configured. Now, at the moment, at least, you can't change the configuration here, but at least you get a feeling for how your widget tree looks like and how it is configured. You can also go into select widget mode here, activate this by tapping on it once, and thereafter you can select widgets here in the emulator. You can simply click on them, like on this button, and now it's selected. You see some helper lines that show you how much space this widget takes up and how it is rendered. And on the right side, or in your browser there, in the DevTools, it is also automatically selected then, and you can learn more about it and how it is configured. You even see, for example, here for the button, how it is built internally by Flutter, that it uses a couple of other Flutter widgets to build that button. For example, a container, a center widget, and so on. So here you can really have a deep dive into your user interface and see why it is built in the way, well, it is built. In case you're not interested in selecting widgets, here in this Flutter DevTools or in the Dart DevTools browser window, you can also click on Debug Paint here. What this does is it adds some helper lines here in your UI that basically helps you understand why your app is laid out or structured in the way it is laid out or structured. You see that, for example, this text here is centered. You see some helper lines around that button widget, which indicate that there seems to be some extra margin, and so on. So that can be really helpful for getting a feeling for why your app looks the way it looks like. You can also paint the baselines here, which gives you some helper lines for the text baselines. Can be useful for aligning things that are sitting next to each other. So these are nice visual helpers here. You also have a performance overlay, which you can activate, which helps you understand how performance of your application is. Though be aware that performance in development mode on an emulator is never great and never as good as on a real device once your app is built for production. So using it here in development mode is not really something I would recommend because you get a wrong idea of how performant or unperformant your application is. But once you build your app for production and you're testing this app, you can get a feeling for it if you have any places in your app that you might need to tweak to improve performance. It's not something we'll care about at the moment though. What you also have here in the DevTools is an option to turn off that debug banner in the top right corner in case that was annoying to you. And really useful, the repaint rainbow. And that's something I want to have a closer look. So what's the repaint rainbow here? I activated it, and the result is that now, if I do something in the app, like tap a button, I get some borders here. And these borders indicate what was repainted. And the more often something gets repainted, the more often the color around that widget changes. And therefore, this is a great tool for finding out whether something changed on the screen that shouldn't really change. For example, here when I click the buttons, it makes sense that all this part here changes. However, in our application here, since we manage the entire state in the main Dart file in the myAppState class, which is connected to our root, to our topmost widget, the myApp widget, since we manage our core state in here, we always rebuild the entire app and the entire page with every button click. That's the reason why we also see boundaries or borders, green borders, around our app bar, for example, because that's also rebuilt when our chosen question changes. Now that's normal for this application here, and it's okay for this simple app, but a possible improvement here could be to wrap our core quizzing logic with the quiz and the result into a separate widget, which then manages the state, so that the scaffold and material app and app bar widget are in a separate widget where the state is not managed, so that the build method for this widget, which contains these never changing elements, is never triggered, and we have the things that do change in a separate widget. That would be one possible optimization which won't matter here, but which we will apply later in the more complex apps we're building to ensure that we really only trigger the build method on the widgets that did change and not trigger it on unrelated widgets which don't really need to update. Because in this app, the app bar never changes, there is no need to trigger build for it and therefore repaint it on the screen. One important side note at this point though, repainting on the screen is not the same as recreating it. It's of course great if you can avoid it being repainted, for example by outsourcing the parts that do change into separate widgets. But even if something is repainted, Flutter might be able to simply take the previous element it painted, so the previous app bar with the exact same color and text, and reapply that. Then it's still worse than not repainting it, but it's better than recreating it, which would mean that it also had to internally rebuild the app bar, which takes up a bit more performance than just drawing an element which it already knows, which it already has stored in memory, back onto the screen. It's a small difference, but it does matter. An element might be repainted, but Flutter might be able to take an existing element from memory. That's better than if Flutter has to create a new element and then paint that element. Of course, the best is if Flutter neither has to recreate nor repaint an element. But we'll take a closer look at such optimizations later once we're a bit more advanced and we know a bit more about Flutter. In the Dart DevTools, we also have more options here at the top. We're currently in the Flutter inspector with all these tools. Now there you also have a timeline. This can be useful for recording your app. If I now tap here, you see some bars appear here. This can also be great for basically debugging performance, but you should do that in production mode, not in debug mode. We even get a warning here that this is not really a good indicator for how our app would perform once we ship it to an app store. But once we do have it in production mode, we can test it here with the timeline and basically get another tool for understanding the performance of our app. We can also spot its memory consumption, which can be useful for detecting memory leaks. If that keeps on growing over time and it never frees up memory, then you might have some spots in your code where you maybe store data that you never use thereafter, but you also never let go of. Also something we'll have a look at later in the course. And then here, last but not least, logging shows you some log messages. Well, typically that's not too useful, but from time to time, you might find some useful information in here that you're interested in. The most important tool, however, is your debug console here, and for visual debugging, the Flutter inspector with the tools I walked you through in this module. Thus far in this course, we had a look at the core basics of Flutter, of widgets, and of building basic apps and of debugging and running them. In this module, we'll have a closer look at the things you need to build realistic apps. And that means we'll dive into more widgets that are built into Flutter. We'll have a look at styling widgets, at building custom widgets, at theming, which allows you to set up a global style for your application, and also at adding logic to an app and how you get that combination right of having a nice user interface and of course also having your logic in code that does something when the user interacts. This is the app we'll build in this module, our personal expenses tracker, where we can add new expenses, like a couple of shirts here for $30.99 maybe, where we can then also choose a date on which we had this expense, and then this gets not only added to this list, but also we have this little chart here at the top, which is calculated and filled dynamically to show us on the last 7 days how much we spent on each day of our total spendings. And this updates with every new transaction we add and with every transaction we remove, as you can see. Also, we have this scrollable list here to display our transactions and the overall scrollable page. We have different ways of opening that new transaction mode, and we have the date picker, and in general, you will learn a lot about new widgets, about wiring up your widgets with your own logic, like, well, deleting widgets when you and also how to style these widgets to have the app look the way it does look. So in detail, as I already mentioned, we'll dive into many more widgets, and I will show you examples of how to use them and how to configure them. Now, since Flutter has so many widgets and so many different configuration options for each widget, it's also crucial that you are able to work with the docs on your own and that you find out how to use the widgets with the help of the docs. And that's also something I'll emphasize throughout this module. In addition, you also find plenty of extra materials attached to various lectures of this module, so always check that top left corner of your video player and see if there are downloadable resources that could be interesting to you to get some extra information and some cheat sheets. Now, besides using widgets and configuring them, we'll have a look at theming and theming our app with the help of Material Design, which is Google's design language, which we'll use in this module. You will learn what theming is and how it works. You will also learn how to add images and fonts, custom fonts to your application, and you will learn how to add business logic and wire everything up there so that things happen when users press buttons and that your user interface updates correctly. It's a lot of content, it's a long section, and together with the previous two sections, this will give you even more fundamentals and also the know-how you need to build your first basic real applications with Flutter. Before we get started with the application, let me point at that Flutter widget catalog again, for which you can also simply Google to find it in the official docs. There you have basically all the widgets that ship with Flutter, or all the core widgets, nicely grouped into categories. And it's always worth having a look at these categories to find out which widgets are there. Because of course I can't show every single widget in this course, because you don't need every single widget in every app you're building. And even though we're building quite a lot of apps in this course, we still don't need every widget. So this is nice to learn about new widgets, but it's also nice, and that's really something I want to bring into your mind, or which is important to understand. This is also a nice resource to not only learn which widgets exist, but also what they do and how you can configure them. So it's always worth having a look at the documentation of a widget you're using to learn what its intention is, how you may configure it, which related widgets exist, how you can construct it, so, well, that is the how you can configure it part, I guess, which properties it has, and so on. This is really something I would recommend diving into because it's a really amazing complementary resource for learning Flutter and for building the app you want to build. Or, if you don't know in which category a certain widget is what you want to learn about, go to api.flutter.dev, and there you can always search these API docs for a specific widget, like list tile, which we'll, for example, use later down in the course. And then on these pages, you always can learn more about how to use them, configure them, which options you have there, what the idea behind them is, and so on. There are, however, a couple of very important widgets through which I want to walk together with you right now, because these are the widgets we'll see throughout the course, and a lot of them already throughout this module. There are, for example, widgets that help you with general application and page setup. And that would be the Material app widget, which we already saw, which we already used in the previous course app. But it would also be, for example, the Cupertino app widget, which you would use to build an iOS-styled application. And more on that later in this module when I dive into the different styles and how you may adjust your application to look good on iOS. Now, this sets up the overarching application, does a lot of behind-the-scenes wire-up work, which will, for example, also help us later once we add navigation and once we can switch between pages. What you can see on the screen, however, is also heavily influenced and controlled by the scaffold, or for iOS styles, Cupertino page scaffold widget. That is the widget that gives you a white background. Of course, you can change the color, but that gives you a background that allows you to add an app bar and so on. So that is the frame for what you see on the page, you could say, and it's a crucial widget for setting up the rest of your page and of your application. Now, once we have the frame set, of course, we want to position our own widgets, and therefore the built-in layouting widgets are also super important. There we, for example, have the container, a nice widget that gives us a lot of different styling and alignment options so that we can, for example, align a child inside of it. But the container is a very versatile widget where we can also give it a background color and so on. You will often use it as a wrapper around other widgets to get a certain styling or a certain alignment. Now, extremely crucial widgets are also the row and the column widget. We already used the column widget in the first course app, and there we used it to have a column of items which we position beneath each other. In this example here, the row widget, of course, is used to position items horizontally instead of vertically. So these are crucial widgets because, unlike the container, they don't just take one child, they take multiple children. So you basically always need a column or a row when you want to have more than one widget sit next to each other or below each other. Now, besides these layout widgets, we also have specific widgets that work together with row and column. Because in there, you can have different child widgets, but when it comes to how much space each widget should consume, there are widgets that can help you there, flexible and expanded. Now, I'll not dive too deep into these widgets right now. We'll see how they work and how you configure them throughout this course. Basically, these are widgets which you would wrap around a child, like a text widget, for example, to configure how much space this child widget should consume in the wrapping row or column. And don't be confused here, flexible and expanded can both go into columns and rows. So this slide is not meant to show that flexible belongs to row and expanded belongs to a column. Both flexible and expanded can be used in both row and column widgets. Other important widgets we have are, for example, related to holding content. There we have the stack widget. The stack widget is always great if you want to have items, other widgets to be precise, positioned on top of each other. Let's say an image with a text in the foreground. The card widget is also useful. This is basically a pre-styled container widget, you could say. It gives you a nice drop shadow, some background color, a little bit of padding. Remember, padding is that inner spacing inside of a container. So it's basically a container with some default styles. And that card look is a look you actually see a lot in modern apps and also websites where you have that visual container around some content. Besides these content containers, we also have elements or widgets that help us with repeating content. There we have the list view, which is pretty much like a column, but a column that is scrollable, because a default column is not scrollable, as you will also see. Sometimes you also don't just want to have items sit next or beneath each other, but have them ordered in, well, columns as a grid, and for that you have a grid view, which is basically a combination of column and rows, which is also scrollable. So like a list view, but with multiple items sitting next to each other if you want to. And inside of a list view, for example, you could use a list tile widget, another core widget baked into Flutter. This is simply a widget which you could also build entirely on your own. You don't need that. It's just a widget that comes with some default styling and some default positioning or layout setup, to be precise. And we'll also use that throughout the course. We also have widgets that help you with different content types. We already worked with text widgets, but there, for example, also are widgets that help you with presenting images, where you can also control how big it should be, how it should be positioned in a wrapping container, and so on. And you have also a widget that helps you with using icons. And as it turns out, you will also have buttons with icons. There is a specific icon button widget even. Speaking of buttons, we have widgets that help us with user input, like text fields where a user can enter something, or buttons, raised button, flat button. As I just mentioned, there also is an icon button widget, which, well, is a button with an icon on top of it. And you can also build your own custom user input widgets, your own buttons with invisible widgets like gesture detector or partly invisible widgets like Inkwell, which gives you that ripple effect when you tap somewhere, which basically allow you to wrap anything into a widget that can't be seen or can only be seen upon a tap in the case of Inkwell, but that allows you to register a broad variety of event listeners on a tap, on a double tap, on a long tap, and so on. So these are some of the most important widgets, and obviously this was just a quick summary here. We'll see these widgets throughout the course, so there's no need to learn them by heart right now. The core takeaway is that Flutter has a broad variety of built-in widgets and gives you all the tools you need to build your own widgets as well. It takes some experience to find out what you have to build on your own and what's built in. And sometimes it also depends on tiny details. Maybe the thing you want to build is almost built into Flutter, but there's one thing which you can't configure, which you absolutely need. And therefore it's great to have both the built-in widgets, but also the flexibility to create your own widgets. The widget catalog is a great starting point to learn which widgets are built in, but please don't feel overwhelmed by the broad variety of widgets you find in there. You don't need all the widgets in every app you build, and also there are some widgets which do almost the same as other widgets and maybe exist because of historical reasons. They existed first before a better version was released as a separate versions, or they do one tiny thing differently than the other widget does it. So that is how you should think about these widgets. But with that, I'd say we had enough of the theory. Let's actually now dive into our next course application and simply start building it to see how we can use built-in and custom widgets. Now, which application will we build in this module? We'll build an expense planner. And that means that users should be able to add their expenses, like what you bought yesterday, bottle of milk, maybe some new shoes. You can add them, and we keep track of those expenses in a list. And then we also show a little chart that basically sums up what we spent over the last week. So our application will look something like this. And now come my awesome drawing skills. This is our iPhone or our Android phone. And in there, in this application here, we'll therefore have a couple of things. We'll have our little chart up there, which we'll build, which will basically have little bars that indicate how much we spent on each day over the last week. Below the chart, I want to have a list of the transactions which we registered. And for each transaction, we kind of save the price, let's say, so what we spent, and then a little title here, something like that. I also want to make sure that we can, of course, add new items here. And for that, we'll have a little plus button here in the app bar. And I also want to have a so-called floating action button here at the bottom, which also has a plus, and both buttons, because this of course still is also a course where I want to show you something, will trigger in the end not a new page, but a new mode on the existing page. So we're still on the same page where we have that chart and so on, but once we press one of these plus buttons, a little bottom sheet should slide in. So this is a little sheet coming in from the bottom, overlaying the rest of this application. So behind that would be our list of transactions here. And in that bottom sheet, we'll have some inputs for the title and for the price, and also a date picker so that we can pick a date. And then of course a button to confirm this. Now, I can certainly draw nicer than that, or maybe I can't. But we can certainly build this app. And we'll build this app with some of the widgets Flutter gives us, with more than just the basic widgets we used thus far. And we'll then also use the various theming and styling features Flutter gives us to make this application look good. And with that, let's get started. I'm here in a brand new Flutter project, just a bit cleaned up. I removed all the comments and I converted this homepage widget into a stateless widget. And you find this main Dart file attached to this video in case you want to replace yours with it. I have no other widgets in this project right now. I haven't added any custom widgets. I haven't added anything. This is my basic setup. And now the goal is to get started, and we'll basically build this application as I just sketched it out, and we'll add new widgets as we need them, or dive into the widgets Flutter gives us as we need them. Now, what will we need to build this application? Remember that we had this chart area at the top, and below that we had a list of our transactions. So what we certainly have is at least two widgets sit next or above each other, we have that chart, and below that a list of transactions. That list, of course, also means that we have more than one item in there, but we can take care about that in a separate step. For the moment, let's start basic, and let's make sure that therefore on the body of our scaffold here, which is rendering that page of our app, that there we have a column, because we will have 2 items in there. Hence, we should add the children key here to the column, and in there, I want to have these, as I said, 2 areas. Now, for the moment, I'll add a card here, and card is a built-in widget, which is this pre-styled container I mentioned earlier. I'll add a card here to later hold my chart. For the moment, the child which I add in the card, so the widget that is wrapped by that pre-styled container, that will be a text widget where I say chart, simply as a placeholder, of course. We'll add a real chart there later. Now, below that card, I want to have that list of transactions. So for now, let's add another card here where we say list of TX for transactions simply. Let's save that and let's see if that works. And for that, I'll start my app in without debugging. So I pressed the shortcut for this option here, start without debugging. And I want to see whether that works. So let's wait for that to build and launch. And with this launch, this is what we get. You might barely be able to see the card effect here. If you watch really close on your own screen, probably, you see that the text is inside of a tiny container with a white background and a little drop shadow there. So this is certainly not the final look you want here, but at least we have 2 widgets sit on top of each other. Now, since we use that card, and since the card is one of the more important base widgets Flutter gives you, let's see how we can make sure that this looks a bit better, that this also takes up more space. And for that here, let's press Control Space and see what we can configure on the card. We could set the color, the background color. We can also set the elevation, which simply is a double, which controls how strong that drop shadow is. We can also add a margin, which adds some space around it. And the other fields here aren't that helpful to us right now. So let's maybe go with elevation and set this to 5. And let's see how this changes things. Now we can see a bit of a more stronger drop shadow on that first widget or on this first card. But what we haven't changed at all is the size. For this, you have to know that the card by default assumes the size of its child. So if we want to change the size of that card here, then we need to change the size of the child. Now, text, on the other hand, is a widget which by default only takes as much space as this text needs. And if you want to change the size of text, you need to change the size of its parent. So what can we do here? Since this card depends on the child and this text depends on the parent, we have a dependency which is kind of hard to break, right? How can we increase the overall size of the card? There are 2 ways of breaking that. One is that we wrap that text with a widget where we can set a size. We can do that with the refactoring shortcut, which you can find in the key bindings in case you forgot it. And there we can wrap the text with a container, because container is the most universal styling, positioning, sizing widget you have. With a container, you can control almost anything when it comes to how something is sized or how something is aligned and styled, at least if we talk about things like background colors and so on. And therefore, once I wrap the text with a container, we can use the fact that on the container we can set a width. We could set this to 100, and this means the container will now have the width of 100 device pixels, which is a unit that always gives us the same size, even on differently sized phones or devices. So now we can see that this container is a bit bigger. This becomes even clearer if I give that card a color, which is the background color, of, let's say, blue. If we do that, then we see it more clearly. So we can change the size of the card by increasing the size, or in this case, the width of the child, because now the child is a container. The direct child of the card is a container. On that, we can set the width, and therefore, we make sure that the card no longer depends on the width of this text, which is just as big as it needs to be, but instead on the width of the container, which we can control. You could also set this to double.infinity, which is a special value, which means take as much width as you can get. And here this means the container will take the entire width of the device, since there is no other surrounding element or widget around our card that would restrict the overall width the card can take. So that is how we could break this. Another option would be that we don't wrap our text here in a container, but the card. Again, with the refactoring tool, we can add a container around card. And now here we can also set the width to double infinity, for example. If we do that, we also have a card that takes the entire width. And that has one important implication. The important implication is that card by default depends on the size of its child, unless you have a parent for card, like container, which has its own clearly defined width. This also means that column doesn't seem to be such a parent, because when we just had column around our card, the card didn't expand to take the full available width. And indeed, column is a widget which only takes as much width as its children need. Now with container, we give column a child that says, please give me all the width I can get, and it takes all the width it can get, and therefore column sizes itself after that and also now takes the full available width, because column always has the width of its broadest, of its widest child. And card now does not take the width of its child, but since it has a parent that sets a clearly defined size, card actually takes the parent as a measurement and takes the width of the parent. Now, when you hear something like this the first time, it sounds like something that is incredibly hard to learn, because it sounds like you have to remember all these combinations by heart. You have to remember that a card takes the child width unless there is a parent that sets a clearly defined width. Now, two important points here. For one, you have the official docs, and things like that are typically noted in there. So you can take the official docs to learn how widgets behave regarding their size. And in addition, and this is really the best advice I can give you, don't learn such things by heart, learn them by doing. Experiment with things. If you have a card that doesn't have the size you want, start wrapping it a container. See what happens if you set a width or height there. Start wrapping it with a column. See if that changes things. Start wrapping the child of the card with a container, and so on. So simply try things out, because you will have no chance of learning these things by heart. There are way too many combinations and widgets to do that. That's also why I don't provide a cheat sheet with all possible combinations, because that would be too many and too many to learn anyways. Try such things out. Build a dummy application where you can simply play around with widgets just like we're doing it here, and you will get a feeling for how you can combine widgets to get a certain result. And also important, in Flutter, there always is more than one way of getting a certain result. Just as you see it here, we could have added the container around the card or inside the card. Here, the result is the same, even though these are two different setups. Before we continue working on the app itself, let me play around with the column a bit. Because right now our two cards here, this blue card and the white card below that, are clearly positioned inside of a column. That is why we can have them above each other. And we can also see that they seem to be centered. The card with the chart in it takes the full width. So here we don't really see the centering effect. But we can clearly see it on our list of TX card. It's in the middle, horizontally, not vertically. And that is the default behavior indeed of a column. Now let's go to the column widget and let's see what we can actually configure there. Here you see you have a cross-axis alignment and a main axis alignment. And these are the two core configuration options which you have to configure how your column behaves. And you have the exact same options on a row, by the way. Column and row are core widgets in Flutter. They allow you to position items next to each other or above each other. Column allows you to position items vertically, row horizontally. Now you do that positioning with the help of the so-called main axis and cross axis. And for a column, the main axis by default is from top to bottom, cross axis is from left to right. So with these two configuration options, you can define how the items should be positioned inside of the column, both regarding the vertical direction and the horizontal direction. For a row, it's the opposite. There, the main axis is left to right, and the cross axis is top to bottom. And with these properties of column and row, which you can set through their constructors, you have a broad variety of options of how you want to position the items that you have inside your column or row. Let's see an example. Here's our column, and now let's set the main axis alignment here to, and now what does this need here? Which type of value? It needs a main axis alignment value. So let's enter main axis alignment and let the IDE help you. You should get a couple of suggestions here, and as you see, there are a couple of static fields, or to be precise, that actually now is an enum. You know, enum is that thing where you actually just have a couple of different options, which are numbers with human readable labels. And then these numbers are interpreted internally, in this case by the column widget. So here we can set this to center, and so on. Now the default actually is start. Let's see what happens if I set this to end. If we do that, now you see the items are pushed all the way to the end of the column, and therefore to the end of the screen. That's what I meant with the default was start. That's why they were at the beginning of it initially. Now you can also set this to center. And now, unsurprisingly, they are in the middle of the screen. Now sometimes you also want to have some space between these items, and therefore you have space around and space between and space evenly. With space between, the first card is right at the top and the second card is at the bottom. So the empty space in a column, which is always there, because a column by default takes all the height it can get, it has double infinity as a height value, so to say. Because that column takes all the height it can get, and therefore the full device height minus the app bar, because of that, now the white space with this setting is between the items. With space around, it's a bit different. There, the empty space is around the items. So we have the equal amount of empty space in front and after each item. These are very helpful settings which you can use on both columns and rows to position items along the main axis, which, just because it's important, is top to bottom on a column and left to right in a row. Now, besides the main axis, you also have the cross axis where you can position items. Now, to see an effect of that, let's first of all go to the second card and give that a color of, let's say, colors.red, so that we can see that second item just as well as the first one. Now here, for cross-axis alignment, you use cross-axis alignment, which also is an enum, and here you got a couple of different values. You also have end and start. Let's see what these do. Let's set it to start. And now you see the one here, which takes the full width, will never change, because the cross-axis for a column is left to right, and since this takes the full width left to right, we can't position it. But the smaller card can be positioned, and with a cross-axis alignment of start, it's all the way on the left, because the cross-axis starts on the left by default. Of course, unsurprisingly, if we set this to end, we therefore push the item all the way to the end of our column, all the way to the right here, because cross-axis is left to right. Now, other values we have here, for example, are center, which is the default, where this is in the middle, horizontally. And as you see, also, for example, stretch. If you use stretch, now this red card also takes the full available width. And here again, we have that scenario where card normally would take the width of its child, but now the parent of the card, which of course is our column here for the second card, the parent sets a clearly defined width. In this case, it sets a width of take all the width you can get, and now the card follows that parent width. Again, something where you can always experiment with to get a feeling for how that behaves. And main axis and cross axis alignment on columns are super important. The same for rows, of course, because column and rows are so important, crucial core widgets, which help you to position and align the items or the widgets you have on your screen. That's why we had this little excursion here, this little look at how we can work with column and main axis and cross axis alignment. Of course, we don't really need this alignment and this look we have here. We'll go back to our application now, but it's super important to take that with you, that you can align items in a column and also in a row with the help of main axis alignment and cross axis alignment. Now that we had some fun with column, main axis alignment, and cross axis alignment, let's take a step back and let's continue working on our actual application that we want to have. For that, we, of course, need our chart at the top, and below that we need our list of transactions. Right now we have no way of adding transactions through our app. Of course, we'll add such a way later. But since we don't have that at the moment, let's add a dummy list of transactions, shall we? And for this, in my widget here, I will add a final list. And now the question is, what is a transaction? And we could use a map here, because a transaction is certainly not just a string or a number. It's not just the value, the amount we spend. It's also not just the title. It's the combination of the title and the value we spent. And we could absolutely use a map for that. It's basically what we did in the first app in this course. There we used a map. A map would be fine, but here I actually want to take a different route and create my own class and therefore my own object blueprint for this. For that, in the lib folder, let's add a new file, and I'll name this transaction.dart, because in there I'll define how a transaction should look like. This will be a normal class, and now this will be named transaction, and it will not extend stateless or stateful widget, because this transaction class here will just be a blueprint for a normal Dart object, which I want to use in my Dart code. I don't want to use this as a widget that should be rendered. We'll of course also add other custom widgets throughout this module, but this here is not one of them. Instead, here I simply want to define how a transaction should look like, and therefore here I'll first of all define which properties or fields, which variables a transaction has. Now let's say each transaction has an ID, which is actually a string. Something like that, a unique ID that identifies each transaction. In addition to that, a transaction will certainly have a title, which, allows us to find out what this amount we spent is all about, and that is also a string. And of course, we also need an amount. So how much did we spend on the item we have here? Now, the amount will be a number, and therefore we could use num, but I want to be more specific than that. Is it an int or is it a double? Well, obviously, that depends on your requirements and what you want in your application. But I'd say for money that we spend, a double makes more sense, because we often have amounts like 99.99. So here I'll have my property of type double. Now, last but not least, I also want to save the date on which we did our transaction, on which we made that transaction. And that will be of a special type, the type datetime. Now, datetime is a type that's built into Dart. It's essentially based on a predefined class Dart ships with, you could say. It's not a primitive like string or double or int or boolean. It's a bit of a more complex object, but it's nonetheless an object or a class that's built into Dart, so we don't have to define it ourselves. And here I'll name this date, so that's my property name. These are the 4 properties that make up a transaction. Now, to conveniently create such a transaction, let's add a constructor here so that we can use the transaction here anywhere, this transaction class, to conveniently create new objects based on it. Now, to this constructor, we of course have to pass the values for this transaction. And there, it's up to you whether you want to use positional or named arguments. But since we have 4 fields that need to be populated, 4 properties, I'll go for named arguments, because I think that makes it a bit easier to create such a transaction. We don't have to learn by heart or find out which argument goes into which position. So I'll wrap this into curly braces. This is the syntax you need to add named arguments. And then we accept the value for the ID. And you might remember, this is the syntax that Dart understands to automatically bind the argument for the name ID to the equally named property ID because of this dot. And then we do the same for this title, this amount, and of course also this date. So now we have these 4 named arguments which are automatically bound to their respective properties here. These properties should never change thereafter, and therefore I'll all mark them as final here, which means they're runtime constant. They get their value when this transaction is created, but the value thereafter never changes. So with that transaction class created, we can go back to the main Dart file, and in the my homepage class, I'll create a list of transactions. So now we can use transaction, that class we just created, as a type here for our list. And that tells Dart that this list here, which I'll name transactions, that this variable will hold a list of transactions. That is how you should read this. It's a list of transactions. And here it's an empty list. Now, important to use the transaction class as a type here, or as anything here in the main Dart file, you have to add an import. And my IDE automatically added it, but not in the best way. You should simply import /transaction.dart. So import that newly created transaction Dart file, and that unlocks every non-private class and so on, which you have in that file. So therefore now we can use the transaction class here. Of course, having an empty list here is not that helpful though. I want to have some transactions to start with. So here I'll add transaction, using my class as a constructor now by adding parentheses. And now we have to assigning ID, a title, and so on. So my ID here could be T1, it's up to you. Title could be new shoes, and the amount could be, should be a double, could be 69.99. Now we haven't specified a currency here. For this application, I'll assume it's always dollars. You can of course assume any currency you want. Last but not least, we need to set a date. And here I will use datetime, this built-in class, and then now, which is a constructor offered by datetime that builds a new datetime object based on the datetime class with the current timestamp, which we'll do for now. So now we have this transaction in here, one tiny tweak in the transaction class. All these properties here are required, and therefore we should add required in front of each property. This, however, is not a decorator that's built into Dart. So in order for this to work, we need to import something from Flutter, because Flutter is actually the framework that introduces the required decorator. And we do this by importing package Flutter here in the transaction Dart file, and there foundation.dart. You could also use material.dart because that internally is based on foundation.dart, but foundation.dart is in the end the file that exposes @required. So now we made sure that these are required and that we would get an error if we tried to create a transaction without one of these 4 properties. And with that, let's simply create one other transaction so that we have at least 2 to display in our list by adding this one here. And maybe here we have our weekly groceries which we bought. Maybe that cost us 16.54 or 53. And I'll also take the current timestamp here. Later, of course, we'll make sure that the user is able to choose the timestamp. So with that, we have our list of transactions. With that list of transactions available, let's output the transactions. And for that, here, instead of that second card, which is a placeholder for that list of transactions, I want to have the actual list of transactions. So since we have more than one transaction, we need a widget that can hold more than one widget, because each transaction here in our list of transactions should be mapped into a widget that outputs the data of that transaction. Now, which widget can we use if we have more than one widget? A column. So here in the column, we add the children key, and again, now we can, well, output our different transactions. Now, each transaction might now be a card. So therefore, we could add a card here and now populate it with data for the first transaction, and then add a second card and populate that with the data of the second transaction. But this approach would have a flaw. Do you know which? Well, we as a developer would have to hard code as many cards as we have transactions. And whilst we know how many transactions we have at the moment, because the transactions are hard coded too, later the transactions will be dynamic because the users of our application will add them. So we don't know in advance how many cards we need. So in the end, our goal should be to take our transactions list and map that into a list of widgets. We did this earlier. So here, children will now not be an array like this, but instead here I'll point at transactions, which is my list of transaction objects. And there we can use the map method to transform this list of objects into a list of widgets. Widgets technically also are objects, but you get my point. Keep in mind, you need to call toList here at the end because map will always give you an iterable, which you need to transform to a list. But right now there is nothing to transform. Map doesn't do anything. You might remember that map takes a function which automatically gets executed on every element in that list. So in this case, on every transaction. So what we get here is a single transaction, and I'll name it TX here just as an abbreviation. So we get a transaction here as an input to this function we pass to map, and this function, again, executes on every transaction in here. And we need to return a new element here, and that new element, of course, should be a widget that represents our transaction. And there we could use a card with a child, and for now, let's simply output the title of the transaction, and we'll output the rest later. So here we get our card with our text in there, and the text, of course, should be drawn from the transaction we have. And in there, I want to access the title. That's, by the way, the convenient thing of using a custom class and object instead of a map for our transactions. Here I get nice auto-completion as soon as I type a dot to access the different properties of this object. I don't have to use title as we did it for a map. So here I output my title. And with that, we actually already transform our list of transactions to a list of cards where each card outputs the title of the transaction. If we save that, our application is taking shape and we see the two titles here. Now, of course, a transaction should be more than a tiny card with no spacing at all inside of it and then the title. So let's work on how we output a single transaction in the next lecture. Our transaction cards don't really look that impressive, and we should certainly change this. To change this, let's consider how a single transaction might look like here. So we have our app here, and up there we have the chart, and down there we have our list of transactions. Now, how should a single transaction look like? Now, obviously, there are dozens of ways of building this and structuring this. But one possible way I could come up with is that for each transaction, we maybe have the price here in a box on the left, almost like an image. So our price would be in here, obviously not a dollar sign, but the concrete amount. Then next to it, we might have the title, maybe in a fat, bold text. And below that, smaller, and maybe like light grayish, we have the date. Not too complex, but should be pretty helpful. Now, how could we build this, however? How do we build this thing here, this container? Well, the surrounding piece here, that can probably stay a card. We might want that slight drop shadow here. We can even increase that with the help of the elevation argument. Inside of that card, and that's really how you should think about building user interfaces in Flutter. What's inside of that card? You might say we have 3 elements in there, and that's correct, but what's actually happening in there? Well, actually, we have 2 main elements here sit next to each other. We have 2 items here next to each other. So that here should actually be a row in there so that we have 2 items next to each other. Because there is no other way of positioning 3 items like this in Flutter other than with a row. And in that row, we then have this first item here, which could just be a container. So let me note this here. That thing here, the purple thing, that's a row. Then this thing here might be a container. And then, last but not least, I'm running out of colors here. Last but not least, if I take that rose color here, last but not least, that thing here, so title and date, that of course is another column in there, right? It's a column inside of our row because we have 2 items above each other. Columns are not just there to position items on the overall page, but also inside of other widgets. Columns do nothing else than take 2 or more widgets and position them above each other. No matter how much vertical space there is. Here it's almost no vertical space, but still items above each other means a column. Items next to each other, like here, means a row. That is how you should think about building user interfaces in Flutter. And that's what I want to build together with you now. We will build this transaction card together with rows, containers, and columns, and text, and so on. So back in code, let's build this. We have our card, and as we just saw when I sketched this, inside that card, we need a row because we want to have two items next to each other. So let's replace the text here with a row. And now the row, just as the column, takes children, 2 or more widgets, which are now placed next to each other. And that's the difference to the column, of course. Their items are placed on top of each other or above each other. Now in that row, we wanted to have that first item, which we said could be a container, that holds the price. So here, why don't we add a child, which is our text, which is tx.price, and therefore not price, tx.amount, and therefore the amount of our transaction. And here I'm getting an error because that's a double, but text actually expects a string here. So we need to convert the double to a string, and we do this by calling toString there. On every double, you can call toString. On every number, you can call toString. Actually, on every object in Dart, you can call toString to get a string version of it. Of course, for some objects, that makes more sense, like doubles or numbers in general. And for other objects, like your own transaction, toString might just give you some unusable output. Here, however, we'll get the number as a string, which is really useful. And therefore, we already have that container. Now, next to that container in our row here, I want to have that column here. So that column where we can have the title on top and below that, the date. So let's use column. And then here, again, we might have two texts. So we have the text for the title. And then we can copy that to also have the text for the date. Now, date is of type datetime, which also is not a string. But we can use toString here to convert this to a string and see what that gives us. Let's save that and see what we get. Okay, the rough layout is there. Obviously super ugly, but we'll get there. We see the price, we see the title, and below the title, we see the date. The date, of course, is not nicely formatted. It's not human readable, but we will change that. To change the appearance of that, and with that I don't mean the date, we'll take care about that separately, but to change the overall appearance, we have to learn a bit more about how styling in Flutter works. We already did some basic styling. We, for example, set a background color on that card here at the top, but how could we style this a bit more? For that, you have to understand that styling in Flutter works entirely through the arguments you pass to your widgets. If you have a web development background, you are used to using CSS, cascading style sheets, for styling. And that is basically an extra programming language. In quotes, it's not really a programming language, but doesn't matter. It's an extra programming language which you can use to tell the browser how to style certain elements on the page. And it's only loosely connected to HTML, which is the structure of your page, the programming language with which you describe which elements you have on the page. In Flutter, there is no such separation. You don't have a separate styling language or anything like that. You style widgets through the arguments they take. And you have a lot of flexibility there. And if a certain widget doesn't take a certain argument, if you can't give a column a background color, for example, indeed you can't, then you always have to use another widget and wrap the widget which you want to style with it. So for example, if you want to give that price here, that amount here, let's say some spacing and a background color, then we can't do this on the row or on the text, but we can do that on the container. We can add space around it with the help of margin, because if you recall that slide I showed you earlier, a container is basically a collection of things. You have the child, the content in the middle, then you have some internal spacing between the border and the child, and some external spacing around the item, so around the border. So here we can add margin to add some spacing. Margin is actually of type edge insets geometry, and you always create margin in Flutter by using edge insets dot, and then you have different ways of creating margin. Margin in all directions, a constructor where you can specify the margin in each direction separately, symmetric margins where you say how much margin you want to have top and bottom and left to right, and that's indeed the margin I will use here. There you say how much margin, and that's now just a number in pixels, you want to have vertically, and let's say that's 10, and then how much margin you want to have horizontally, and let's say that's 15. And if we do that and we save, we now see we have some spacing around that, just like that. You also can, of course, do more. Let's say we want to have a border. Conveniently, the container has a decoration argument. Decoration here takes the decoration class, but actually, and that's something you learn from the docs or, well, from this course, you should use box decoration here, instantiate that, and now that is a class which gives you a lot of crucial arguments to style the decoration and therefore the appearance of that container. Not every widget has a decoration argument. Row, for example, doesn't have one, but the container has. So here, for example, we could now also assign a border. Now, a border, again, is not simply a number or anything like that. Here, it's instead of type box border. So you could think that you need to type box border and see what that gives you, but actually, the general border object is what you want here. And there you have some extra constructors, and all is really useful because that allows you to define a border in all directions. If you just create border as an object like this with the normal constructor, you can specify the border for each side separately if you needed that. So border.all allows us to draw a border around the container in all directions, and you can give that a color. And here I'll just use black. You can give that a width, maybe 2 pixels, and a style. And here you could choose from different styles like dotted and so on. If I auto format this and save this, now we see there's a border around our price. Now actually, some spacing inside of that border would be nice too, and you learned that this could be done with padding. Now not inside of the box decoration, but inside of the container. And again, if you're wondering how I know this, the IDE help with control space and the official docs, and of course resources like this course are your way to memorize this, and then it's always about playing around with these things. Padding, just like margin, takes an edge insets object. So let's add edge insets here. And there I want to have the same padding in all directions, maybe 10. So this is taking shape. We now have a border with our amount in the middle. Maybe we now also want to change the text style, however. The text style can, of course, also be changed. Not on the container, but on the text itself. On the text, if you use control space, you see you got a bunch of arguments to configure how that text is rendered. For example, also what should happen if it exceeds the box it's inside. Here, however, I'm interested in the style, which is of type text style. So indeed, you should create a text style object, and now you can configure a lot of stuff about the text. You can set a shadow, you can set the height, and so on. Here, I want to set the font weight, and I'll set that to font weight.bold. Font weight here is a class with a lot of static properties like bold. So we don't instantiate font weight, instead we access .bold like this because it's a static property. Keep in mind, static properties are basically like enums, just that it's not a number with a label, but a more complex value with a label. That value, however, that complex value is then used by the text style in conjunction with the text widget. So you just set this and you get a bold text. You can also change the size, so we can set the font size here maybe to 20. If you do that, it's bigger. Please also note that the surrounding card and container automatically adjusted to the increased size. So by default, that container grows with the content, which is of course good. So now we have this. Let's maybe also fine-tune the color. And for that here on the text, we can go to style and set the color. And let's set this maybe to purple, which is one of the built-in colors on that colors class. Again, this is a static property on the colors class. Just like font weight, colors acts as a grouping mechanism. And for the container, where I also want to change the border color now, well, we do that here when we set up that border. So I'll change this to purple as well. And now we have that purple box. So this is looking good. Now, as a little exercise, try doing similar style adjustments for your row. I want to make sure that all the items are positioned on the left by default and not centered. You learned about this earlier in this module. And change the text styles there as well. The title should also be bold, a little bit bigger, not as big as the amount, but a little bit bigger regarding the font size. And the date, whilst it still looks ugly, should have a grayish color, so not black, but gray. And it should definitely be smaller than the title here. These are the adjustments I will make in the next lecture. Definitely try it on your own first. Were you successful? Let's do it together. So let's start by positioning the items. For that, let's go to our column here, which holds the title and the date. And there you learned that you can adjust the alignment with main axis and cross-axis alignment. But what do we need here? Remember, in a column, main axis is top to bottom, cross-axis is left to right. Since I want to change the positioning on the left to right, so on the cross-axis, from center, which is the default, to start, I need to, well, target the cross-axis alignment here. So let's set cross-axis alignment to cross-axis alignment dot start, and this will move the items to the left. Now let's work on the text style of the title. So here's our title, and as you learned, you can add the style argument and instantiate a text style object to control the style of this text. There you can set the font size, let's say to 18, and the font weight here, maybe to font weight dot bold, just like we did it for the amount. That looks better. A little bit of a smaller font size, maybe 16. So that's looking good. For the date, I want to give this a gray color. So therefore, I'll give this a style as well. Text style, because in there, in this object, we can set a color property. And I'll set this to colors gray, like this. Okay. Now with that, our transaction items here are taking shape. Certainly not the final form in which I want to have them, but a good start. Let's now see with what we can continue. So throughout this course section, we worked a bit with columns, rows, and containers. And these are, as you probably can tell already, 3 very important widgets that Flutter offers you. And hence it's super important that you understand how container and column and row can work together and where they differ. Now, one important difference, of course, is that a container takes exactly one child widget, and the columns and rows, on the opposite, take multiple, an unlimited amount actually, of child widgets which you pass in that list of children. And that's, of course, a crucial difference. Another difference is that a container, unlike column and row, gives you rich alignment and styling options. As you saw, you can add a decoration with this separate box decoration object, where you can add a border, a color, you can add margin and padding to a container, you can align things in a container if you want to. On column and row, you also have alignment options on the cross and main axis, but you have no styling options. If you want to give a column a border, that's not possible with the column alone. Now, for the container, you also have a lot of options for the width. It's pretty flexible. By default, it takes the child width, but it also takes the available parent width if you have a parent with a fixed width. You can also give it its own width. You can set a width on the container and it will then take that. And there are different rules and there's a different order on how a container sizes itself. And in the official docs, you can read all about the exact order if you're interested in that. The core takeaway here is that you can really size the container, by the way, not just regarding its width, but also regarding its height as you want. For columns and rows, it's a bit different. There, by default, a column always takes the full available height and a row takes the full available width, but that's basically it. You have no extra options or arguments you can set on column and row to configure the width and height. And therefore, to sum it up, a container is perfect for custom styling, alignment, sizing. It's your go-to widget if you want to wrap another widget because you want to transform that other widget because you want to assign some styling. On the other hand, columns and rows are must-use widgets if you have widgets that should next or above each other. So if you have more than one widget in a row or, well, in a column, then there is no way around column and row, basically. The really important takeaway here, however, is not that you always have to choose one of these two, but that you can combine them together. Wrap a column in a container, or use a container in a column or in a row, of course, and you can then mix and match effects. You can have your own boxes with certain stylings inside of a column, or you wrap your overall column to, for example, add a border around it. That is all possible, so don't see containers and columns and rows as alternatives, but see them as crucial building blocks in Flutter that can be mixed and matched to build really flexible user interfaces. Now, obviously, there are other important widgets too. It's not just containers, columns, and rows, but these three widgets will actually be commonly used and will get you very far. With that, back to our application here. And before we continue working on the user interface, where we of course still have lots of work left to do, let me actually first work on the data we're outputting. With that, I mean this price here, which doesn't really look like a price. There is no dollar sign in front of it, for example. And I also mean the date. I want to change the formatting or the content of these two pieces of data which we're outputting here. Now for that, let's start with the price, with the amount we're outputting. And there, I have a special syntax, or I want to show you a special syntax you can use in Dart, not just in Flutter, to output values in a text or as a text. Right now, I'm outputting the amount here with the help of toString, and that is the perfectly fine way of doing that. And this is actually all we need if all we want to output is the amount value here as a string. But if I want to add a dollar sign in front of that, I actually can also concatenate this string together with another string. I can add dollar sign here and then add a plus to combine these two strings. And normally this would work. Here, however, Dart doesn't like this for some reason. Now let's first of all try an alternative which will work. If I add simply a colon for amount or whatever, so a colon and then a white space, and then I have the plus and then the amount to string, and I save this, then here we see a colon and the amount. Now that's nice, but I don't want to show a colon, but a dollar sign. So what's special about the dollar sign? For this, let's first of all understand how we could shorten this here. Concatenating strings like this with a plus is perfectly fine, but Dart actually has a more concise and shorter syntax for that. Instead of combining strings with a plus, which gets especially cumbersome if you have very long strings with a lot of different segments, you can use a special syntax where you use the dollar sign, which actually has a special meaning in Dart strings, which is why we had this error before. And after the dollar sign, you can reference a variable or a property name to output that here. So here we could type tx, and now it would try to inject the value of tx here in that place. So if we now save that and we go back, we see some strange error here on the right. That simply is shown because we're exceeding the boundaries here. Let's ignore it for now. More interesting is that we see instance of transaction. So indeed, we are outputting our transaction here, and instance of transaction is simply what you see when you call tx to string. And that's called for you here automatically. Now, the more interesting thing is that, of course, here I don't want to output my entire transaction, but my amount. And therefore, we can also use .amount here. However, if you are trying to inject or to interpolate, as it's called, more than just the variable itself, so if you use more than just the variable name, like here, where I also use the dot notation, then you have to wrap that expression which you're trying to interpolate into curly braces. So then you have dollar sign and then curly braces, and between the curly braces, you have your expression which should resolve to a string or to something where toString can be called on, which will then be called automatically by Dart, so that this string gets now added in this place here. So now if I actually remove tx amount to string here at the end, and I just have this syntax, if we now go back, we indeed see our amount here again, but now using a feature called string interpolation. And that's a very handy feature since this is obviously shorter than combining multiple pieces of text together with a plus. We also don't have to call toString here because Dart does this for us when we use this string interpolation syntax. Now that's all nice, but of course I wanted to add a $sign here and not a colon and a white space. However, the $sign, as you can tell, is a reserved character. The $sign to Dart means that you plan on interpolating some value. But what if you want the $sign as a character? Well, you can do something which we already did earlier when we wanted to output a quote. Then, you might remember, we added a backslash in front of it to escape it. So to tell Dart that this should not be treated as a language feature to close a string, but instead as a normal character. And you can do exactly the same with a $sign. If you don't want the special meaning it has to Dart, but you want the character $sign, then you add a backslash in front of it, and you simply add the $sign after the backslash. So now this $sign after the backslash here will just be output as text. This $sign here, however, since there is no backslash directly in front of it, will be treated as the beginning of a string interpolation. And with that, if we save this, we have the $sign in front of the amount. That was a lot of talking just to add a $sign, but the core takeaway, of course, is not just that you can escape it, but that it has a special meaning and that you can use it in string interpolation. So string interpolation is a really useful feature and something I will use throughout this course and which I would recommend using because it can save you some extra code. Now let's also format the date, however. And there, instead of just printing it as a string like this, which is relatively ugly, it's certainly human readable, but it's not really that beautiful. Instead of using that, I'd be more interested in actually having a nicely formatted date. And that can easily be achieved with the help of an extra package. That's correct. There is no built-in feature, neither in Dart nor in Flutter, that would make it easy for us to format this date. Obviously, we could always try to do it on our own. We could write our own code that takes this string and, for example, only extracts the date part here at the beginning. But writing that code on our own would be pretty cumbersome, and thankfully there is a package, a third-party package, which we can use. If you search for Dart date format, you will find this Intel package here. Click on it, and you should be taken here to a description of this package here on pub.dev. Now, pub.dev is an important page in the Dart and Flutter universe. It's a site, a web page, where you find a lot of packages you can install into your Dart projects. And we will actually use a lot of these packages throughout the course. For example, later also for things like HTTP requests or using Google Maps. So here on pub.dev, we're now on the page of the Intel package, and Intel stands for internationalization because this actually is a package that helps us with localizing our app. We could, for example, transform strings here to different text for the different locales we might be targeting, so the different languages we might be targeting. But for a start, we can also use this package to simply transform a date to the English locale, but there to a human readable string that is nicer than this string we have here. So for this, we need to install this package. And clicking on installing here, you get instructions on how to add it. It's super straightforward. You can just copy that part here, so the package name and the version number, and then go to your project and there to the pubspec.yaml file. Because the pubspec.yaml file is the file which in the end manages the setup of your project and most importantly the dependencies of your project. So which other packages can you use in this Dart project here? There we already have Flutter as a dependency, and below that, on the same level as Flutter, you can add Intel and the version number, so what you just copied. Now one important note, in .yaml files, indentation is very important. Indentation expresses how things are related. So it's important that you don't add Intel here on the same level as dependencies or on the same level as SDK or one space too far on the right. So you can hit space twice and you're on the same level as Flutter and it has to be on that level. Now if you save this file, Flutter should automatically go ahead thanks to the Flutter and Dart extensions which you have installed, and install that package on your machine and enable it in this project. Important, the source code for this package will not be stored in this project. It's stored somewhere else, typically in your user folder, but a connection is established in your project so that you can use this package. And now we can use it here in the main Dart file to output our date here as a more human readable text. For this, let's go back to the package page. You can check out the API reference here on the right to find the documentation for this package. And here you'll learn how to use it. And you can configure a lot there because, as I explained, you could use this package for actually translating your app or parts of your app, things like dates and numbers to different locales. But here you also find the basic syntax for formatting a date. And in the end, that is what we will use here. So in the main Dart file where I want to format the date, I first of all have to import this package. You always have to import something to use its features. So the package name here now is Intel, and there you want to import intel.dart. With that import added in the main Dart file, we can go down there where we have our date string, and now here we can use date format and build an object with the constructor here. This is a class that is now made available by the Intel package. And on that date format object, you can call format and pass a date into this. So now not a string, but a date. Conveniently, tx.date gives us a date. So let's just get rid of toString and add this, and format will then automatically return a string. That's exactly what we need here. With that, if you save it and you go back to your application, now you see this looks way better. We get this beautiful string here out of the box, thanks to this format package, or to this Intel package and the format method there. The thing just is, I only want the date. And you can actually define the pattern of the string that should be generated. There are two ways of doing that. For one, you can pass a pattern string here to date format. And now this has its own language for defining these patterns, and you can learn how to define these patterns in the official docs of the Intel package, which I just showed you a second ago. There you can, for example, enter things like y to indicate that you want to first print the year, and there you want to print it by including all 4 digits, then maybe a dash, then maybe the month, and then the day. And there is a difference between capital and lowercase characters, and again, the official docs of this Intel package and there the date format functionality show you all the different patterns you can use and the different meanings of the different characters. So if you would use that here, we, for example, get a date that is formatted like this. We have the dash between the year and the month and the day. Because I added the dash here, we could, of course, also use a slash instead. Only the characters here, so Y, M, and D, these are special values which are interpreted by the date format. What you put between these characters is basically up to you. So now we would have a slash in between. Now that's one thing. There also are a lot of pre-configured configurations, and these are all made available as special constructors. So you can also add a dot here after date format to access these special constructors, and there you have tons of constructors, as you can tell. Constructors for all kinds of stuff, like for example here, for a year, then a month in a written out form, and then a day. And if I use this here, I don't have to add a pattern because this pre-configures a pattern. And now we have this here as a date. And I will go with that. However, feel free to play around with that, choose different patterns, different formats, dive into the official docs, and fine-tune the date to your requirements and preferences. For the moment, and not for the entire app, but just for the moment, I'm done with the styling and the setup of the content. Of course, you can always tweak this to your requirements, and again, we will all change things later, but for the moment, I'm happy with these styles. I now want to focus on the next steps, which means that users should be able to add transactions here. And for that, we need some button that allows users to, well, start the process of adding a new transaction, open up some extra page or some extra input field where we can add a transaction. That would be pretty sweet. For that, let's go back to our code here. And first of all, I want to add an area where users can enter transaction data. Now we have our chart container, And below that, we have the column with all our transactions. Now, as a start, I want to make sure that this chart container and our transactions actually are ordered from top and bottom, which they are, but that they start at the beginning, that we don't have that space around setting. So let's go to the overall wrapping column here and change the main axis alignment to start, which is the default. Hence, we can comment this out. I'm using a shortcut here in my IDE. You can simply add 2 slashes in front of that if you want to. So now with that, we have all that content pushed up to the top. And now I want to add a new input area. For the moment, I'll add that input area below the chart. And that input area, in the end, will require a couple of different text inputs for the title, for the amount, and then also some input for the date. Now, since we need multiple widgets, what does this mean? We need a column or a row, because otherwise we can't have multiple widgets in the same part. Now, of course, we already are in a column. So here we could just add our text inputs. However, it would be nice to also have some styling around these text inputs, maybe a border, maybe a background color. And therefore here we could add a card to get some default styling, light rounded corners, also some background color. And then in there, as a child, I want to have my text inputs. Now, as I said, this will be multiple text inputs, which should be all in that card. So since we will have multiple widgets in there, now we definitely need a column. You could use a row, but I think it makes more sense to have the text inputs sit on top of each other. Now, how do we create a text input though? There is a special widget in Flutter, the text field widget. Don't confuse it with the text widget. The text widget, which we're using down there, is responsible for outputting text. The text field widget is responsible for receiving user input. So we can add a text field widget here. And if I add, let's say, for the moment, 2 text field widgets here, and I save this, then indeed we see 2 lines here. So that's our card. The card is always a bit hard to see on the white background, but there is this card around it. We can maybe add some elevation here to increase the drop shadow. It's a bit easier to see. But most importantly, we see these 2 lines. That's the most important part here. So we have these 2 lines, and if I tap into a line here, indeed the soft keyboard should come up. If you're testing this on an iOS simulator, you might have to enable the soft keyboard in your toolbar at the top under the hardware item. So the soft keyboard comes up, and indeed we can enter text here. Thankfully, we can also enter it with our physical keyboard, which makes it easier to test this whilst we are developing. So that's pretty nice. We can enter this here. We can also close the soft keyboard here on Android. And therefore, we can enter text. However, at the moment, it's not clear which text should go into which text field. And of course, it would also be nice to have some spacing around the text fields so that they don't stretch the entire width of our card here. Also some spacing top and bottom. And in general, improve the layout, the styling, and also the information about our text fields. So to style this, as I said, it would be nice to have some spacing around our text fields. Now on a card itself, you can only define some margin, but no padding. So you can't define inner spacing between the card edges and the content of the card. The column also has no padding or margin argument, so we can't add spacing here. And you learned what you can do in this case, wrap it with a container. So here we can again use the refactoring tool to wrap the column here with a container. And with that wrapped here, you can add either a margin or a padding. Here it doesn't matter because we're now inside of the card. So margin around the container will add some spacing between the card and its content. And padding here will not add spacing between card and content because the content would be the container. But since we don't directly see the container, we would have some spacing between the card edge and then inside of the container between the container and our text fields. So both would work. And here I will go for padding and use edge insets all 10 to add a padding of 10 in all directions. So now we have some spacing and our text inputs don't stretch the entire width. We also have some spacing top and bottom. Now it would also be nice to have some labels on the text fields. And thankfully, you can of course also pass arguments to text field to configure that. If you hit Control Space, you see there are a lot of things you can set. Feel free to go through these options on your own. Things like autocorrect and autofocus should be pretty clear. Autocorrect enables autocorrection when the user enters text. Autofocus makes sure that this gets focused the moment it is focusable. You have more strange arguments like controller and so on, which we'll use later. You can change the cursor color, so that marker in the text fields once the user tapped in there, which color it has, which radius, which width it has. You can change the decoration, which will become important for us in a second. You can enable or disable it, so whether the user can tap in there and that keyboard comes up or not, and so on. As always, play around with these settings, dive into the official docs, and get a feeling for what's happening there. At the moment, for us, the most interesting part here is the decoration argument, where we can add an input decoration object by instantiating the input decoration class, which is provided by Flutter. And there you can, for example, control whether there is a border around our text field. By default, we have this bottom border here. You can add a counter that indicates how many characters were entered. You can handle different error styles, and these are also things I will come back to later in this course once we dive deeper into handling user input, adding validation, and so on. For now, we'll not do that. So for the moment, what the most interesting thing here is the label text, because that is that extra piece of text above the text field, which actually tells us what should be in the text field. Now, label text actually takes a string, not a text widget or any other widget, but just a string. And there we could enter title here to indicate that here, well, we want to have the title entered. Let me copy that and use the same setting for the second text field, but of course there I'm expecting the amount. With that saved, now we have these little titles above the text fields, which of course now help us a lot, because now we have a chance of understanding what should be entered here. Now we can enter content here, but we have no way of submitting it, of saving that as a new transaction. So as a next step, we should probably also, below the text fields, add a button. And here you could add a raised button or a flat button. I will go for a flat button here and give it a child, which should be a text widget here, where I want to say add transaction. You also need to add on pressed, and for the moment I'll set this to an empty anonymous function just so that the button is enabled, but right now it won't do anything. And for the color, for the text color, I will use purple. With it configured, if you go back, you see that add transaction button here below our text fields. Now I'd like to have that button sit on the right, and that's just a personal preference. And to achieve that, you can of course go to your column here and add cross-axis alignment start. And that will move it to the left actually. I mean end. That will move it to the right. Now that button is on the right. Now we have the button and we can press the button. Let's next make sure that we actually fetch the user input, save it somewhere, and when we click that button, we add a new transaction to our list of transactions, well, upon a button click. So having the button is good, but of course we want to actually add a new transaction when we press it. And for that, we first of all need to collect the user input. It's good that we have these text fields, but how can we get access to what the user entered? There are two ways of getting access. It's up to you which one you choose. It also depends on the complexity of the form you're building. The first way of getting access is that you simply save the user input with every keystroke, that you save it in a property. Now, for that, we need a property in which we can save it, and we can add it here to our widget, but keep in mind that this is a stateless widget. And what does this mean? It means that any data we have in there, like the transactions property, is immutable. We can't change it. Well, technically we can change it, but our changes will never be reflected on the user interface. Now, actually here, that wouldn't be a problem, because with every keystroke, we could save the data the user entered, and then only do something once we hit a button. So it's actually okay if we just save these changes without updating the user interface, because there is no update we want to perform with every keystroke. We just want to save the data behind the scenes. And we can do that because a stateless widget is still an object, still a normal class, so we can have properties in there which we can change. We just can't rerun the build method. We can't use setState here. But again, that won't be needed. So what you can do therefore is you can add new properties here to your class. Maybe a string title input and another string amount input. That's, by the way, important. The input values are always strings by default. If you need a different value, like a number here for the amount, then you need to convert it manually. So we have these two strings. And now if we go down to our text fields, there you can add the onChanged listener. Now onChanged will fire with every keystroke. As you see, you have a couple of other listeners too. onEditingComplete is fired when the user presses the done, go, or next, or whatever it is button in the soft keyboard. So that would basically be that button in the bottom right corner. That can have a different look and meaning, and you can configure that actually. By the way, you can ignore this here for now, this strange yellow thing here. So that is onEditingComplete. It's fired when that button is pressed. OnSubmitted is kind of related, but this fires whenever the done button is pressed. So not on every button in the bottom right corner basically, but only for that done button. And if you configured your text field to show a different button there, then it would not fire. And onTap is fired whenever you tap into the text field. Now here we need onChanged because onChanged fires for every keystroke. OnChanged then requires us to pass a reference, a pointer at a function, which takes a string value. So not a function that has no arguments, but a function that accepts exactly one argument, which is of type string, and that then returns nothing. You can use a named function here, or you define an anonymous function. However, as I just explained, it needs to be a function which takes a value. You don't need to add the type here because Dart is smart enough to infer this, because onChanged expects a function that takes a string argument. Dart automatically understands that value here will be of type string. You also don't have to name this value. You can name it val, whatever you want. So now we get this, we have this function. It will be triggered for every keystroke. And then in here, since we're editing the title here, we can set title input equal to val. So that means we overwrite the current value of title input with the input the user chose here. So with the current input of that text input, of the text field. We can do the same for the amount, add onChanged, here get the value, and then we can also use that shorter notation with the arrow because we have only one expression. There we can set amount input equal to val. With that, we have a setup where we register every keystroke, and now we save that in our title input and in the amount input. Again, the UI won't be updated because we're not calling setState, and we couldn't call it because we're in a stateless widget, but that's not required here. To prove that it worked here, when we press that add transaction button, I will print the title input, so the value we stored in there, and also the amount input. Let's save all of that. And again, you can ignore this yellow-black thing here at the bottom. I will explain what's up with that later. And for the moment, we can enter some amount here, like 12.99. And here we can enter a title like test. And you could use your physical keyboard for this too. If you then hit add transaction, you see test and 12.99 output here because these values were saved with every keystroke, and therefore we can also use them. The only thing we can't do right now is update our user interface based on that. Registering the input on every keystroke is perfectly fine. However, here, Flutter actually complains or gives us a warning that this myHomepage class, which is marked as immutable, that's basically a flag the stateless widget sets, has a field, a property which changes or which is not final. And that's true. Title input and amount input are not final. They can change. And actually, the case we have here is a pretty niche case. Normally, you don't have changeable properties in a stateless widget because you can't update the UI based on these changes anyways. This is one of the rare cases where we save some data and where we are perfectly fine with that having no direct impact on the user interface. Still, you might consider using a stateful widget here to get rid of that extra warning and to avoid using or writing suboptimal code. Though technically this would work here and it also wouldn't be a horrible mistake. Now, we'll have a problem anyways. I of course don't just want to print my results here. I want to create a new element or a new transaction, and that in the end should then also lead to some output on the screen, because transactions, our list here, should then actually change and hold that new transaction. So we'll have to switch to a stateful widget at some point anyways. Before we do so, however, let me first of all show you an alternative to registering this manually on every keystroke. Whilst you can do this, and whilst this is especially useful if you have more complex logic that you maybe want to run on every keystroke, Flutter actually has a built-in mechanism that allows you to listen to every keystroke and then get the finished value once you're done. For that, I'll comment out the title input and amount input, and I'll add two new properties which now are final. And that is the title controller, which is created with a value of text editing controller. And it's the amount controller, which is also a text editing controller. Text editing controller is a class provided by Flutter, and you can assign such a controller to your text fields with the help of the controller argument. So now to the title text field, I add my title controller. And to the amount text field here, I'll add my amount controller. Now, what do these controllers do? Flutter automatically connects the controllers with our text fields, and these controllers in the end listen to the user input and save the user input. And therefore here in onPressed, we can then print title controller.text to get access to that saved text. Hence now if I go back and I type something here and I hit done, and I then add transaction, I see test here. So this is of course a more convenient way because you don't have to manually write a function that takes a value and just saves it in a property. And in addition, as an extra benefit, this is now also a solution because these properties are final and the heavy lifting of saving stuff is done by Flutter. This is now a solution Flutter also likes in a stateless widget. Nonetheless, the days of us using a stateless widget, or at least of only using stateless widgets, are coming to an end because we will have to change this to a stateful widget in order to update our list of transactions and reflect that change on the user interface, where of course for every new transaction, a new transaction card should be output down there. Let's add a stateful widget. Now, which widget should be stateful? Right now we only have one widget, the widget in our main file. We could turn this into a stateful widget, but that would have at least two disadvantages, which are kind of connected. For one, it's already a pretty large widget. We have a pretty complex widget tree in there. And it is a good practice and good idea to split your large widgets into smaller widgets. That makes it easier to read them, to work on them, to maintain them. And also from a performance perspective, as soon as you start having stateful widgets that also rebuild when you change something, you should split your app so that you don't rebuild your entire widget tree just because a transaction changed. For example here, the part where we handle the user input, that is where we get the data for the new transaction. But of course, this box up here doesn't change just because we added a new transaction. In this box, we don't show the new transaction. So there is no need to repaint this with every new transaction we added, or with every change in the transactions list in general. So it would make sense to kind of have that list of transactions in a separate widget. And therefore, let's create a new file here, which I'll name transaction list.dart. Now, in addition, I now also wanted to make it really clear which files here are widgets and which files are normal classes. for example, the transaction Dart file is a normal class. It's not a widget at all. This here, the transaction class, serves as a model for our data. Therefore, here I'll create a new folder, models, and move the transaction Dart file in there. And if we had more models, if we had different types of data, different custom types, we would also add them here. In the main Dart file, I now also have to adjust my import here and import from ./models/transaction Dart because I moved that file in there. Now the transaction list on the other end is a widget, and therefore I'll also create a new subfolder, widgets. Now here I'll move the transaction list Dart file into the widgets folder. Now of course right now it might look a bit overkill to have two folders for only two files. But the more widgets we add, the more sense the separation makes, because it's then way easier for us to find out what's a widget and what's a model. So in the transaction list file here, I want to create a new state full widget now. And for this, I'll use the shortcut here, this little snippet the Flutter extension gives me in Visual Studio Code, to scaffold out a stateful widget. It automatically creates the widget class and the state class, and it places a couple of markers where you can now type the name, and it inserts the name in all the places that need it. So here I'll name this transaction list using this Pascal case naming convention of having uppercase starting characters for the words, but having only one word altogether. Now in here, I need to import material.dart from the Flutter package because we're using stateful widget, which is exposed by that package. Also state is coming from there, and of course build context, the widget type, and the container type here. And with all of that, we have our base widget set up. Now in here, I want to manage my list of transactions. So with that, I mean my list of transaction objects. In here, we can therefore add a final list of transactions. And for that, make sure you add an import to your transaction model with /models transactions, because we need to go up one level. We're in the widgets folder. Tells Dart to go up one level, so out of the widgets folder, and then it looks for a new folder, models, which then exists in that lib folder in which we then are, and there in the models folder, it gets access to the transaction or Dart file. So then we have a list of transactions here, and I'll name this user transactions, any name you want. And initially, I'll have the transactions in here, which we previously had in the main Dart file. So let's grab these two transaction objects here, cut them in the main Dart file, and move them into the transaction list, like this. So now we have these two dummy transactions here to start with. By the way, if you're wondering why this is final, we will still be able to edit this list, as you will see. And I will come back to why this works and how it works in a second. So now we have these two transactions in here. Now in the build method here, I of course want to build that list of transaction widgets. In the main Dart file, I can get rid of that transaction list and also get rid of that import here from the models folder, of course. And if we scroll down to that error, which my IDE displays, this is the part where I output the list of transactions. This is the part which we can grab now, this entire column here, cut it out of the main Dart file and of our widget there, and add it instead as the return value in our transaction list here. Now in there, I'm accessing date format, and date format, on the other hand, requires us to import the Intel package. So we can remove that import from the main Dart file and add it here in the transaction list Dart file so that we can format the date. And transactions, that's the wrong property name. Here I renamed it to _user transactions, should be the name. So _user transactions, so let's use this here. Now we have the transactions managed in here, but now we'll face a new problem. We're adding transactions from inside our card here with the text fields, and that card is actually a sibling to our transaction list widget, which we would add here. So add transaction list here next to the card. That's why these ending annotations, which the Flutter extension adds, are really useful. So next to the card where you have your text fields. And of course, to use the transaction list widget here, you have to import it from /widgets transaction _list.dart. But as I just said, we now have a problem because in transaction list, we have our, list of transactions. And this list should change. But the change is triggered by our text fields, which reside in the main Dart file. So what can we do about that? Well, in the end, we have to do something which is called lifting state up, which means the common denominator of our text field card here and of the transaction list, so the one widget where we use them both, is of course still our My Homepage widget here. So there actually is no way around managing our state, our transactions in here, because we need to add a new transaction to that list from inside our text fields here, or with the help of our text fields. And then we need to pass that down to the transaction list, which is nice for outputting our transactions, but bad for managing them, because if we manage our transactions here in transaction list, then we have no way of accessing the user transactions list here from outside of that transaction list widget. The problem just is our text fields here are not inside of the transaction list. So of course we could alternatively also take that card with all the text fields and add it to our transaction list. That would work, but I actually prefer a different approach. Let's add two new widgets. One for our text input area here, so for the card with the text fields, simply to make that main widget tree a bit leaner. And second, let's then put our text input widget, which we'll create, and that transaction list widget, let's put that together into a new third widget, which we then use here in the main widget, in the My Homepage widget. The advantage of this will be that the My Homepage widget can stay stateless, and things like the scaffold and the app bar aren't rebuilt just because we added a new transaction, because these things really are not affected by a new transaction. The parts that do need to interact with a new transaction, so our text input card here and the transaction list, will then live in a separate widget. So let's add two new widgets, as I just said. One is the new _ transaction Dart file, which will hold our text fields. And one is the user _ transactions.dart file. In the new transaction.dart file, I'll create a stateless widget, which I'll call new transaction. And in here, as in all your widget files, you need to import material Dart so that you unlock stateless widget and so on. Now let's go back to the main Dart file and grab that card with all the text fields in there. So this entire card here, grab it, cut it, remove it from the main Dart file, and return it here in the new transaction file. Now we have the amount and the title controller in here, so let's add that. Let's add these properties in the new transaction widget. The title controller is a text editing controller, so instantiate that and store it in a final property. And the same for the amount controller. That's the exact same step we did in the main file earlier. So now this works. Now in the main Dart file, we can simply use our new transaction widget here, instantiate it, and add an import at the top. Again, my IDE automatically added one, and whilst this would work, the recommended syntax actually is to use this relative import syntax with /widgets new transaction in this case. And now we have a leaner main Dart file. Now to avoid having to manage the state in here for these two widgets, where actually at the moment My Homepage is the common denominator, to avoid having to manage them here, we have that new user transactions file here. That will now hold a stateful widget named user transactions, where as always you have to import material.dart. And now here I actually want to use my new transaction and my transaction list widget. So the goal here is to return a simple column with these two widgets. Actually, basically what we have here, a column with these two widgets. So you can cut the two widgets here from main Dart file, and therefore also of course get rid of these import statements there. And instead in the user transactions file, return a column, because we want to have two widgets sit on top of each other, hence we need a column. And in that column, add these two widgets, and of course also add the imports. So import /new transaction Dart and import /transaction list.dart. Now we can manage our list of transactions here in the user transactions state. So in the transaction list start file, we actually don't need a stateful widget. Instead, let's use a stateless widget here. And that means we can get rid of this part of the create state method here, and then also of our state class. Cut that list of transactions here. Leave the build method in here, of course, we still need that. But now go to the user transactions file and there to the user transaction state and add that underscore user transactions property there. Here I'm also using the transaction type, my transaction model. So we have to go out of the widgets folder to the models folder and then import my transaction Dart file here. Now we're almost there, but now we need to pass user transactions to the transaction list widget here. And you'll learn how that works. So feel free to do it on your own. We'll do that and a couple of other things in the next lecture. To receive our transactions in the transaction list file, in the transaction list widget here, we can first of all add a new final property here, which is a list of transactions. So this doesn't change, which I'll name transactions. Of course, you can use a different name here. So we have that final list of transactions, and that should be set with the help of the constructor now, because the constructor is how you can pass data from the parent widget into a child widget, so into this widget here. For that, I'll use the shortcut and expect to get the transactions as my first and only positional argument. So now incoming transactions are saved here, and instead of underscore user transactions, we again now use just transactions here, referring to this list. Now in user transactions, where I do instantiate the transaction list widget, we now have to pass our list of transactions, and that here simply is underscore user transactions. So thus far, we just did a lot of reorganization without actually getting closer to the point where we can add a new transaction. But this will change now. Now in the user transaction file, where we manage our list of transactions, we can add a new method. A method that doesn't need to return anything and therefore will have a return type of void, and which I will then name add new transaction. The name is up to you, though it should start with an underscore to mark this as part or as private and as part of that private class here. In here, I expect to get two pieces of information. I expect to get my title, which will be a string, and I expect to get my amount, which actually should not be a string, but a double, let's say. So here I get my title and my amount, and I then want to create a new transaction here. So I'll create a new variable, which I'll call new tx maybe. It's final because here I created with the values that are passed into this method. So it is create based on values which I don't know at the point of time I'm writing the code. Hence const can't be used here. But I can use final because once that transaction has been created with these dynamic values, it will not change again. So here I will create a new transaction by using the transaction constructor. And for my title, I pass the title. Now to avoid confusion, I'll name this tx title here. You don't have to rename it. You can use the same argument name here as you expect here. But to avoid confusion on what's what, tx title is what I pass as a value because I get it here as an input to this method, and I pass this as a value for the named title argument on my transaction constructor. For the amount argument, I pass tx amount. Again, you could have named tx title just title and tx amount just amount. That would have been okay. Now we also need to pass an ID and a date. For the moment, we have no way of selecting the date. We have no date picker the user could use. So why don't we again use datetime now to use the current date. And now for the ID, I want to have a value which is kind of generated automatically and unique. And therefore, I'll also use datetime now to string here. It's not perfectly unique. Theoretically, we could add two transactions at the exact same timestamp. But here for this app, it will do for now. And it will be a string, and it is generated automatically, so we can treat this as a kind of unique ID for now. This is the new transaction, and this new transaction should now be added to the user transactions list. For that, since I also want to update the user interface, because build should run again to rebuild our transaction list, and then also rebuild new transaction, that's the side effect. Since I want to update that, I have to call setState now, which I can call because we're inside of a state class, extending state. So we can call setState in here. And inside of that function you pass to setState, I will use my user transactions, which is that property up here. And now I want to add a new transaction. Now, of course, that is marked as final. But remember what I explained earlier when we talked about final and const. I mentioned that Dart stores objects in memory and only stores the pointer at these objects, the address in your variables. So underscore user transactions holds a pointer at this list. The pointer, the address itself, is final. We can't do user transactions equals something. That would not be allowed, because then we would try to assign a new value to user transactions, and user transactions is a final variable. What we can do, however, is we can interact with that list, because that doesn't change the pointer. The object stays the same. We just manipulate the object. And that can be done with the help of add. Add is a method we can call on a list to add a new element to that list. And that will change the existing list, but it will not generate a new pointer or a new address. And therefore, we don't violate this being final. We just added the object that's stored in this final variable. So here I add a value, and that value, of course, is my new transaction. Now, thanks to setState, that should be reflected on the user interface, and a new transaction should be added to our list. To now see that all come together, let's go back to the main Dart file, and there, let's now add our user transactions widget on which we worked below our chart container here. And for that, as always, you need to add an import, which should be /widgets user transaction start. Then that's added here below the container. Now, last but not least, we have to make sure that when a user now presses this button, the add transaction button, we don't just print the text of that transaction, but that we actually trigger that add transaction, that add new transaction function in user transactions. Here's your chance to wire that up on your own. We'll of course do it together in the next lecture. Were you successful? Let's wire it up together. And for this, let's go to the new transaction file. And here for onPressed, I now want to call that add new transaction method. The problem just is this method is a private method in a private class in a different file. So there is no way how we can access it directly. Well, actually, there is a way. Remember that this in the end also just creates a pointer at this function here in the end. We can pass that pointer down to new transaction. So here to new transaction, I can pass add new transaction. So I can pass basically that function pointer here by the name. Without adding parentheses, if we would add parentheses, we would immediately execute this when Dart parses this line. Without parentheses, we just pass down the pointer. Now in new transaction, we need to accept that pointer. So here I'll add a new final property, which is of type function, which I'll name addTX or whatever you want to name it. And that should be set with the help of the constructor of new transaction, because we're passing something to the constructor here in user transactions, and therefore we should provide such a constructor here in new transaction. So add new transaction and bind whatever you get to addTX. So not whatever you get, of course we know that what we get will be a pointer at a function, and we bind that pointer into the addTX variable here. Since addTX holds a pointer at a function, we can now execute it like a function here in onPressed. We can execute addTX, and now here we need to pass the value for our title and also the value for our amount. So here I'll pass title controller.text and also amount controller.text. Now here's one tiny issue. Text here always returns as a string, but actually in our add new transaction method here, we expect the amount to be a double. Now to convert that string to a double, you can go to new transaction and actually use double.parse. And this will take a string and convert it to a double. Now important, if you entered text that can't be converted, something like hello, then this will throw an error and your app will break. So in reality, you might want to also provide some logic that would handle such an error. But since we haven't learned that yet and it's not that important right now, we'll handle errors later. For now, be aware that you have to enter a valid number here, otherwise this will break. Now with that, everything is wired up. If we save this and we go back, that's looking good. And now let's give this a try, enter test here. And here, as I said, enter a number. Also important, that number needs to use a dot as a decimal place. And now hit add transaction, and you see it gets added here, which is of course pretty sweet. And of course we can add as many transactions here as we want. We can press this button over and over again. At some point, however, we'll face a problem. If I enter more and more here, you see now we have that warning, which we saw before already, this yellow-black thing here. We now already see that even without the keyboard opened. So we should finally tackle what the issue here is. And to give you a hint, it's related to another problem. We can't scroll this list. There is no way we can see the new transaction we added at the bottom. And that's not a bug, that's a default behavior, which we can easily fix, and we will fix it in the next lecture. So what's causing this issue here? Which we also kind of saw when we added that keyboard. There we also have this strange warning. The problem is that this content is not scrollable. Let's understand how a column, and by the way also a row, works by default. A column takes the full available height, a row the full available width. But with that, of course, I mean the height on the screen, not an infinite amount of height. It doesn't automatically add a scrolling functionality. That means that a column tries to squeeze all children it has into itself. But if the child widgets have their own heights, like this one has, we define the height of a single transaction by the height of this box bar or font size and so on. So if these have a height which the column can't shrink, then at some point of time, the child widgets won't fit into the column anymore. And then we need a solution, and the solution is to add scrolling to the column. And you can also add scrolling to a row. The fix is to go to our main Dart file and wrap the overall column that holds all our content on the page in a new widget. Now here is no predefined snippet for that, but we can wrap it with a new widget. And the widget we want to use here is a single child scroll view. Now this adds some scrolling functionality to this column, which otherwise can't be scrolled. And therefore now, you already see that we get no error here anymore when I open the keyboard, which is good. Now if I add a couple of transactions here real quick, so that we have too many transactions to squeeze them all into one column, then you see I can now scroll, because single child scroll view adds scrolling functionality. Now here's one important note. You have to add the single child scroll view on this level here, so as the body element itself. It wouldn't work if you add single child scroll view only around user transactions or only inside of the transaction list here, let's say around this column. This would not work like this because the single child scroll view then wouldn't be able to set up scrolling correctly. It basically wouldn't be able to identify the container height in which it should scroll. What you can do, however, is you can not use single child scroll view here in the main Dart file. So remove that and remove that extra parentheses. And instead in transaction list, you can wrap it with a container, which you give a clearly defined height. And important here is that you choose a height that does fit on the screen, like maybe 300. Let's see. Yeah, I'm not getting any warnings here. For example, if I chose 500 here, I would get an error here. And of course, the available height depends on the device size. We'll later also have a look at how you can find out how much space is available. But here on my emulator, just because I want to show this, if I work with 300 here, now we have a clearly defined container into which this column may go. So now the column does not size itself after the amount of space it needs for its children. Instead, it knows how much space it can take, 300 pixels. And now you can wrap the column here with a single child scroll view. And that single child scroll view now also knows that it must scroll inside of this 300 pixels box. So now here, we still get that warning, however, because I removed the overall scroll view on the entire page, which means that when the soft keyboard enters the page doesn't know where to go. But now we can scroll into that sublist down there. Now this can also be a useful pattern, but in our app here, we definitely also need the scrolling on the entire list, because we otherwise get that problem here where our soft keyboard actually pushes the page up a bit, and that then leads to exceeded page boundaries. By the way, in detail what's happening here is that Flutter tries to always scroll the input, which we're editing, into view, and therefore it insets the page by the height of that text field, so that that text input can never be below that soft keyboard. It's not the case here, but it could be below the soft keyboard on smaller devices. That's why the height of that text field is always added as a padding above the soft keyboard, and that's exactly the problem we have here. That height is added here, but since the page can't scroll away, we try to add height on a page that's already fully occupied with content. So that's the problem we have here, and to avoid that, we definitely have to wrap our overall column here with a single scroll view. So there is no way around that. So here we have the single child scroll view around our overall column, and now the entire page is scrollable, which leads to no visual difference when that keyboard opens up, but technically there is a difference, and we can see that, by the way, if we rotate the device. Now if I tap in here, you see that this gets scrolled up a bit by Flutter to make room for the keyboard, and that is exactly what happens when we have a scroll view and what's not possible if we don't have one. It's a convenience feature by Flutter so that we can always reach our text input and see what we're entering, but it only works if the page is scrollable for pages that are packed with content or on smaller devices. Well, in our list of transactions here also is scrollable, because here we still have our separate container with a single child scroll view, which of course is something you could now also delete again, but you can also leave it here. Instead of having our column with that single child scroll view, there is another widget baked into Flutter that we can use to ensure that we automatically have a scrollable column or row, because it's such a common pattern that you need multiple widgets next to each other or on top of each other or above each other, and that list should be scrollable, and a column and a row by default is not scrollable. So of course you could always wrap your columns and rows with single child scroll view, but as I said, Flutter has a shortcut here. Instead of manually adding that single child scroll view, let's get rid of it here in the transaction list widget. And instead of that, let's use, instead of the column, a list view widget. List view is a widget provided by Flutter, which is the end, by default, a column with a single child scroll view, you could say. On the list view, you can set a bunch of things. Most of them are relatively advanced and rarely needed, but you can also set a scroll direction in case you need a row instead of a column, a scrollable row. With that, if you save it, now we'll have the same behavior as before, as I can quickly prove if I enter items here. This is a scrollable list in that container which we defined here. Now, also important, if I remove that container here in my transaction list widget, now you see no transactions are shown, and we actually get an error here. It's a pretty long error message, and it can be complicated to read. In the end, the problem is that the vertical viewport was given an unbounded height. And this might sound cryptic, but what it means is that list view is in the end a widget which, yes, is a column with a scroll view, but what it means in the end is that a list view is basically a widget that has an infinite height. Unlike a column which takes all the height it can get on the given screen, a list view does not have a fixed height. It can't have a fixed height because it's scrollable. There are items that are currently not on the screen, and therefore the height where all the items have to fit in the end has to be infinite, because it has to be larger than just the screen size. Otherwise, the items that are there and just aren't on the screen at the moment wouldn't be there, right? So there are items below the screen or above the screen, depending on where you scrolled, and these items are also part of the list view. Therefore, its height is higher than the screen height. It's actually infinite. The problem with an infinite height just is, if you throw it into your page like this, Flutter doesn't know how to size that list view. Of course, to you as a human, it's obvious. It should take the remaining space here, right? But that's not how Flutter works. It needs clearer instructions than that. So you need to give it some constraints, some settings on how much height it should take. And previously, with that container, we had that. If you have a container around your list view, you have exactly that kind of constraint you need. You're telling Flutter, add that list view, please. And Flutter has a look at its parent, and it finds out, oh, my parent has a height of 300. Okay, I will take 300 as a height for the list view. Without that container, the parent here of the list view is, since we use transaction list here in user transactions, is in the end that column. And a column by default takes all the height it can get. So the problem with that, of course, is if we have something that takes all the height it can get, and then we have something that has an infinite height, if we combine these two, we have a problem, because as much as I can get and I know no limits is a bad combination. So here we need some wrapper that defines a height so that Flutter knows how big that list view actually should be, how high it should be in this case. But with that, using a list view is the better alternative to using a column with a single child scroll view because, well, it's in the end shorter. And in addition, you get a couple of other optimizations and improvements which the list view has baked in. We learned about the list view. There are actually two kinds of list views, or two ways of using it, I should say. The list view widget can be used as we used it by passing a children argument to its constructor, and then you have a list of child widgets. The alternative way of using the list view is to use the builder constructor it offers you. So that's an extra constructor on the list view class, which also gives you a list view, but a list view that works differently. Now let's first of all have a look at the left case. There we have our child widgets, and as you learned, a list view in the end is like a column with a single child scroll view around it. And therefore it's able to have more items than we have space on the screen because it has an infinite height or width. The list view builder generally works similarly, but there we have no wrapping single child scroll view in that sense. But instead, here we have some optimizations put in place by Flutter. To be precise, the list view builder in the end only renders the widgets that are visible. And that's a difference to the scenario on the left here. With list view, where you pass your children as an argument, all widgets that are part of the list view are rendered, even if they're off screen. Now, for short lists, that's no problem, but for very large lists, that means that you consume a lot of memory, a lot of performance for items that aren't even visible. And if you then scroll such a long list, you can have lags and bad performance because Flutter needs to manage all these items in memory, even though you might not be seeing them right now. You can't interact with them right now. Still, Flutter needs to maintain them all in memory. The idea with the list view builder is that Flutter actually gets rid of all the items which are currently not visible and only shows you what's visible. So the parts that are not on the screen are not loaded or not rendered, to be precise. And this therefore is the solution and the approach you should use for very long lists or for lists where you don't know how many items will be on it, so that for longer lists you don't run into performance issues and lags. Now, it is worth noting that the list view builder, of course, has a certain threshold, so it doesn't instantly remove every item that's not on the screen anymore. It waits until this is a little distance away, so until you scrolled a bit before it actually removes that. And the list view on the left here, where you pass children, will actually also get rid of elements that are outside of the current viewport or beyond a certain threshold. But unlike List View Builder on the right, it has less optimizations in place. And unlike List View Builder, it actually does create all items that are in it initially and does not create them lazily when they're needed, but instead it just has a limited amount of optimization. So you don't want to use that for very long lists or lists where you don't know in advance how many items you'll have, and potentially you might have a lot. In such cases, you might want to use List View Builder instead to improve performance. So let's have a look at that List View Builder then. We can easily transform our existing list to such a dynamically loaded and rendered list by using List View Builder instead of List View, but now we need to pass different arguments here. The builder method requires an item builder argument. That's a must-have. You must provide the item builder. Now, item builder, in turn, takes a function that will give us a context. We get that automatically. Flutter manages that for us. Context is this meta object with which we haven't really worked thus far, which holds information about the position of the widget in the widget tree. And int, it gives us a number of type int. And that actually will be the index of the item we're currently building. But step by step, item builder takes a function. So you need to provide a function here, either a named function or, as I'm doing it here, an anonymous function. Then this function, as I just mentioned, receives a context, and I will name this CTX. You can give this any name you want, but the value of this argument will be build context. Because this function here is not called by you, so it's not your job to provide these arguments. It's called by Flutter, because it calls this builder function here for every new item it wants to render on the screen, for every new list item in the end. And it gives us a context, which we don't need here, but still we get it. And it gives us an index of that item. So is it the first item, the second item, the third item of the items it should render? That's what we get here. Now, what you can't provide to the builder constructor is your children thing here. Instead, what you need to provide is the item count argument. And that defines how many items should be built. In our case here, that would be the length of our transactions list. If we have 2 transactions, we want to build 2 items, right? So we pass transactions.length, which gives us the number of items in our transactions list. Now Flutter knows that it should execute this function here twice if we have 2 items, or as often as we have items in transactions. And now in here, we have to return a widget that is built for this item we're currently looking at. So a widget that is built for the first item, for the second item, and the third item, and so on. The item I want to build here, of course, is my card here. So I can actually grab this entire return statement here, all the way up here, and replace this return statement with it, so that I return my card inside of that builder method here. The problem now just is, in there, I previously got my transaction, because previously we mapped our list of transactions to a list of widgets. This approach does now not work anymore, because now the builder instead simply takes a number of items, not the list itself, just a number of items, and then repeats this function here, this builder function, for every item. In order to now get access to the different transactions, we can simply replace tx here with transactions, which is our overall transactions list. And there, with the square bracket syntax, we can access a specific index. And here, it's convenient, and of course, not a surprise and not happening by accident, that Flutter gives us the index as a second argument in this function it calls for the item it tries to create. So it gives us 0 for the first element it tries to create, 1 for the second element, and so on. And therefore, we can use this index here to access the first transaction, the second transaction, and so on, depending on which item is getting built. And this is all managed by Flutter. So now we use transactions index instead of tx here. And with that, if we save this, we got our transactions here, but now built with the help of the builder. And that, of course, is pretty nice, because now, here, of course, we don't really see that or feel that, but now we have a list that also has a great performance for a lot of items. So now this is the solution you should use for very long lists. For lists where you know how many items you have, and it'll only be 6 or 7, then using list view children is perfectly fine. But for long lists or lists where you don't know in advance how many items you'll have, consider using list view builder to get the best possible performance. So this is taking shape. We have our input area. We can add transactions like new shoes for $12. Now there are a couple of things I want to change though. For example, when I enter my amount here, it would be nice to have a keyboard where we can only enter numbers and where we can't even enter text here. In addition, it would be nice that when I hit this button here, this confirm button on my inputs, I do actually trigger add transaction if a value for title and for amount is provided. And last but not least here, when I output my amount, it would be nice to always see 2 digits. Not more than that and not less. Because right now I can also enter something like this. And of course that looks super ugly. So to fix or to change this, let's first of all go to new transaction Dart, which is where we have these inputs. And to make sure that we can only enter numbers on the second input here. And there you can change the keyboard type. And that takes a text input type, which in the end is a class. And there you have a couple of static properties again. Again, static properties on classes. That's a bit like enums, just having more complex values than just numbers. And there you can set this to datetime, which is a perfect input if user should enter date. Email address, which is great for entering email addresses because the @ sign is easily available, and so on. But here I want number. And with that, if we now save this, if I tap in here, we now get a number keyboard, which is of course good. In addition, to make sure that we also submit our form when we press the done button, we can add the on submitted listener here. Now I want to do the same as I do down here, so I can of course simply copy that function, but if you find yourself copying a lot of code, it's always a good idea to refactor it into a single named function, which you then can call from all these places, so that when you ever change something in that function, you don't have to change it in 3 different places, but only in one place. So let's grab this logic here, where we call add_tx, and let's add a new function here in our new transaction widget, a new method to be precise. It'll not return anything. I'll name it submit data. The name is up to you though. And in there, I will call add_tx and forward the title controller and the parsed amount. Now down there, I call submit data therefore, or I point at it without parentheses, because I don't want to execute it in line. I only want to pass a pointer at this method so that it is executed when the button is pressed. However, here on submitted actually gives us the value the user entered thus far as a value. So here we have to use a slightly different syntax, provide an anonymous function where we get that value. And I don't really use it, but still I need to accept it. Otherwise Flutter will complain. An alternative would have been to not use an anonymous function here, but accept that value up here. Then this would also be fine. You just need to have a function that in the end reacts to onSubmitted that does take that value even if you don't use it. But since I don't plan on using it, the approach I like more is to not take the argument up here, but instead use an anonymous function down there and add an underscore here, which is kind of a convention, not a hard rule, but a convention to signal I get an argument, but I don't care about it here. I have to accept it, but I don't plan on using it. So instead of giving it a more meaningful name, I add an underscore here to indicate, yeah, I don't use it. So now this is the code I can use for onSubmitted on all my, or on both of my text fields here. And also when the button is pressed down there, I want to call submit data. Another advantage of not accepting a value in submit data is that here for the button I wouldn't get one. So here I would have had to manually provide one by calling this with something like this if we edited submit data to accept a string. So that's why this approach of not accepting a string in submit data, but instead dumping the value here is preferable. So now we submit that whenever one of these buttons is pressed. Of course, the button could be pressed before both a title and an amount have been entered. So what I'll do first is I'll extract that data. Entered title is title controller.text. And here I'll have my entered amount, which is amount controller.text. And I'll do the double conversion right here already. So double parse. I'll call it here. Down there, I will therefore just refer to my entered title, and then here to the entered amount. But first of all, I want to check whether we do have values in here. So I'll add if entered title is empty, so if the user did not enter anything there, or if entered amount is smaller or equal to 0, which also would be invalid. I also don't want negative amounts. Then I'll just return here. And if I just return here, then this code will not execute, because return also stops the function execution. It means the code after return is not reached. That's also something important. Return stops the function execution. This code is not reached if this here is called. So if we make it into the if block, we'll not try to add a new transaction. So therefore here, if I hit add transaction with no values entered, I actually get an error because I try to, well, convert something to a double which is not convertible. But if I try to, for example, submit -1 here, and I hit add transaction, I don't get an extra error, but we also don't get the transaction. So stopping this works. The same is true if I enter a valid amount for my amount here, but not for my transaction. If I hit this done button or add transaction, this also doesn't get added. So our little dummy validation here works. Now with that little dummy validation added here, we can almost test this. One mistake I just spotted is, of course here, when I use this approach of using an anonymous function, here inside of that function body, we then have to call submit data like this. Otherwise, this will not execute, because now this anonymous function is passed as a reference to onSubmitted. The reference to this anonymous function, to be precise. Inside of that anonymous function, when it executes, we have to manually trigger our function. Only here for onPressed, where we don't have a wrapping anonymous function, we just pass the reference to our own function. And with that, if we save that, we go back to our page here. If I enter something valid here, but let's say I have -10 down there and I hit this button, you see it doesn't get added. But if I enter something valid here and I use this confirm button, it does get added. So now we can use this as well, and we have some basic validation in place. Now regarding the output of our prices here, for that we can go to our transaction list, which is where we do output all these transactions. And there for the transaction amount, in the end what I want to do here, on amount we can call toString, but I mentioned that we don't have to do that if we use this interpolation. But there is a special kind of toString. You can use toString as fixed and then define how many decimal places you want to show, for example 2. And if you use this, if you use toString as fixed 2, then every value has exactly 2 decimal places. No matter if you only entered 1 or none, or if you possibly entered a lot. Then you see this gets rounded. So this is really convenient to have a nice user interface where we don't have too long numbers or too short numbers. We spent a lot of time on our text inputs, on these transactions, and for the moment I'm quite happy with the result. Now as a next step, I want to make sure that this text input area here however, is not always visible, but instead, as we also planned it at the beginning of this section, it is shown when we press a button that's added here in our action bar, and a button here at the bottom, a so-called floating action button. And for that, we first of all need these buttons. So let's learn how to add buttons in the app bar or buttons on the overall page with the help of that floating action button feature. Let's start with the app bar. Here in main Dart, which is where I do render that app bar, on the app bar, you can add an actions argument, and that takes a list of widgets. Now, theoretically, of course, you can add any widget in here, text or whatever you want. Typically, however, you add buttons here though, or most typically, you add icon buttons. We haven't used that before. We worked with a raised button and we worked with the flat button. But there also is a, well, icon button. And the icon button does what the name suggests. It renders a button that only holds an icon. For that, we need to set the icon argument here. And the icon argument takes, let's have a look. It takes a widget, but actually it wants an icon widget. Icon is another widget built into Flutter. So icon is coming from Flutter, and it gives us a widget that in the end renders an icon. And it takes one positional argument, the icon data. So basically some information on which icon to show. And there we can use icons, which is a class provided by Flutter that gives us access to all the typical material icons. So here you can go through that list, and conveniently here you see a preview of the icon that's getting rendered. And here I'll use the add icon, which is simply a plus. Now on that icon here, you could also configure other things like the color of the icon or its size, but I'm happy with the default. And on the icon button, you can also configure other things. Most importantly, you need to provide onPressed, just as you do it on other buttons as well. For the moment, I'll set it to an empty anonymous function so that the button isn't disabled, but at the moment, of course, it also won't do anything useful. Here now we see that button, and you can of course remove the debug banner here with the help of the Dart DevTools, as you learned it in the debugging section, if it's annoying to you. I hope you can see the button here though. This is the button which, when we press it, should bring up a little modal, a bottom sheet here, sliding in from the bottom, which holds this text input area. And it's not just this button. I also want to have that floating action button. We add this also with the help of the scaffold. There, besides app bar and body, you can also add the floating action button argument. By the way, you don't have to add that below the body. It doesn't matter in which order you provide these named arguments. Floating action button wants a widget as a child, and typically that is a, well, floating action button, which is a button optimized to be used as a, well, floating action button. You could use any button though, but I will go with the floating action button. And here I will also provide my icon, an icon widget, by using icons add. So the icon widget here is a normal widget and therefore can be used as a child in the floating action button. And then here onPressed. For the moment, I'll not do anything. If we now go back, we have that floating action button here in the bottom right corner. You can also change the position of that floating action button here with another argument you pass to scaffold. You can add the floating action button location argument and set this to floating action button location dot, and then you have a couple of options like center float, for example. If you save this, it now floats in the bottom center, which is really nice. So now we have this button here as well. We have the button up here. Let's next make sure that when we press these buttons, they bring up that sheet, which in the end can hold that user input area here. To show a sheet, there is a built-in function Flutter offers us. That's good, to show such a bottom modal sheet, I should say. And since I want to show that sheet both when we click that floating action button and when we click that action in the app bar, I will create a method that opens up that sheet so that we can, well, share that method with both places where we want to trigger it. It will return nothing, that method, and I'll name it start add new transaction. The name might be a bit clunky, but in the end, that is what happens here. It doesn't add a new transaction, it starts the process of adding a new transaction. It starts the process by showing the input area for that new transaction data. So start add new transaction is the method name, and in there you can call show modal bottom sheet. It's a function provided by Flutter. That's why this function is available here. So this function can be called, and show modal bottom sheet now needs at least two arguments. The first is a value for the context, because internally this function will use this strange context object with which we haven't worked to show that modal sheet. So we need to pass a value for context here. The good thing is we get a value for context in here. We get it passed into the build function automatically by Flutter, but of course that's the wrong place. We need it up here. Solution is simple. We accept it as an argument here. And I'll name it CTX to avoid confusion with the names. So I forward my context, which I expect to get as an argument, to show modal bottom sheet for the context argument. And then we also need a builder. Builder now is a function that needs to return the widget that should be inside of that modal bottom sheet. The builder function itself also gives us a context, and I'll name this bctx to really make this clear that this is not the same value as this context. This is the context we pass to this function to pass it to the modal bottom sheet. The modal bottom sheet then starts building that sheet that slides in, and to that builder, it again gives us its own context, so its own package of meta information about that widget which it builds. We never use that context. Well, at least now we start using it here indirectly when we pass it to show modal bottom sheet. We get it here nonetheless in the builder in case that inside of the builder, where we now build the widget that should be part of the modal sheet, in case we needed access to the context object there, and you will later in this module learn why you, for example, need the context. So we get it here in case we need it, even though we don't. Since we don't use it, of course, you could use that underscore thing to indicate, I know that I get it, but I don't care. Inside of that builder function here, you now return something, and that something now is the widget you want to show inside of that modal sheet. And in my case, that, of course, should be that new transaction. So here I want to show new transaction. For that, I now need to import my own new transaction widget with that relative import part. And new transaction now has one disadvantage. It, of course, needs the add transaction function reference. And we outsourced that into user transactions because up until now, that was the perfect solution. We had new transaction and transaction list in there. We had our transaction list, so our list of objects in there. We had the add new transaction method in there, and all that was hidden away from our main Dart file. And now all of a sudden, because we have to trigger start add new transaction from in here in the main Dart file, because here is where we have the app bar and the floating action button, because we have to trigger that function from in here, we now have to bring new transaction back into that main Dart file. And since that needs the add transaction method, we now actually have to bring all our state logic into this file. So there is no way around it. Let's transform this stateless widget to a stateful widget. At least we can do that automatically with the help of the refactoring tool. If you click on it and then use the refactoring shortcut, you can choose convert to stateful widget here. You automatically get your state object. And now in there, I will basically grab my list of transactions and add new transaction from inside the user transactions widget, add it in the main Dart file, here below title controller and amount controller, which I, by the way, don't need there anymore. And now with the transactions and the add transaction method brought over, we need to import our transaction model to unlock that transaction class. So let's add this import here. And of course, now that means that our user transactions widget unfortunately is redundant. And that is also something you'll have in Flutter development, which is why I'm showing it here. You will sometimes build a solution which you then have to break up at some point because you recognize, okay, for this feature, I need to manage my state somewhere else. Otherwise, I can't pass data around. Later in this course, we'll learn about a more elegant state management solution, which avoids having solutions like this, where we have to lift state up to the common denominator. But for the moment, and for simple apps like this, it is fine, and we also won't have a performance problem if we use our main file for managing the state and for rebuilding everything on every change, therefore. We can get rid of the user transaction file, however. We don't need it anymore. And in main Dart, we hence now, instead of returning our user transactions, return our transaction list widget, pass our user transactions into it. User transactions is now managed here in the main Dart already in our my homepage state class. And the remaining thing we have to do, therefore, is that instead of importing user transactions, that's the widget I just deleted, we import the transaction list start file with the transaction list widget. Now with that restructuring, we can pass underscore add new transaction, so a pointer at this method, to new transaction here. And now we have a setup here where we just need to wire up this start add new transaction method, which now should be underscore start add new transaction because it's now part of that private state class, and therefore the convention is to make this a private method as well. Now we just have to use this method here and wire it up to our button in the action bar. So here, instead of doing nothing when we press this, we target start add new transaction. Now keep in mind that this requires the build context because it needs to forward that to show modal bottom sheet. So actually we need to call this as an anonymous function so that in here we can call it manually and forward context, which is this context value here. And now we do the exact same for our floating action button down here. And now with that, if you save that and maybe restart the app because we changed a lot, typically the app needs to be restarted thereafter. If you do that, now if you press the plus up there, you see that this action sheet floats in. The same for the floating action bar at the bottom. And that's a default feature you get. You can also click the background to close it. You can also click the action sheet itself to close it. That should eventually change in the future. Until this changes, you can easily fix that by wrapping your new transaction in show modal bottom sheet with a gesture detector, which is another widget I mentioned earlier on a slide, which takes a child, in this case our new transaction, and where you can register a certain gesture, in this case on tap, and simply do nothing when this gesture occurs. This catches this tapping on the bottom sheet and avoids that the sheet gets closed if you tap on the sheet. It still gets closed if you tap on the background, but not if you tap on the sheet. For this to work, you also need to set a behavior, and you need to set this to hit test behavior.opaque. This is important to catch the event and avoid that a tap here on this gesture detector, which itself is invisible, but which has the size of our new transaction widget, that a tap on that also then still triggers a tap on the underlying modal sheet. With this setting, you catch the tap event and avoid that it's handled by anyone else. And this avoids that the sheet closes when you tap on the sheet itself. Again, to my knowledge, this should change in the future, so maybe when you're viewing this, you don't need to add this detector anymore. Here you see now I avoid that this closes when I tap in here, which is of course what I want. I don't want to close the sheet when I tap in here. I want to close it, however, when I tap on the background. And that is what's happening. Our application at the moment has one problem. When I open that modal sheet and I try to enter something here, you see that this gets cleared. The title gets cleared as soon as I click into the amount. If I click into the amount, into the title now, the amount gets cleared. So something's wrong here. By the way, of course, our amount is also a bit overlapped by the keyboard if we enter something into the title. And that's something we'll fix later. Also, if you would rotate the device into landscape, you wouldn't really be able to work with that. But let's take care about this later once we learn how to build more responsive user interfaces. For the moment, let's fix that issue of our data getting lost when we, well, click into the other fields. The fix is simple. You need to change new transaction, so this widget which renders these inputs, from a stateless into a stateful widget. Even though we're not calling setState in here, that internally changes something for Flutter because the state object in the end is treated differently than a widget object. It's basically maintained and not rebuilt as often easily. And therefore you should convert new transaction here to a stateful widget. And thanks to this refactoring syntax, that all is done automatically. And now if you reload your application with that saved, if you now open that again, now here we can enter something, and now the data is kept, and we can add this and see our new transaction here, which is of course pretty convenient. Now internally here in new transaction, there's now also one important change. We still get add transaction as an argument here, and that's inside of our widget, right? Add transaction is a property in our widget, not in the state object, but in the widget. And it needs to be there because we need to define it, or we need to accept it on the constructor of the widget, not on the constructor of the state, because the state is constructed here with the help of createState, and that's inside of the widget. So to receive something, some data in the widget from outside, which is the case here, we receive a pointer at the addNewTransaction function, we need to accept it on the constructor of the widget. The problem is that I want to use this function from inside the state object thereafter, and not inside my widget, and these are two different classes technically. Thankfully, Flutter establishes a connection and gives us a special property inside of our state class. It gives us this widget property, and this refactoring step automatically added it. With widget dot, you can access the properties and methods of your widget class inside of your state class. So with widget.addTX, I can access the addTX property, which is this function reference I get, even though I'm technically in a different class. That's important. Widget, that is a special property we haven't seen before. It has to be named widget, and it's only available in your state classes and gives you access to the connected widget. And with that, we now also fix that issue of the bottom sheet clearing our inputs when we type in there. Now, another thing we can do is that when we enter a new transaction here, that we actually also close the bottom sheet as soon as we confirm it, and that we don't have to close it manually. And doing that is pretty straightforward. Here in submit data, after calling addTX, you can call navigator of context pop. Now that's something we haven't seen before. The navigator is also something I'll have a way closer look at in the navigation section of this course. It's built into Flutter and it can do a lot of awesome stuff. Here, we simply use its pop method to basically close the topmost screen that is displayed, and that is that modal sheet if it's opened. So that closes that modal sheet by popping it off, and more on that and what it does in detail in a later section. Of context here is required to get access to the right navigator or to give the navigator some metadata. And context here, just like widget, is a special property which is available class-wide in your state class here, even though you never defined a property named context. It's made available because we extend state. So it's basically like widget. It's a special property that is available and that in this case gives you access to the context of your widget. Widget gives you access to the class itself, to its properties and so on. Context gives you access to the context related to your widget. More on all of that later. With that, however, we now added the functionality that we can automatically close our bottom modal sheet once we're done. So if I now add my new shoes here, which let's say cost 99.99, now you see that also closes the modal sheet. With that, let's continue with our app and let's again turn our heads towards styling. Regarding the styling, right now our app doesn't really have a uniform style. We have the blue app bar, we have the blue chart placeholder, the blue fab here, the floating action button, and then the purple custom style here. And in general, thus far, when we wanted to style something, like here in transaction list, when I want to style the color of my amount, of the border around the amount, I had to do that manually with colors purple. We can do that, but what if we decide that red would be a better color? Then we manually have to change this here to colors red, and we have to change the text color here to red. And we also have to go to our main Dart file, and there we have to find our app bar, and on the app bar we can set the background color to colors red. If we do all of that, it saves, and yeah, it works, and no, I don't want to use red. But of course, it's pretty cumbersome if we have to change this manually in all these places. It would be better if we had a central place of setting these colors, and then we could tell Flutter, please use my globally defined color, my primary color, my secondary color, and so on. And that's possible with a concept called theming. We set up an application theme in the main Dart file, and there in our material app. If we scroll up in the main Dart file, here's our My App widget, which is our actual root widget. There we set up the title for our app. This, by the way, is the title you see when the app is in background mode in the task manager and so on. So I'll name this personal expenses. I also want to use this as a title, by the way, in my app bar. So here I'll also name this personal expenses. But of course, the title is not the thing for which I came there. Instead, here in your material app, you also can add a theme argument. And the theme argument allows you to set up a global application-wide theme. And theme basically means a combination of colors, of text styles, of font sizes that your entire application uses, that many of Flutter's widgets then use as a default, and that you always can tap into when you want to color your own widgets. So how does such a theme look like? How do we define it? Theme takes a theme data object. Now that's not a widget, but a normal object based on a class. The theme data class, however, is provided by Flutter. Now theme data, as you can tell, has a lot of arguments which you can configure. The good thing is you don't have to configure all of them. A lot of the theme settings are derived from other theme settings, so that you only have to define a couple of main settings unless you really want to control every nitty-gritty detail in your app, which you also could if you need that. The most important thing you can define here is the primary swatch. There also is a primary color. The difference is that the primary color is one single color, like blue or red. And the primary swatch is based on one single color, but it automatically generates different shades of that color automatically behind the scenes. And many of Flutter's default widgets need these different shades. And if you only define your primary color and not the swatch, then these shades are not available, and therefore all these Flutter widgets will fall back to other defaults or use your primary color, which can in some places look worse. So you should define a primary swatch there. And what you pass there is still a single color though. So all these shades are then generated automatically based on that color, you could say. To be really precise, colors gives you a bunch of material colors, and material colors are more complex objects which have the color itself as well as all the shades included, and primary swatch is then able to pull out these shades. But that's happening behind the scenes. You can simply choose one of these colors. And of course, it's totally up to you what you want to use. I will use purple as my primary color and now also swatch. The effect of that is that when I go down to the app bar and I make sure that the background color, this red color, is removed, and I then save this all, that I automatically get a purple app bar, but also a purple floating action button, just because I set this default primary swatch. Of course, here my boxes are still red, because I'm styling these manually. I'm not telling Flutter that I want to use my theme here. To tell Flutter that I want to use my theme here, I can use theme, which is an object provided by Flutter, and it's available in this file because I'm importing Material Dart. So I'm accessing theme here, then of context, and that in the end is something we also saw on the navigator in the last lectures. And this in the end just tells Flutter, here's my context object, and context is something I get passed to the build method automatically by Flutter. And as I mentioned earlier, context is essentially an object with a lot of metadata about this widget and its position in the widget tree. And one thing context also contains in the end is a reference to our theme data, you could say. It gives this widget a direct access to our theme data so that we don't have to pass the theme data down to that widget through the constructor. Because if every widget needs to get the theme data through the constructor, you would pass the theme data around a lot. And therefore, this is way more convenient. It gives us a direct tunnel to the theme data. This is a very elegant way of managing this, and that's also a topic we'll dive into later when we talk about different state management options where we can pass around our own data in a similar way. For now, let's just use the theme by getting access to the context, which gives us the direct tunnel to the theme data defined globally. And now there you see you have a bunch of properties. You can, for example, access the primary color. Or if you wanted to, you could access a darker or a lighter version of the primary color. That's the shading I mentioned. There are different shades. Here I want to use the primary color, and I'll do the same here on my text as a text color. So theme of context primary color. Now, of course, I still define my color manually here, but I point at the theme. And the advantage is that if I now change my theme, let's say I go back here and I change my theme here to green, then all these places change simultaneously, and you don't have to manually pick and edit all these colors. That's the huge advantage of using a theme. I want to go with purple here though, and besides the primary swatch, you often also have an accent color. The accent color, like the name suggests, is an alternative color, because often you want to mix colors. And you can look into the official material design documentation if you want to get ideas for how to mix and match colors and which combinations work. I really like the amber color, which is a yellowish color, combined with purple. If I save this, we see, for example, that now that we define that alternative color, the floating action bar is actually configured to use that accent color. Remember that floating action button is a default button or a default widget provided by Flutter, and internally it's simply configured to use the accent color if available and fall back to the primary color if it's not available. And that's pretty neat. Here we see the accent color in action, and it was just one line of code and something totally different in our app changed. Now, besides that, you can configure a lot of other things too. You could, for example, set the overall app bar theme if you wanted a different theme for the app bar, and so on. And we'll come back to that theme data throughout this module and throughout this course. Playing around with it is something you can always do. At the end of this module, in the Useful Resources lecture, you'll also find a link to the official theming docs where you can learn more about that and about the many ways of adjusting this. And using themes is a crucial and super important feature in Flutter apps because it makes styling and coloring so much easier. Now that we added our theme here, why don't we also add a custom font? Because right now we always use the system default font, which is okay, but in a lot of applications you of course want to bring your own text styles, your own fonts. And adding custom fonts is very easy in Flutter apps. First of all, you need to create a new folder in your project folder. So not in the lib folder, but simply in your main project folder. You can name that folder whatever you want. Typically you name it something like assets, or you directly name it fonts, whatever you want. I'll name it assets, and in the assets folder, I'll create a fonts folder. You could, as I just mentioned, also have the fonts folder on the root level, but I want to have it here in the assets folder. Now there I want to use a couple of fonts, and you find a zip file attached which includes the fonts I will use here. So let's drag and drop the contents of that zip folder into that fonts folder here. I brought in two fonts here, Open Sans in a bold and the regular version, and Quicksand in a bold, light, medium, and regular version. We'll actually not use all these versions, but you can play around with them, and we will definitely use both fonts, Open Sans and Quicksand. Now with the fonts added here, we still can't automatically use them in our application. To unlock them in our application and to include them in the app file that Flutter generates in the end, you need to go to your pubspec.yaml file, which again is your global management tool here. And there, if you scroll down, you should actually find this commented out area, which already gives you an example of how to add fonts. So you can simply comment this back in by removing the hash symbols. And then you see that you have fonts, which is indented by 2 spaces. And again, in YAML files, spacing matters. And there you define a family key after this dash and a white space. And that is the name of the font. This name here should match the name of your font, but theoretically it's up to you. But of course, to avoid confusion, you typically give that the name of your font. So for example, here we have Open Sans. Now, you also need to define where the exact files for that font can be found. You do this on a fonts key, and then here with these asset keys. And there you have to point at the folder, which in our case is assets/fonts. And then there I have Open Sans -regular TTF. And here you absolutely need to get these file names correct. Make sure you don't mistype. This path and this file name here has to match this path and file name here. Now I also have a bold version of this font, so I will also add assets/fonts/opensans-bold.ttf because that's my file name and my folder. Important to inform Flutter that this is the bold version. it doesn't infer that from the name, you need to add a weight information here, and the weight here is 700 for this font. If you're adding a new font and you're downloading that from some resource like Google Fonts, which is a web page, then there you should find some information about which weight your font has. So Open Sans Bold has a weight of 700, and therefore I add this extra information. This will become important later when we use font weight bold in our Flutter widgets and tell Flutter that we want to use the bold font. 700 is treated as a bold font, and therefore Flutter would pick this one. Now this is not the only font I have, however, not the only family. I'll add a second family here, and that's called Quicksand. And there again, we add the fonts key, and in there, asset, and then assets/fonts/quicksand-regular.ttf, and then also assets fonts quicksand-bold.ttf. And there again, I'll add the weight 700 annotation. Now you have two other fonts which you could add, which I'm not adding here. Of course, if you are not using them, you could delete them. But for you to play around, feel free to add these other fonts as well so that you can use them. That, of course, brings us to the question, how can you use your own fonts? Let's say we want to use Quicksand as our normal global font in the application. You can set such a global font in your theme. So here in the theme data, you can set a font family, and you can set this to Quicksand. Now, of course, the name you use here as a string has to match the name you have in your pubspec.yaml file. So if this family identifier is written as Quicksand, the file names don't matter, but if this identifier is written like this, then you have to write it exactly in the same way when you are referring to it. Now with that, you will have to quit your running process and actually restart it entirely. So pressing the refresh button also won't help. You need to restart the app because we added new files to it. And therefore you, for the first time right after you added the files, you need to restart the app. And once you did that, once the app did restart, you should see that your application-wide default font is Quicksand, which is a bit thinner than the default on Android, which is Roboto. So here's my application. And as you can tell, we now have a thinner font, and that is our Quicksand font. Now, of course, in some places, you might still want to use a different font. For example, here for my titles, I want to use the other font, the Open Sans font, and also maybe here in the app bar. Now, there are two ways of doing that. You can go to your app bar, if we want to start with that, in the main Dart file. And on the app bar here, on this text here in the title, you could add a style, and that would be a text style, and there you can set the font family, and you can set that to Open Sans like this. If you do that and it saves, you see now this is bolder because now it uses Open Sans. The downside of this is that if you had an application with multiple pages, which we haven't here, but we'll have it later in the course, then you would have to add the style to every title, to every text widget in every title of every app bar, which is really redundant if you want to have the same style in every app bar across your entire application. Therefore, you can also set a default app bar theme in your theme data. There, you can add app bar theme, and now define a new app bar theme here, where you set a text theme by using themedata.light, which is a set of defaults, the defaults you normally have when you just create a theme data object. Now here we basically have that same theme data object with the default settings configured. And on that theme data object, using the light theme, we can now access the text theme here and copy it with our own settings. So what we basically do here is we assign a new text theme for our app bar, so that all text elements in the app bar receive that theme. And we based it on the default text theme so that we don't have to overwrite everything like font size and so on. But we use the default text theme and copy that with some new overwritten values. And here I overwrite that titles are a specific style of text, Flutter knows, that titles receive a specific style. I want to give titles a text style, because title here expects a text style object, where the font family is, let's say, Open Sans, and where it maybe even has a default font size of, let's say, 20 if you want to change that as well. Now with that, we're using the basic text theme with our own settings mixed in, and we apply that to all texts in the app bar theme, or in the app bar in general. And to be very precise, we don't overwrite all text in there, but text which is marked as a title by Flutter, and the title here is actually marked as such by Flutter. And I will show you how you can manually mark items as title in a second. So if you save that and you go back, you see this is now less bold because the default actually was bold. I now change this to not be bold anymore. We can, of course, set this back to bold by adding font weight, and then here font weight.bold again, just to confirm that this works. Now it's bold. And now we are clearly using a different style. We're using Open Sans here, not Quicksand anymore. So this is working. And this is one way of also applying fonts here to all our app bars, or to be precise, to all title texts in app bars. Now I also want to make sure that all my other titles here are using this style. And how can we do that? For this, we first of all need to inform Flutter that our texts here should be treated as titles. So let's go to the transaction list and there to our title, which is here. And there, what we can now do is, instead of defining our own text style here, we can also reference our theme with theme of context, and then access the text theme, and here our title theme. Now at the moment when I save this, this will use Quicksand, because remember that our title theme here is only defined for inside app bars. And we could bring that out of the app bar if we wanted that same style everywhere, but I want a slightly different normal text theme, and therefore here I can set up my own text theme. Just as before, however, I'll copy it based on the existing text theme so that I don't have to set everything. And in there I want to set my own title theme by giving this now a globally available text style, which all items that refer to this title theme will now use. And there we can set text style to font family Open Sans, font weight bold, and a font size of, say, 18. And that's the difference to the app bar font size where I have 20. Otherwise I could have used just one global title theme. Now I have a separate title theme for the app bar and one for the rest of the app, and I do refer to that by not providing my own text style here, but by referring to the globally available text theme, title text style. So with that, if we now save this, we have our nice look here using Open Sans and a bold text and a size of 18 for everything that is marked as a title with this approach. Custom fonts are great. What about custom images? Let's say if we have no transactions, I want to show some image that indicates that we have no content, that we're waiting for new content. For that, first of all, let's make sure that we can have no content by going to the main Dart file, and there let's remove or comment out these two default transactions. Now with that, if we reload this, we'll have a pretty empty space over here. So there's nothing there. And there I want to show an image now. For that, we first of all need an image. Now you can also add images that are stored somewhere in the web, but of course you can also include local images. And here I want to use a local image. For that, in our assets folder, next to the fonts folder, I'll add an images folder. The name is up to you, just as it was with the fonts folder. You just should have some strategy or idea for storing images. And I'll copy an image into that folder. Here is a file, you find it attached to this lecture, waiting.png. It's a couple of sets over here. So we have that image, and now I want to include that image here instead of my list of transactions, so instead of this widget, if we have no transactions. I'll actually write the logic for that inside of the transaction list so that our main widget tree here doesn't get too huge, too large. So in the transaction list here, I only want to render this list view builder widget with all its, well, list items if we have no transactions. Otherwise, I want to render some text where I say no transactions added yet and that image. Since we have an either or decision here, we in the end need a ternary expression. So let's add one. We receive our transactions here. So I want to check if transactions is empty. In that case, here, I want to render my text and that image. Otherwise, after the colon, the list of transactions. So here I need a column because I want to have the text, and above and below the text, I want to have the image. So let's add, first of all, the text. And there I'll say no transactions added yet. Whoops, with lowercase t. And that can be a title, so why don't we give it a style of theme of context dot text theme dot title, which is what you learned about in the last lectures. And below that, let's add an image. And for this, we can use the image widget. And there we have a couple of constructors for the different sources the image could be coming from. There is asset, if it's provided as an asset in our project. File would be good for images that are in files that you obtained in a different way, but by streaming in some image, something like this. Network is great if you have a URL for the image, so if it's not stored as part of your project, but it's a web image. But here, of course, it's part of our project, so we need asset. And then you need the path to the image here, and that's assets/images/waiting.png. Now, just like fonts, adding an image here isn't enough. You also need to include it in your pubspec.yaml file. There, you should already have a section that shows you how to add it. You add an assets key, and then a path to all the assets, the non-font assets you want to use in your app. In this case, that's assets/images. And by the way, it's important that you have assets here. Just because this key is named like this does not mean that it goes into your assets folder automatically. It's a pure coincidence that this folder is named assets and this key is named assets. So here you need to add the full path, which is assets/images/waiting.png. Typical image formats like JPEG, PNG, and GIF are supported. So with that, we added the image, and now, just as before, you need to quit that and then fully restart your application after you added this new file here. So now this file will be included in your bundle, and thanks to image asset here in the transaction list widget, it should also be displayed. So the image should also be displayed then. So let's wait for this build process to finish. And here we are. So we see the image, but as it seems, it's too big. We get this warning that some content is overflowing its boundaries, and that's the case here because our transaction list actually only gets a container with height 300, and that image simply is bigger than that. Of course, we could provide a smaller image, but maybe on bigger screens, on bigger devices, we want a bigger image, because maybe at some point in the future, we calculate this height dynamically. We're not doing this right now, but we'll later learn about tools that allow us to do that. So it would be great if we could squeeze the image into that container and tell Flutter that it should size the image appropriately. And you can do that. On the image here, you can add a fit key and set that to a box fit value. Box fit is an enum and gives you a couple of options. And cover is a great option that respects the boundaries of the surrounding container and fits the image into there. The problem with that just is that we have no boundaries here. We have that container, but the direct parent of the image is not the container, but the column. And you learned that columns take as much height as they can get. So the image is not able to infer the size into which it should squeeze the image from the column. It would need access to the container, but that's outside of the column. Solution is simple. We can wrap our image here into another widget, for example, into a container. And now that the image is wrapped in there, we can give this container a height of, let's say, 200. And once we do that, now the image fits in there, because now box fit here is able to take the height of its direct parent and squeeze the image in there. And this gives us this look. Now what I would like to have is some spacing between our title here and the image. And there's another widget which makes this super simple. Below the text, above our image container here, you can add a sized box. We haven't seen that widget before. Sized box does what the name suggests. It allows us to add a box with a specific size. You can add a child in here, so you can add content in here. And actually, we could replace this container here with a sized box, because all we do is assign a height. And that's exactly something you can do in sized boxes too. You can set widths and heights. The cool thing is you can also not define a child here, and therefore sized boxes are also a common way of using them as separators, as to provide some spacing between elements, because this will be an empty box which we don't see on the screen, but which still occupies its space. It still occupies 10 pixels of vertical space here. And therefore now we have some spacing, a little bit more spacing between the image and the title. And of course you can ramp up that spacing to, well, increase that distance. So this is good. Now we have that waiting picture, and as soon as we do add a transaction here, like new shoes, that actually disappears and we see our transactions, that as it should be the case. So now we also saw how we can add our own images. Now with the application taking a lot of shape, it's time to finally work on that chart, because that's the ugly piece that really doesn't fit into our application at all. Now for that, let's add a new widget. And I'll name it chart.dart file, because it will in the end display a chart about our recent transactions. And that can actually be a stateless widget, because we won't need to change any data in there. It'll just output some visual data about the transactions we added to our app. I'll name the widget chart because, well, in the end, that is what it is. And of course, just as a side note, there are official charting packages or third-party charting packages you could add to Flutter projects if you need more complex charts. But that basic chart which we'll build here, or that basic output we'll build here, won't need such a package. But you can bring in such packages if you need more complex charting functionalities. Now, what do we need in here, or how do we build this chart now? I want to have that chart wrapped in a card, and I'll give this card an elevation level of let's say 6 to have a nice drop shadow. And on that card, I also want to have a margin around so that there is some space around our chart. We can add that with edge insets, as you learned, and I'll add a margin in all directions of, let's say, 20. We can always shrink that down if it's too much. Now, of course, we need a child, and that will be our actual chart. And for that, let's again analyze how such a chart should look like. It's time for my awesome drawing skills again. So in our application here, right, we'll have that chart area here at the top. And my idea here is that we have a couple of bars, let's say for the last 7 days. So let's see if I can squeeze 7 bars in here. Yeah, almost. So we have 7 bars here, one for each day in the last week, with some labels for the weekday, so Monday, Tuesday, Wednesday, and so on. So a single character for the weekday below that. And above the amount of dollars that we spent on that day, which can be 0 if we spent nothing, or, well, a different amount if we spent something. And then in that chart, I want to have, or in that bar, I want to have some indication of how much that amount that we spent on that day is of the total amount we spent on the overall week. So if we spent 50 on Monday and 30 on Tuesday and 0 on all other days, then we had a total spending of 80, 50 plus 30. And here we have $50 of 80 total dollars. So we might have something like this, a significant amount above 50% of the bar. And here we might have $30 of $80 total spending. So we're around a third of that bar. That's my idea of how this should be structured. Now, what will we need here? This here, the red part, that's our card. We already have that. Let me pick a different color, blue. Now, in that, we'll certainly need a row. And of course, that row does not go beyond the boundaries of the card. I'm just drawing it like this so that you can see it. So we need a row here for our different bars. Each bar, so each bar here is then a column. because we have the dollar sign, then the bar itself, and then the label. And the bar inside of the bar, so to say, so that part here where we have that yellow filling, that of course again will be a container with a partial background. We'll see how we can draw, how we can fix this, how we can build this in Flutter. So that's the rough layout. Let's now build that. So the child of my card here should be that row with all the information in it. So let's add a row here. And in that row, I want to have my bars with the label, with the weekday label, and with the amount, and of course with the partially filled background. So we'll have some children in here, and we'll always have exactly 7 bars. That's something I know. Nonetheless, I want to generate these 7 bars dynamically and not hard code 7 bar widgets in here. So therefore, let's add a new method here in our chart widget, or a new getter to be precise. You might remember getters are these properties which are calculated dynamically. And there I want to have a getter which I'll name grouped transactions, because these are, or transaction values, because these are the transaction values grouped by weekday. And what this actually returns, what this yields, should be a list, because I need multiple bars, I need 7 bars. And the item, the list item in there, the list items, should be maps. You could also build your own objects, that would be perfectly fine. But I will use a map here. And in that map, we'll have mixed content, we'll have keys that are strings, and the values will be of type object, because we'll have mixed values there. And it will become clearer what's in there as we progress here. So as a getter, this needs a body where we return that list. Now, first of all, we can use list and then generate, which is a utility constructor on the list class. List is a core Dart object or a core Dart class, and it has a generate constructor which generates as a new list. We define the length, and generate makes a lot of sense here because I know that I want a length of 7. I want 7 weekdays. And then we have a function which will be called for every element. So here we pass in a function, and that function will receive the index. So 0, 1, all the way up to 6, because the index is always 1 lower than the length. So it will give us a list with 7 elements, and first list element has an index of 0. So it executes this function for every generated list element with index being 0, 1, 2, 3, 4, 5, 6. In here, in this function here, we pass as a second argument to generate. I return my map in the end, right? Because I have a list of maps. So we can return something with curly braces to create a map. And now in that map, which I return here, I need a couple of pieces of information. I need to get the label for the weekday, and I'll just name this key here day, but it should hold a label like M for Monday, T for Tuesday, and so on. So we'll replace this later, we'll not hard code this, no worries. Then I will also need the amount for that day. And that amount should be something like $9.99, of course. So the total spendings for that given day. Now we need to calculate that amount for that day, and for that we need to know which transactions we have overall. So the chart will need our list of transactions, otherwise we can't derive the values for the chart, of course. Hence, I'll add a final property, which should be a list full of transactions, and transaction is my own class, so we should import that from the models folder, the transaction Dart file. And I'll name that recent transactions, because actually we should only receive a list of the, well, recent transactions that happened over the last days, over the last 7 days to be precise. I'll add a constructor where I expect these recent transactions and store them here in that list. Now let's continue with the logic for grouping our transactions by weekday. To group these recent transactions here inside of our generate method or in the function we pass to generate here, I first of all want to find out which weekday we're currently generating. Now we can do this with the help of index. So I'll create a weekday variable and I mark it as final. You could use var here, but if you don't intend on changing this variable ever, you can also mark it as final, and then this is considered to be better because you're clear about what you're planning. And being clear about your intentions is always good in programming. So instead of var, I use final to mark that this is a final variable, which kind of doesn't really make it a variable, I guess. And then we set this equal to date time now, which is the current date, so today. And now, of course, we know that since we generate data for the last 7 weekdays, when this here has an index of 0, then we could say we deduct 0 days from today, and hence we have, well, today, and we can get the weekday of today. For the next item in the list, this will be 1. So that would be yesterday if we deduct it from date time now. And then we can get the weekday of that, and so on, all the way up to 1 week ago. Thankfully, the datetime object in Dart has a subtract method where we can conveniently subtract a duration to get a new date. Duration has to be a duration object, and duration is also built into Dart, so we can use it like this. And duration in its constructor takes some arguments that allow us to define the duration. And here we could say the duration should be index days. So for the first round, when this is 0, we have a duration of 0 days. So we subtract 0 days, which means we have still datetime now. In the next round, for the next list item which is generated, index is 1, so we subtract 1 day. So that means now we generate a date which is yesterday, and so on. So with that, we generate these different days, but of course, I'm not really interested in the date. I want to get my weekday shortcut, my identifier. And we can do that with the help of a package we installed earlier with the Intel package. So here you can add the Intel package again, the Intel Dart file. And here when we assign a weekday value to the day field in our map here, to the day key, we can use date format dot e. That's a special constructor that simply gives us the shortcut for the weekday. So M for Monday, T for Tuesday, and so on. That's built into that date format class, which is of course extremely convenient. And then all we have to do is pass our weekday in here, and that will then retrieve the shortcut for that weekday as a string and store it in this map. So that's the weekday. What about the total amount for that day? That of course means that we need to sum up all transactions that happened on this day. Now we got the recent transactions, which are all transactions for the last week. So now we need to find all transactions that happened on this day and then sum them up. We can do that with the help of a for loop. So I'll create a variable here. To be precise, I'll create a variable with the double keyword, total sum. And I use double here instead of var because since I don't initialize this variable, it's unclear which type it will have. And then it's a good practice to clearly define the type it will have. And now we can use a for loop. We haven't used a for loop before. A for loop allows you to repeat code multiple times. You do that by typing for, and then you pass some instructions here between these parentheses. To be precise, a for loop needs 3 things. It needs an internal variable which changes with every iteration in the for loop, so with every execution of your code. And that's created with the var keyword. It's often named I, but you can use any name you want, but I for iteration. And you assign an initial value. Typically that's 0, but you can assign any value. Then you add a semicolon, and next you define your exit condition. So how long should this loop keep on running? And here it should keep on running as long as we have transactions in our recent transactions list, because I want to go through all transactions to then filter out the ones that happened today. So our keep it running condition here, which is a better name than exit, so our keep it running condition is that I, this index here, is smaller then recent transactions length. So let's say recent transactions is a list of 5 elements, then this loop will keep on running as long as I is smaller than 5. A problem with that is that we never change I. That's the third element you need in the for loop. You change I with every iteration, typically by simply adding 1. And that's a shortcut for I equals I plus 1, which you could also write. The shortcut is I plus plus, which means after every round, important, after every round, 1 gets added to I. So after the first round, I is 1. If you have 5 elements in here, it keeps on running. And after the last round, I, if we have 5 elements, will get a value of 5 that is then not smaller than 5 anymore, and hence it will stop running the loop. So with that, we're running through all our transactions, and inside of the for loop, we can now add an if statement to check if that transaction we're now looking at happened today. So that means that now inside the loop, in the if statement, I use recent transactions and access the element at the index I. And I will, of course, change with every iteration. So we go through all elements in recent transactions, and here I access each element. And then I can check if that element here, if the date of that element is equal to this date. However, this would be wrong, because this is a date time object, which means it does not only contain the date, but also the time, the timestamp. And this simply means that comparing dates will never succeed, because we'll never have the exact same timestamp. Instead, I want to make sure that the day, the month, and the year is equal, because these are my 3 things that make up the date. So I compare the day, and thankfully there is a day property on every datetime object. I check if day is equal to, and with 2 equal signs, as you learned, you can check for value equality, if that is equal to weekday.day. Now I also need to make sure that we're in the same year and month. So I will also check if recent transactions for the element I, if they're on the date, the month is equal to weekday month. And one additional condition which I want to add here, and you can split conditions across multiple lines to keep it simple. And I want to check if recent transactions date year is equal to weekday year. With that, we have a condition that checks, are we looking at a transaction that happened on the weekday we're considering for this iteration in our list generation here. If we identified a transaction that happened on that day, we want to add it to our total sum. And now actually I want to initialize my total sum with a value, with 0.0, and therefore we can change double to var, because if we initialize it with a value, Dart is able to infer the type. So in the if check here, I now want to use double sum, a total sum, and add my, with the shortcut here, my recent transaction for the given index amount, because I need to add that amount to the total sum. And with that, we go through all transactions and we add the sum of each transaction, the amount of each transaction that happened on that weekday we're looking at, to the total sum for that weekday. And now down there, when we generate the map, we just have to replace 999 with the total sum. And now we should be returning a map with the weekday, shortcut, and the amount. And that was a lot of work, but I hope the logic here is clear, which allows us to find out which amount of transactions, which total sum was generated on a given weekday. To see whether that worked, I'll actually print these 2 pieces of information here. So here, right before we return the map, I'll print the weekday identifier and the total sum. But now, of course, to see that, we also need to wire up our chart widget. To wire up the chart widget, we need to include it in the place where we want to display it. That would be in the main Dart file instead of our chart placeholder. So here we have that chart placeholder. Let's replace that entire container now with our chart widget. The chart widget is only available if we import it. So here we need to import ./widgets chart. And let me also bring that import here next to the other widgets imports. Not required, but good from a stylistic perspective. So we're importing the chart widget. We're using it down there Chart, however, needs our recent transactions, and that's important. It does not need all transactions. We could have more transactions here, but I only want the transactions from the last week, so we should make sure that we only add those. For that, in the main Dart file, I will also add a getter. I have my list of transactions here, and below that I'll add another list of transactions, but this is now a getter, so a dynamically calculated property, which I'll name underscore recent transactions. Now, just as all getters, this has no argument lists, but it has a body and it needs to return here a list of transactions. And for that, we of course take all our transactions, but now we want to filter out transactions that didn't happen in the last week. We could again do this with the help of a for loop. We could build a new list in here and return that new list after running over all transactions with a for loop and finding all transactions that have a date that is younger than today minus 7 days. But to mix things up and to show an alternative to using for loops everywhere, you can also use another method which exists on every list, which is a default method Dart offers on lists, and that's the where method. Where allows you to run a function on every item in a list, and if that function returns true, the item is kept in a newly returned list. Otherwise, it's not included in that newly returned list. So here, I pass in an anonymous function, and that function gets the element of our list because it executes on every element in this list, and therefore it gets the element it's currently looking at as an input. And here I get my transaction, which I'll name tx. You can name it whatever you want. And I want to return true if that happened within the last week, and false if it's older than a week. And for this, I'll check if tx date, and the good thing is that's a datetime object, and there Dart gives us a isAfter method. And now all we have to pass here is another datetime, and only if this date is after this date, this here will return true, and only then this transaction will be included in our recent transactions. So the date I want to pass here is of course today minus 7 days. So here I create datetime now, and I subtract a duration. You already saw all of that earlier. A duration where days is equal to 7. And this subtracts 7 days from today, and hence makes sure that we check that this date here is after today minus 7 days. Only transactions that are younger than 7 days are included here. And now we can pass recent transactions like a property, because it is a property, just a dynamically generated one, to chart. So let's save this, and we get an error. The error here is if you scroll up, let me increase that. If you scroll up, you see that the error is that it has something to do with the iterable, which means something with a list. And it's not of subtype list transaction. Instead, it's a where iterable transaction. Bit cryptic, but it has to do with where and iterables. And since it appeared after writing this code for the recent transactions, it probably has something to do with that. Indeed, where returns an iterable, not a list. But we expect a list here. So what we need to do here is on the value we generate here with where, we need to call toList. And you might remember we had to do this with map as well earlier. So now if we save this, now our app restarts. And now let's add a transaction here. New shoes, 99.99. And if we save that, nothing happens in our console. So is our chart logic not working here for the grouped transaction values? Well, we can't tell because we're simply not using that. It's a getter, and we're never using the grouped transaction values. So in order to find out whether that works, we need to use it. And for a start, I will simply print grouped transaction values here in the build method of my chart. And with that, it crashes. Let's see what's wrong here. The problem is type datetime is not a subtype of type string, caused by line 26 in our chart file. Yeah, the problem is, little mistake on my side, we shouldn't pass weekday here to this e constructor, but instead call format on the object that constructor gives us and pass weekday to that format function, also down there, of course. So with that, let's now save this. And if we now scroll down, that looks better. And indeed, what we see here is a couple of things. This is the overall list that was generated, and this looks good. It has a list of days with the different weekdays. And we see 99.99, which is the value I added today on Thursday. And today indeed is Thursday. So this is working, and it's generating this correctly as it seems. Let's validate it by adding one other transaction, groceries, 9.69. This will also be added today because right now we have no way of targeting different days. And with that, yeah, our amount today increased. That strange number here, by the way, why it's looking that strange. This is not a bug. This is a default Dart behavior. You actually have that behavior in every programming language. When you do calculations with numbers with floating point values, so with decimal places, then that's hard for computers, and you will therefore, when adding various decimal places, sometimes end up with long expressions like this, with a lot of decimal places. Doesn't really matter for us here, however. It's not a bug, it's a default behavior which you have in any programming language. More information about that can be found attached in a document to this lecture if you want to learn more. For the moment, let's leave that as it is, and let's make sure that we now also don't just see our data here in the debug log with the help of these print statements, but that we instead really output something on the screen for our transactions. To get the grouped and summed up transactions on the screen, here in the chart Dart file, in the row where I output my bars, or where I plan on outputting my bars, the goal now is to generate the children here for that row based on the grouped transaction values, because that will be exactly 7 items, since we generate 7 items, and we need these 7 bars with all the information about the transactions for that day and so on. Hence, down here, we can refer to grouped transaction values, which is a list, and map this into a list of widgets. And as always, on map, you need to call toList in the end. Now here we have a function that executes on every item in that grouped transaction values list. And that will receive the data, or whatever you want to name it, that name is up to you, for every element here. In there, we need to return a widget, and we have no widget for that bar yet. We haven't created a widget that could be a bar in our chart. So for the moment, we can return some text here, so start, and simply output data, day here, which should be the shortcut for the weekday, plus a colon, plus data amount to string. Now, of course, as you learned, concatenating data like this is not really necessary. Shortcut is that you have a string here, and then you use $, and then here, data day. However, since it's more than just a single variable, you need to wrap that in curly braces. And then we have a colon. This is now normal text. And after that, we have, again, another string interpolation here where we access data amount. And this will automatically be converted to a string then. If we save this, I get an error here. Let's ignore it for now. It's just some overflow here because we're entering too much data. The important thing is that theoretically it works though. Super ugly, but we see our weekday, and then we also see our value. Small correction from my side, the weekday here is not yet a single digit, a single character. To turn it into a single character, however, we can go here to the place where we generate that formatted weekday and use the substring method, a default method you can use on any string in Dart. Start at the first character, which has the index of 0, and end after the first character, so before the second character. And if you do that, now indeed you have T, W, T, and so on. So it's a tiny fix, but of course the more important fix is that we render real bar charts here, real bars, and not, well, ugly text like this. So let's build the bars for our chart, and therefore I'll add a new file in the widgets folder, chart_bar.dart. That will simply hold the bars for my chart. It'll be a stateless widget because we don't need to change any data in a single bar. I'll name it chart bar. You can, of course, name your widgets whatever you prefer. And in there, as always, we import the material Dart file so that we unlock stateless widget and so on. Now in the chart bar, I expect some information. I, of course, want to have my label, so the text, the weekday. I also expect a double, which is my spending. And there I want to have the spending amount. But I also, and that's new, need a double, which is my spending percentage of total, if you want to name it like this. You could use a shorter name, but I want to be really clear what this is. I need that so that I know inside of that bar how I should color the background, because only a percentage of the bar should have the background color, right? So these are the 3 pieces of information I need. And here on my chart bar constructor, you could use named arguments. I will go for positional arguments, and I'll get the label, the spending amount, and the spending percentage of total. With that information, we can now work on the bar. And that will be a column here, because we have 3 items on top of each other, or above each other. So let's add children here. And the topmost item is, let's say, the amount we spent on that day. So therefore here, that can be some text. And the text I want to have in here should have a $sign, and we need to escape that, as you learned. So /$. And then a string interpolation with $sign curly braces, where I use my spending amount. But there I want to call toString as fixed to remove all decimal places by setting them to 0, so that I have no decimal places here, and I only show the rounded integer value, so to say. So that's the topmost element, the text with the $signs. Then let's say we have a sized box to add some spacing, maybe 4 pixels. And thereafter a container. That's our main bar. This container might have a height of, let's say, 60 pixels and a width of maybe 10. And then the child should be a background that is filled to, well, different amounts. We can fill that background fractionally, so to say. Let's take care about the child in a second. For now, let's add null here. After the container, I'll have another sized box here with, let's say, a height of 4 as to add some spacing. And below that, a text with my label, which holds the weekday. So now back to that container. How can we give this a background that's partially filled? For that, let's use a new widget, which I mentioned earlier on a slide, but which we haven't used yet. And that's the stack widget. The stack widget allows you to place elements on top of each other. And with top, I mean in like a 3-dimensional space. So not on top of each other like a column, but really overlapping each other. It also takes a children argument, which takes a list of widgets. And now the first widget you add here will be the bottommost widget. This should be a container with a decoration, which is a box decoration object, where I want to assign a border, let's say with border all in all directions of a gray color. And here I'm not using the theme because this is really the only widget where I want this, and a width of 1 pixel. Whoops, I should also target my color here with colors gray. Besides that, the decoration for this container should be that I have a background color, which maybe is a light gray color. I'll also select this manually here, and I'll not use gray from colors because that's too dark. Instead here, I'll use color, and then that has a constructor from RGBO. And that means it's allowing us to mix a color with red, green, blue, and opacity values. And here, if you pass 220, 220, 220, and then 1, you should get a light gray color. So this is basically RGBA values being used. Each value here can be between 0 and 255, and you can simply play around with that or use some color mixers on the internet to generate your favorite color in RGBA code. Last but not least, I want to have a border radius for some rounded corners. And here we need a border radius geometry. We create that, however, with the border radius class, and there you can use the circular constructor to give that border radius of, let's say, 20 pixels. You can play around with that, what fits your or what suits your needs. Maybe let's use 10. With that, we have the overall container. That will be the main container. And now I want to overlay, hence the stack, another container, which is smaller, which has less height than 60, and which has a different background color, so that we have the effect of that container here being partially filled. So therefore, inside of the stack, above of that container, because the elements here are from at the bottom to at the top ordered. So on top of that container, I'll add another container where I could manually set the height differently, or I use a special widget Flutter has, the fractionally sized box. And this allows me to create a box that is sized as a fraction of another value. There you need to add a height factor, and that height factor should be a value between 0 and 1, where 1 is 100% of the surrounding container. So in this case, this is the surrounding container. So 1 would give us a height of 60, 0 would be, well, 0. And my percentage is, of course, my spanning percentage of total here. I expect this to be a value between 0 and 1, so I pass this here as a value to height factor. Now, since I can't set a decoration on the fractionally sized box, but I can set a child, I'll add a container as a child here. And that container now will have the background color I want. So I'll give it a decoration here, which is a box decoration, where I set the color. By the way, you could set the color directly on the container too with the color argument, but I want to use the decoration because I want to set more than just the color. So I'll set the color here, and the color should be based on the theme. So let's select it from our context, and there our primary color maybe. Of course, it's up to you which color you want to use. And then set the same border radius as for the other border, so that the two containers, which are placed on top of each other, are matching up regarding their borders and their edges. And with that, we should have a bar that works. Let's now try it, and let's make sure we pass in a value for spanning percentage of total. Let's use our chart bar. Back in the chart widget here, where I currently return some text, I of course instead want to return my chart bar widget. For that, as always, you need to import it by pointing at the chartbar.dart file. With that imported here, I return my chart bar, and now we need to pass in three things. The label, which is not hard. In our data object here, we're referring, of course, to this map here, and there the day is our label. Whoops, should be wrapped in quotes. The second argument also is not hard. It's our spending amount, and that's data and then amount. But the third part is more difficult. We need the total spendings for that week. Let's calculate those with another getter, which will return a double. And I'll name it max spending. And here I want to return a value based on my grouped transaction values, because there in the end we want to sum up all the amounts. The sum of all the total sums for each day gives us the total sum for the entire week. Now, grouped transaction values, of course, is a list, and now here I just need a double. There's another helpful method we can use in Dart on lists, and that's the fold method. Fold allows us to change a list to another type with a certain logic we define in the function we pass to fold. So here to fold, we pass an anonymous function, and besides that, as a first argument, we pass a starting value. In this case, that's 0.0. So that's our starting value, and now in this function, our second argument we pass to fold, we have to return a new value which will be added to this starting value. We have to return a new value now for every run on every item in grouped transaction values. Therefore, in this anonymous function, we receive two arguments. The first argument is the currently calculated sum, so our starting value for the first element, and thereafter the current sum or the current value we calculated based on this function. So our sum. And the second argument we get here is the element we're looking at, so our item, or whatever you want to call it. These names are up to you because you get the values passed by Dart, but you're writing this code here, which is triggered by Dart, so you can name these things here as you want. Now in here, you have to return a new sum, which will then be passed as an input to this function for the next element in line in this list. If you're having a JavaScript background, this is basically your equivalent to the reduce function. This also exists in many other programming languages. Now in here, I now simply return sum plus item amount, and this should give us all the totals for each day, and therefore sum up the total for the week. And therefore I'll name this total spending here. So now with that, we have a getter for the total spending. Now here we could pass the total spending in, but actually in the chart bar, I'm not interested in my total spending, but in the percentage of the total. So actually what we should do here, before passing this in, we have to take the amount for the given weekday we're looking at, and we have to divide this by our total spending so that we get the ratio of how much of our total week spending did we spend on this day. Now here we're getting an error that we can't use that operator on the type object because Dart is not able to find out that the amount is a double. We can fix this by wrapping this in parentheses and using as double here. And now with that, we should have everything to draw our chart with some bars onto the screen. That's looking good. Of course, we're not using the space very efficiently. That's something we should work on. But other than that, I'm liking this. If I add a new transaction now, more shoes, for let's say $120.99, you see this updates, this number updates, and well, always the first bar is of course fully occupied because we have no way of targeting different days. Now we actually do get an error though if we restart the app, and therefore we lose all our transactions, which are stored in memory of our application, because right now we're not saving them anywhere, not on a server or anything like that. And of course later in the course you will learn how to save data on a server and load it from there. But right now our data is lost whenever we restart the app. And for this app, this is fine. It's just our next step in our journey to master Flutter. The problem nonetheless is that if we have no transactions, our chart here breaks and we get an error. Reason for that, of course, is that here, the fraction we're passing to our chart bar, which defines how much it should be filled, that, of course, is an invalid value if we have no transactions, because then total spending is 0. We haven't spent anything, we have no transactions. And dividing by 0, never a great idea. This actually yields an invalid value, and what I actually would want to do is, of course, check whether total spending is 0, and if it is 0, if we have no total spending, then I want to pass 0 to all my chart bars, because then each chart bar should be empty, and therefore the fraction by which it should be filled should be 0. So in the end, we can simply add a ternary expression here and check whether total spending is equal to 0.0, and if that's the case, pass 0.0 to the chart bar as our percentage of total, because the bar should be empty then. And only if we have a non-zero value, I want to calculate my share of the total spending. So with this simple change here, now this renders again, and now we have an application that also works with no transactions. So next steps will of course be that we target different days, but first of all, I want to make sure that we use this space a bit more efficiently. To use this space more efficiently, we need to inform these child elements in our chart, because this chart bar is a child element of the row, how they should spread out. Now in the row, of course, we can say main axis alignment, because in a row the main axis alignment is left to right, should be main axis alignment space around maybe. If we do that, that looks way better already. I also, however, want to make sure that my items here, if I add a really large amount here, don't change their size. Instead, they should stay in their size and should rather shrink the label here. That can be achieved by going to the chart bar and then by wrapping this column here with another widget. I'm wrapping this column here because my chart bar is the child of the row here, and I could therefore also wrap the chart bar here if we wanted to. Let's actually do it here. So whatever you do, you should wrap the widget, which in the end is a direct child of the row. And I'll wrap this widget here with a new widget with the flexible widget. Now flexible takes a fit argument, and there you pass a flex fit value, it's an enum, where you have two values. Now let's try loose, and now you see already we have a line break here, because with loose we already restrict how much space this may take a bit. But it's better with tight. Now we force the child, as the text here says, to use its available space. And the available space here, by default, is the same space for every item in our row. You can change this with the flex attribute here on flexible. If you would wrap every child individually, which is not possible here because here we're generating all the childs, so every child I generate has the same flexible setting. But if you set flex here to 2 on one child and 1 on another child, then the child with 2 will get twice as much space in the row as the child with 1. So with flex and the values you assign there, you can distribute the available space in a row or column between the children. And you do this by assigning a number to the flex value, and then these numbers are added up, and each child then receives its share of the total sum based on the value you added. However, the default is that every item has exactly the same space, and that's perfect. That's what I want here. With flex fit tight, we then ensure that the child also can't grow, because by default every child has the same space, but childs can grow and take some space away from other children if they need to. With tight, we force a child into its assigned width or into its assigned size, and it can't grow. And that's exactly what I want here. Since it can't grow, now the label wraps here, which of course also is ugly, but our chart looks better. Now to avoid the line wrapping here, we can go into our chart bar, and we have to make sure that this text here basically shrinks if we're running out of space. And that can be achieved by wrapping the text with another widget that's built into Flutter, and that's the fitted box widget. The fitted box widget forces its child into the available space, and if that child is a text, it even shrinks the text. So it creates a widget that scales and positions its child within itself. So the fitted box prevents that this text keeps its original size and adds a line wrap. Instead it says, no, you will not grow in any way. Rather, you should instead shrink so that you fit into the box. And therefore now with fitted box, our label shrank, which is, in my opinion, better than having strange line breaks here. And with that, I'm very happy with the chart. The only remaining thing I want to do is I want to add some padding around my bars here so that they're not sitting on the edges of my card. And that can be done in the chart widget, of course, here on the row, which is the child of the card. Let's surround it with a container to add some padding, like this, with edge insets all of 10 maybe. And now we have some spacing here, which looks way better. Now, a little side note here. If you find yourself creating a container only to add padding, then there's a replacement. You can then just use the padding widget. And they're basically simpler containers, which can only be used to add padding. So if you only need that, you can consider using padding widgets instead of a container. You still, of course, need to set the padding property to tell the widget how much padding you want to add. And with that, this is the final chart. Now I want to fine-tune the list items a bit more. And once we're done with that, let's have a look at responsiveness and also how we can use different styles for iOS and Android devices. In the last lecture, we played around with our chart and we had this strange behavior that one column was getting bigger than the others because it had longer text in there. And that distorted our chart. And we could fix this with the flexible widget But of course, it's important to understand why we were able to fix it with that. For that, I prepared a very basic playground here. It's a simple app, and you of course find the code for that attached. It's a normal app as we created with Flutter Create, and I only changed the main Dart file to contain a row here as the body. I'm spacing my items with space around, so I'm aligning them on the main axis with space around. And then I have 3 containers in there. Each container has a height but no width, a different color on each container, and then we have some text in there. And the first container has a bigger text, which is why that box is, well, bigger than the other boxes. This is a comparable setup to what we had on the chart, right? We have 3 different elements in this case here, and one of them is getting bigger than the others. Now, first of all, it's important to realize that inside of a column or a row, every item is just as big as it needs to be or as you tell it to be. For example, on a container, we could also set a width of 300, and now we would have a way bigger container over there that even leads to that row not being wide enough to fit everything in there. So that's the first important takeaway. If you don't assign any widths and so on, then the items are as big as they need to be. Now, sometimes, however, you want to tell an item to take up more space in that row or column than it would normally take. And you can do that by wrapping it with a widget. Let's say we will wrap the second item, the second container here, with a new widget, and that is the flexible widget, which we used in the last lecture. Now there you learned that you can set a fit property. And now what does fit do, or the fit argument do? Fit takes a flex fit configuration. That's a enum with basically 2 values, loose and tight. The default is loose, so setting loose makes no difference here. What does loose mean? It means that the child of that flexible item basically should keep its size and use that size in the surrounding row or column. So as I said, it's the default and you rarely need to set loose explicitly. You would typically only set this if you kind of derive the value here dynamically, and you also sometimes switch it to its alternative, which would be tight. Now what does tight do? If I wrap my item 2 here with flexible fit set to flex fit tight, then you see all of a sudden this blue container takes up all the remaining space here in our row. Please note that it only takes as much space as fits in there without squeezing any items off the screen, which is why we're not getting this yellow-black warning marker here. So now blue essentially knows, okay, I should take all the space I can get. And indeed, if you have a look at the description of tight, then this is forced to fill the available space. Loose doesn't force the child to fill the available space, and therefore it will fill the space it needs to fit its content in, which in this case is only this text here, or if we had set a width on the container, it would be the width we set here. But now even when we set a width of, let's say, 100 here, with flex fit tight, this is basically ignored and it is forced to take all the available remaining space here. Now you can also do other cool things. Let's say we also have the third container wrapped with that. So I wrap this with a widget 2, give it a flexible widget around it, and set fit to flex fit tight. So to the exact same configuration as my item 2. Now you see the 2 items here split the available space. And now if I remove that extra text on the red element, on the first element, you see that this now gets squeezed to only have the bare minimum of space it needs to fit its text in there, which would be the default space it takes because we have no flexible widget around the first container with flex fit tight. We have no such setup there. And therefore, this only takes the space it needs. The other 2 widgets, the other 2 containers, however, are configured to fill the available remaining space. And that means right now, since there are 2 containers, which each want to take the available remaining space, they split the remaining space amongst them. Now, sometimes you want to have that behavior of taking the available space, but you also know, yeah, both should take the available space, but the blue container should get twice as much of that available space as the orange one. And for that, you can add another argument here on the blue container then, and that's the flex argument, which I only explained in theory in the last lecture. Flex by default is set to 1 on every element, so setting this to 1 won't make a difference. However, watch what happens if I set flex to 2 here. If I do set this to 2, now you see the blue container grew. And now, if that here, the blue and orange area together, is our remaining free space after deducting the red container from the full row, then you see that blue is now twice as big as orange because we gave it a flex value of 2. Now, important, 2 does not mean twice as big as the rest. Instead, this works a bit like Flexbox for the web, if you know that from CSS. If not, that's no problem. Flutter goes ahead and basically adds the flex values of all items in the row, which means the first item here has no flex value because it's not wrapped in flexible, but then we have a flex value of 1 here, which is the default for our third container. So we have flex 2 plus flex 1, which means we have a total sum of 3. Then Flutter knows that since this here has a flex value of 2, it wants to take 2 of 3 available segments, and this one has the default value of 1, it takes 1 of the 3 available segments. So this takes 1/3 of the available size, this takes 2/3. If we, for example, added flex 2 on the last container as well, they would split the size equally again. Why? Because we have a total flex value of 4, 2 plus 2, and Flutter now finds out that the middle container wants to take 2 segments of these 4 available segments to split the available space, and the last container wants to take the other 2 available segments. So therefore now they're evenly split. So these flex values have to be seen in relation to each other. If we have 5 and 2 here, this means, well, this is 5 to 2 in terms of how much space it takes. We have a total of 7 segments into which the available remaining space is split up, and this container here takes 5 of these 7 segments, this one 2 of these segments. So this is 2.5 times as big as the last container. This is how you can play around with that, and that's of course super useful for sizing your elements in a row or column. Now, back to the fit here now. If I change the item 3 to a flex fit of loose, you now see the container itself now only takes as much space as it needs for its child. And yet we see that there now is some empty space, some white space. The reason for that is that the flex values here are actually still taken into account. If I set the last item here back to flex 1, you see now there's less available free space. The reason for that is that we still have flex fit tight on the blue container, which means take all the space you can get, but we at the same time tell it, but you only get 5/6, because 5 plus 1, 5/6 of the available space. So even if the last item doesn't fully occupy the remaining available space, so the 1/6 that it could take, even if that's not the case, this middle container is still configured to only get 5/6 of the available space. And that means that 1/6, which the last item could take if it would be set to tight, that is simply left open, which is why we have white space all over our row, because that white space together would add up to the size the last box could take if it would be set to flex fit tight, which it isn't, therefore it only takes the space it needs for its content, and the space it could take is left empty. And because we have our alignment set to space around, that empty available space, which is not taken, is, well, split across the entire row and not just somewhere here at the end. So I hope this makes a bit of sense. As always, playing around with that, building a demo app like this and simply trying out different configurations is the best way to dive into this and to really master it and get a feeling for this. That's way better than learning all these different rules and combinations by heart. You won't be able to remember all of that, and also there is no value in doing so. Instead, build a simple application like this and play around with these settings to get a feeling for how FlexFit tight and flex fit loose and the different flex values work together. One last word. If you have flexible with fit set to flex fit tight, there also is another widget which you could use, which is a replacement for it. There is the expanded widget in Flutter. Expanded is simply flexible with flex fit tight, and therefore expanded has no fit argument. You can't set it here. Instead, expanded only knows the flex configuration here, which we used on flexible. So expanded is a perfect replacement for flexible with fit set to flex fit tight, and therefore if I save this, you see no difference on the screen because it is the exact same. So if you need flex fit tight, instead of using flexible with that configuration, you could simply use expanded instead. And that's it for now with rows and columns and flex and flexible and how to size the items in there. Again, definitely fire up your own demo app and play around with these values to get a better feeling for how this all behaves and how you can distribute available space in your rows and columns. I'm quite happy with our current state, but in the transaction list, as I mentioned, of course you can keep your custom list item here, which we built, if you prefer that. I want to show you an alternative though. And that alternative here, instead of using a card with our custom stylings and our custom setup, that alternative is a widget built into Flutter, which you often use in conjunction with lists, but you don't have to use it in conjunction. And that would be a list tile widget. Again, that's built into Flutter, and that's a nicely pre-configured and styled widget with a certain layout that fits particularly well into lists. On your list tile, you can set up a couple of things. For example, you can set up a leading widget, which means a widget that is positioned at the beginning of that list tile. And there we could use yet another built-in widget, the circle avatar, which is a rounded widget that can hold a content. Often it's used to hold images, but here we'll use it to hold our amount spent. And it simply looks nice. So here we can assign a radius of, let's say, 30. That defines how rounded it is. And give it a child, and that child here can be our text with our transaction amount. So again, here using a $sign, which we want to output and therefore which we escape, and then a $sign for our string interpolation, where I use transactions for the given index and there the amount. And if we save that, now our list items look like this. For very long numbers, it's not looking that great admittedly, and therefore you learned what we can do. We can wrap this with a new widget, and that could be our fitted box here. And if we wrap that with a fitted box, now longer items shrink a bit. Now still some spacing would be nice, and therefore we can then also wrap our fitted box here with another widget, with a padding widget, and give it a padding of, let's say, edge insets all 10, maybe. A bit too much. Let's go with 6. And yeah, super big numbers really don't look that good, but it's an unrealistically huge number for this app. So this should be fine. So that's our leading part, but of course that's not all that should be output on the list tile. Besides the leading element, we can also have a title, which is an element in the middle. And there I'd like to have my text with my transaction title. Now we can also set a style, and again I'll get that style here from my theme. So here I want to get my text theme, and there the title theme. Whoops, and it's not I but index. If we add this here, this title assignment with our text widget using the title theme, then we have the title again. Besides the title, you can also add a subtitle to the list tile, which is basically some text shown below the title. So here again, I want to show some text, and there I'll refer to transactions index and then my date. Date, of course, is a date time. I want to have a human readable date, and therefore here I'll use date format for this format with a year, a long month, and then a day. And then I call format and pass that date as a value to generate a string based on that date. And with this adjustment, we now have the date below that. And you're hopefully seeing how this is taking shape. Now we could even add a trailing element, so an element at the end of the list tile, and often there you have buttons, icon buttons like a trash icon for deleting the item and so on. But for here, the only thing I want to do here, I want to wrap this into a card actually. And on that card, I'll set up some margin in all directions. Actually, not in all directions, but symmetrically in the vertical direction, 8 and in the horizontal direction maybe 5, a bit less, so that there is some spacing between the list items as well, and a little background color. And I'll also add an elevation of 5 here to every card. And now with that, this is how the transactions look like. Not too shabby. And up there, we have our chart. Now, of course, feel free to fine-tune this a bit more if you prefer a different look. I will also revisit the general layout. For example, that we have this empty space down there. I'm not too happy about that. We'll fix this later once we learned how to work with the device size and how to find out how big the device is we're running on. For the moment, let's leave it as it is, and let's indeed have a look at how we can adjust our app to different device sizes and also to different operating systems, namely Android and iOS. In our application here, there's also one thing I want to improve. If I have a transaction with a pretty big amount here, so if we enter a big number, then we of course know that we would have grown our bar here without the fixes we applied earlier. One thing we can still see is that now these weekday shortcuts here are not really aligned. And in addition, we also see that the bar here, the first bar, is actually starting a bit earlier than the other ones. It's not in line with the other bars. The reason for that, of course, is that we shrank our text, and therefore the height of this text also changed, and hence this whole bar is moved up a bit. Obviously, that's not a behavior I want here. Now, to fix that behavior, we can go to our chart bar widget there, and simply wrap a container around our fitted box here, and in that container here, we can give this a height of, let's say, 20. Now, the text here at the top will always have a height of 20, no matter how much height it needs, and therefore the text is now aligned, the bars are aligned, and the text here at the bottom is also aligned. And that, of course, looks better than bars jumping randomly around. Now, one other thing we can improve on this chart here is the order of days. It's a pure cosmetic thing, and you might not even want this, but at the moment, the current day, today, is here on the left, and the oldest day is on the right. To me, it's more natural that the day 1 week ago should be on the left, and today should be all the way on the right. Now again, it's totally up to you if that's what you want, but if you want that, it's relatively easy to achieve. All you have to do is you go to your chart Dart file, where you derive your grouped transaction values, and there we built this list for our weekdays. In the end, the way we have our algorithm here means that we, generate today as the first day in line, and it's hard to change that. The easiest way to change the resulting list, however, is to simply add something on the list which is generated here. We can call reversed here. And reversed gives us a new iterable, so we can then call toList on that, and now we get a reversed list. So now we build a list, then we reverse it with the help of reversed, which gives us our list just in the opposite order, and it doesn't give us a list, but actually an iterable, and therefore, just as for map and so on, we have to call toList. And if you do that and you save this, now you see the bars switched order, and we have the oldest date or the oldest day on the left and today on the right. Again, it's up to you if you want that behavior. Here I do want it, and therefore this is the change that I think makes sense here. Before we continue working on this, it's time for a summary, because we covered a lot of things and a lot of different widgets over the last lectures. For example, in the transaction list, we now also use the list tile, the circle avatar, padding, fitted box. There are so many new widgets which I covered in this module thus far, and especially over the last lectures. Now, I know that when I learned Flutter, I found the amount of widgets overwhelming. Now, I did, of course, already mention this earlier in the course. There is this official widget catalog, which I always recommend checking out to learn more about the widgets we're using here and to also learn which widgets are available. I also want to really stress here that there are so many widgets, also because a lot of the widgets have equal or comparable effects. Not equal, but comparable effects. Take the padding here. I mentioned that you can build the exact same thing by using a container. You could use container with padding. Padding is simply a shortcut here, which you can use. You don't have to, but which you can use if you only want to set some padding. It can be easier, doesn't add the extra overhead of all the other arguments which you might want to set up, and therefore using a padding if you only need the padding is a bit clearer regarding your intents. Regarding performance, it's hard to measure that, but that should hardly make any difference. Now, circle avatar, for example, could also be replaced with a container which you manually turn into a circle shape. Now, that's something we haven't done yet. We haven't built our own shapes. But if you would want to replace circle avatar, you could use a container here. Now, of course, on this container, you can't have a radius, but what you can have here is a decoration. And there we can create a box decoration, which we did already earlier. And there, for example, you can set their color to theme of context and then primary color to use that. And then you can give this a shape here. And that by default, if you hover over that, is of type boxshape.rectangle. And you can set this to boxshape.circle to turn this container into a circle instead of a rectangle. Now you can also give that container a height of 60 and a width of 60. And if you save that, you have basically your circle avatar. 60 instead of 30, because 30 was your radius, and therefore, of course, height and width are double the radius. So this is just an example. Of course, you wouldn't build this on your own if you have a circle avatar, if you want that exact look. But this is basically how you could rebuild it. Of course, circle avatar behind the scenes also has some other things, but in the end, this is how Flutter works. There's always more than one way of achieving something. But that is something that shouldn't scare you, but that should actually be good because it gives you a lot of opportunities to build things in a different way on your own or by using certain built-in widgets. And you will also have that point, and that is absolutely normal, and I also have that point, even after all the time I worked with Flutter, where you suddenly find a new widget which you haven't heard about before, which does something which you always did differently. And that new widget does it in an easier way or in a better way. And there are also new widgets getting added to Flutter all the time. So take all these widgets as an opportunity and use the official docs, the widget catalog, to get a feeling for which widgets you have and how to use them. That's also the case for all these values like edge insets here. I know that when you're starting off, it's strange to see how I know that here you need edge insets dot. In other cases, you need to create a box decoration object. Then you suddenly need to use flex fit tight or something like that. So how do you know when to create which value? And there again, often hovering over a value gives you a first glimpse, a first idea. Here, for example, we get a hint at edge insets all. And that is already pretty helpful. If that doesn't help, however, you can also click Command or Control click on a value to dive into its source code basically and have a look at what's happening there and maybe get an idea of which value would make sense there. Or, of course, check out the official docs for the card widget, for the list tile widget to get a detailed explanation of how to configure and use it and to see some examples. That is how you get a feeling for that. And the more you then work with Flutter, the more you remember and the easier it gets to combine all these widgets together. But also be prepared that you will hit that point where you suddenly learn about a new widget or a new value and you can replace some of your existing widgets with that. And that's not bad. Using the second boast widget is not the end of the world, doesn't mean horrible performance automatically. That is how you learn Flutter and how you evolve as a Flutter developer. So enough words about widgets and how to learn and combine them. Let's go back to our application here. At the moment, there are at least two things which are missing. One is the date picker here. Right now, we have no way of selecting a date, and therefore we always use today, which is not really what I want to use. To change this, let's go to the new transaction. And there, below my existing text fields, let's add a new text field, but also a button which should open up a date picker because Flutter has its own built-in date picker widget, which opens up as an overlay on the screen. So in here, I want to add a row actually because I want to have two widgets next to each other, a text field where the user actually can't type, which we only use to output the chosen date, and then the date picker. So for that, let's use a row, add the children property or argument here. And now let's add the two things I just mentioned. So we can add a text widget or a text field widget, which is disabled, whatever you prefer. I'll use the text widget here. And on that text widget, by default, I will say no date chosen. Then next to that, since it's a row, it's placed to it next to it automatically. I can add a flat button here with a child of text choose date. And then, because it's a button, also on pressed, which for now will be just an empty function, which doesn't do anything, of course, but which we can soon populate to do more. With that, if you save that, you see this extra input below our other text fields here. Now, we can certainly improve the look of that a bit. For example, on the button, let's add a text color, and there I want to use my primary color based on the theme with the help of theme off, which gives us access to our theme data. So now this looks better. And in addition to that, maybe add a bit more height to this whole row here. Now to add more height to the row, we can't add height here. The row doesn't have a height property, but we can of course wrap the row in a container and give that container some height. So in that container, let's maybe use 50 as a height here. Maybe 70 actually. Yeah, that now looks better. Now there's a little bit more spacing. So with that, we have a button to choose a date. We have the text here. Now, I also want to change the style of the button a little bit. So on that text widget in there, the style of the text I mean, I'll add the style key, and I'll now not use a theme style, but create a style inline here, so to say, and simply give this a font weight of fontweight.bold. And of course, it's up to you if you want that. I like to have that as a bold text. I think that's a bit easier to spot and to use then. Now, with that, I think the add transaction button is a bit lost now. So maybe we now go down there and change this from a flat button into a raised button here. And change the color instead of the text color to purple so that the background is purple. And now let's make sure that the text color is white. And for that, of course, we could set text color to colors white here. But actually, we have two issues here anyways. For one, I shouldn't choose purple like this. Instead, I want to use my theme. So let's select my context or my theme from my context and choose the primary color there. And instead of setting the color here to white, we should also get the default button color from the theme. We can do this with theme of context dot text theme dot button dot color. And now, since this is still black and I would rather see white here, of course you know that we can go back to the main Dart file to set up a general text theme for our button. So we're setting up the text theme here for the title. Next to title, we can now also set up our button theme, set this to a text style here. And since we're still in the copy with mode, whatever we set up here will be merged with the existing theme. And there we can set up a color, and that, in my opinion, here should be colors white because I'm using purple here. And I personally like white as a contrast more on that 700 shade here, which is the default, by the way, that is chosen for the button. So with that, if we now save this, you see now we have that white color here because we manually overwrote this. And the advantage of doing this via the theme here, of course, is that now whenever we reference this color here on buttons, we automatically get that, and we can always switch it in one central place. So with that, we're working on that, but of course our main goal was to add a date picker. So let's make sure that this button now also does something. Let's wire up the choose date button here with a method that actually presents a date picker. And the good thing here is that a date picker is built into Flutter. So what we actually can do here is in our new transaction state, which holds that build method where we build that new transaction input fields, there we can add a new method. And by the way, this of course should be underscore submit data here, now that I see it, to be in line with our general naming of using private properties and methods in our private classes here. So replace submit data with underscore submit data everywhere. But of course, the main thing here is not to replace that, but to add a new method that actually shows us a date picker. This method doesn't have to return anything to the place where it is called. And I will name it %datePicker because that is what the method should do. It should show a date picker on the screen. Now here for %datePicker, we can use the show date picker function, which Flutter gives us automatically. Just like show modal bottom sheet, which we used earlier, this is used to present an overlaid date picker on the screen. Now a show date picker, of course, can and has to be configured. For example, you need to add the context argument here, just like as on our show modal bottom sheet method here, where we also had to provide a context. The show date picker method also needs to know the context of the widget in which you're calling it. Now, conveniently, in that state class, which is connected to our new transaction widget, we have that global context property available, right? So we can just use that. Now, context here on the right refers to that class property context. Context on the left here is the name of the context argument showDatePicker expects. So the context is one thing we need to pass. We also can pass an initial date, so the date which is initially selected when this picker opens. And there you pass in a datetime object, as you can see if you hover over this here at the top. And therefore we can simply use today for that and use datetime now as a value that we pass in as an initial date. You also might want to restrict the first date that can be chosen and the last date that can be chosen. And for that you can set first and last date. The first date for me should be January the 1st, 2019. So I can simply pass in date time and now not create it with now, but with its normal constructor. And to this constructor here, you see you can pass a couple of positional arguments, and there is one required positional argument, and that's the year. And if you only pass the year, then this will be January the 1st at midnight or 1 second after midnight in this year. So now it will be January the 1st, 2019. And I also want to have a last date, so the last date which can be picked, and that should also be today, because you can't add a transaction in the future, at least not here in this app. So this is how we configure that. Now, showDatePicker should open up as soon as we call %datePicker. So let's hook up that method here to this button, to this choose_date button, %datePicker. Without parentheses, we just want to pass a reference so that this is called by the button when the button is pressed. And if we now save that, and I press choose date here, you see that date picker open up. And that's a widget built into Flutter. Thankfully, we don't have to build that on our own. And here you see we can choose dates, and I can go back all the way to January 2019 and choose January the 1st, or on the other hand, I can go all the way up to the current date I'm recording this on. So this is the date picker. Right now, we're not doing anything with the value the user might have picked. No matter if we cancel or if we confirm with OK, we're not doing anything with the value. And that will be, of course, the next thing we want to do. We want to save the date the user picked. Now for that, you have to know that showDatePicker, this method you're calling here, actually returns a so-called future. We haven't worked with futures thus far. Future is a class built into Dart, not into Flutter, but into Dart. And it's a very important class there. Futures are classes that allow us to create objects which will give us a value in, well, the future. So you use a future, for example, also for HTTP requests, where you need to wait for a response to come back from the server. Here we wait for the user to pick a value. So showDatePicker, immediately when we call it, returns a future, but it can't immediately give us the date the user picked, right? Because we just opened the picker, we don't know when the user is going to choose a date and click OK. So we get back that future, which will then trigger once the user picked a date. Now, to be informed about that, when the user chose a date, we can add a method on the value returned by showDatePicker, which is that future. So on a future, we can add the then method. Then simply allows us to provide a function which is executed once the future resolves to a value. So once the user chose a date. So here we can pass in an anonymous function which will be triggered once the user, well, chose a date. Please note that code execution in your app will not pause and wait for this to happen. The cool thing about futures is that the function we pass in here is stored in memory, and the other code after showDatePicker, if we had a print statement here, this will still execute immediately and will not wait for this future to resolve, which is great, because it would be bad if we would block the entire app just because we're waiting on some user input. So therefore now here, this function will be called once the user chose a date, and there we will get the picked date as an argument in the end. This function is of course called by Flutter for us, and Flutter will give us the date the user picked. And there we first of all can check if picked date, should be date, not data, if that is equal to null, because if that is the case, the user pressed cancel, and then I just want to return in this anonymous function and not continue with any other code. Otherwise, if we make it past this if statement, so if we don't go in there and return because the user did pick a date, then of course we can use that date in our app. And for example, we can store it in a variable. That would be a good start. So here we have the title and the amount controller, and these also should have an underscore at the beginning now that I see it, because they are properties in our class here. So also all places where we use them should now add an underscore, of course, also down there in the widget tree. But again, just as before with the submit data method, the core thing is not that I wanted to change these variables here, these properties. Instead, now I'll add a new property, which is of type datetime, the selected date. And this is not final because this will change. It has no value initially, and it will receive a value once the user chose a date. So it's not final. So the selected date here should be set equal to the pick date if we make it past this if statement here. So selected date equals picked date. Makes sense, I guess. And it would also be nice to output that date down there in that text where I say note date chosen. So here I want to check if selected date is equal to null, in which case I want to show no date chosen. But if it's not null, then we do have a date. And then I want to output the formatted date. Now to format that, we need to bring in that intel package, which gives us that date formatting functionality. So let's import intel Dart from the intel package here at the top of new transaction Dart. And with that imported down there, in the else case of our ternary expression, we can use date format. And now it's up to you how you want to format the date. I will use the YMD format, which is a relatively short one, and insert my selected date here to output that. So now with that, we should save any chosen date and output it here. So if I save that and I go back here, open this, if I click cancel, nothing happens. But if I choose, let's say yesterday, also nothing happens. Do you know why? Because I didn't do one important thing. Setting selected date here is nice, and it will change the property in the class. But to also update the UI and rerun build, we need to wrap this into set state. Remember that this is your trigger to tell Dart, or to tell Flutter, that a stateful widget updated and build should run again. So once we change the selected date in set state, we should have a setup that will reflect a selected date on the screen. So now back in the app, if you bring up that date picker again, and now I choose yesterday, now I get an error. Datetime is not a subtype of type string. So what's wrong here? Well, my problem is down there, where I format that date. Just as before, of course, mistake, I don't have to pass the date into this constructor. Instead, that constructor gives me an object where I can call format, to which I then pass my date. So always format takes the date, not the constructor here. So don't repeat that mistake here as I did. With that, however, now you see the date is output there, and now we can also, of course, choose a different date and overwrite this if we want to. Maybe it looks a bit nicer if we add some string concatenation here and we say picked date colon, and then we wrap this expression where we transform the date into some string interpolation with $ curly braces, so that we have a bit of a more meaningful output and we inform the user what this date here means. It's the date you picked after all. Last but not least, I want to move choose date all the way to the right here. And that can be done, since we're in a row, by wrapping our text here into flexible with flexFit tight, or, as you learned, into expanded. And now this will take as much free space as it can get and only leave the button here as much space as it needs, which means that the button is now all the way on the right, plus its internal padding, which it has, as you can see if I tap on it, and our output here is all the way on the left, occupying all this free space here. So that is it. That allows us to choose a date. Of course, right now we're not saving and using that date though when I add a transaction. So let's do that next. Let's now also use the selected date. And we already have the submit data method, which is triggered when we try to add the transaction. There, right now, we're validating that we have a title and an amount. And if either of the two is missing, we return, which means we don't submit the data. Now I want to add a third condition, which when it is false will also lead to this not being submitted. And that is, of course, that selected date is equal to null, so it's not set. If that is not set, then I also want to quit. So if either of these three conditions is met, if we have no title, if the amount is below 0 or equal to 0, or if we have no selected date, then we will return. And as an addition, to avoid errors, if you don't even have an amount entered, so if you hit add transaction here with nothing entered, where you get an error right now, you can also add an initial check here and check if _amount controller text is empty. In that case, this here would always fail. Then you can also return. Now you can still fail if you enter some text that is not parsable into the amount controller, but that's a case we can ignore for now. At least we now avoid errors because we try to submit an empty form. But back to submitting our date. In the end, the goal has to be that we pass our selected date here, the datetime object, to add tx, so to our add transaction function. The add transaction function in the end is of course defined in main Dart. There we have add new transaction, and at the moment we're not expecting a date here. Of course we can change this. We can accept a third argument, which is of type datetime, which is the chosen date. And the chosen date should now be used here instead of datetime now as a date for the transaction. And that should already be all we need to do. This should allow us to pick a date and use it in the created transaction. So if I now add a title here, new shoes, and a value of, let's say, 69.99, then at the moment I also can't get to my date picker without closing the keyboard, so we'll have to take care about this soon. For now, let's close the keyboard and now choose a date, let's say yesterday. And if I now add the transaction, that's looking good. It was added to yesterday, not today. And now let's try another transaction, groceries, for 15.86, let's say. Close that, choose a date, and let's say that was on Sunday. Then indeed that's added here on Sunday, and you see it only makes up a fraction of our total spendings. Now, the fact that we can't really get to our date picker here without manually closing the keyboard is something we should also take care of course. For the moment, it's however something we can live with, and later we'll learn about a technique or about a certain feature of Flutter that helps us with fixing this problem here as well. The application is really taking shape. Besides some styling or layouting things like that keyboard thing here, or maybe on different device sizes where we might want to change the look and feel of our app a little bit. Besides that, the app is really looking and working good and decent. And the missing feature I want to add here is a feature that allows us to delete transactions. For that, let's go to our list tile here in the transaction list start file. And there on the list tile, I did mention that on the list tile, you can add a trailing widget as well. So if you add trailing here, you can add a widget there, which you want to show at the end of the list tile. And the trailing widget I want to show here is an icon button with an icon of delete, which is a trash icon. So I'm creating that icon button because when we press this button, the element on which we triggered it should be, well, removed. I'll give this a color, that icon, and the color here will be received or taken from my theme, and there I'll take the error color. Now we haven't set the error color, and of course you could do that in your theme. There on the main Dart file, besides setting a primary swatch and accent color, you can also set an error color, but the default here is red already, so you don't need to set that, but you could if you wanted to, and especially if you want a different color than red, of course. And then on pressed, I of course want to trigger a method that removes that element. And for the moment, let's do nothing so that we can see whether it's displayed. And that's looking good. We have that icon here. We can press it. So let's now also make sure that when we press it, we do delete this transaction. Since we manage the transactions in main Dart, here in our My Homepage state class, where we also have the add new transaction method, this is also where we should have the delete transaction method. So let's add delete transaction here. Doesn't need to return anything because the place where we call it doesn't really need a return value. And now the question, of course, is how can we delete a transaction? How do we identify a transaction? Now, of course, you could identify a transaction by its name, by its title. But the problem is the title here is not necessarily unique. So is the amount and the date. All of that could be duplicated. We could have the same transaction twice on the same day with the exact same amount. That would be valid. So rather than doing it like this and trying to delete the transaction by name, we can use another trait of our transaction. If we have a look at the model, we see that we have an ID there, and the ID should be unique, and indeed it is. At least almost. Of course, in our app here, in the main Dart file, when we create a new transaction, we do generate the ID based on the current timestamp, and in theory, we could have the same transaction added twice at the exact same time, but in reality, in this app, that won't really happen. So it's a good enough ID for now, and therefore, we can use this ID as an identifier. So when this method here gets called, delete transaction, I expect to get that ID as an argument by whoever is calling that. So whoever calls this method needs to provide the ID of the transaction that should be deleted. And then in here, we can delete this transaction by that ID. For that, we will call setState because we certainly will need to rebuild our UI thereafter. And inside of that function you pass to setState, we can reach out to our user transactions, to our list of transactions. And there, as you learned, since this is a list, you have multiple methods that allow you to manipulate that list and generate a new list. And I want to use remove where. This manipulates the existing list, just like add manipulates the existing list. And it removes the item where a certain condition is met. Therefore, we pass in a function, and that function gets the element, each element of the list, because this runs this function on every element in the list, just like where did. So we get our transaction in here, and we have to return true if it is the element we want to remove. And that, of course, is the case if the ID of the element I'm looking at is the same ID as I'm getting here. So if tx.id is equal to ID, then I know this is the element I want to get rid of. And since we only have one expression here, which value we return, you could also use the shortcut of using that arrow without the curly braces and without the return statement, and use this inline notation also without the semicolon, and have this shorter syntax here. That's optional, but you can use it here because we have only one expression and we want to return the value and use that value of that expression. So this allows us to remove an item with that ID. Now we need to call delete transaction, and that happens from inside the transaction list. So let's pass delete transaction to the transaction list now, here as a second argument maybe. And of course, we now need to tweak the constructor of transaction list now to accept that. So here I now expect to get a function, delete tx, whatever you want to name it, and I bind the second argument I'm getting to this delete tx property here in the transaction list widget. And now delete tx is a pointer at that delete function. So in our transaction list, we can now use it here on that icon button to trigger that deletion. Now important, binding it like this won't work because delete tx actually points at our delete transaction method here, and that requires an argument, the ID of the transaction that should be deleted. the onPressed method by default doesn't pass any arguments. So we would be missing that argument which we need. The solution is to wrap this into an anonymous function so that we pass a reference to this function, to this anonymous function, to onPressed. And then when this anonymous function is executed, in there we have our own function which we call, and there we can now pass our own argument. And the argument I want to pass here is my transaction ID. So I can use transactions and then for the given index .id and forward that. With that, let's give it a try. Let's save it all. Let's try deleting the new shoes here. And that works. And you see the chart also updates. So now we have a setup where we can not only add transactions, but where we can also delete them. To round up this application as it currently is, before we dive into responsiveness to make it look good on other device sizes and to make it look good on iOS, I want to revisit this list of transactions because at the moment I feel like it looks a bit cut off, both on the top and at the bottom. Now, first of all, to make sure it looks better on the bottom, here on our transaction list widget, we can of course do something to change the height of this container. Keep in mind that this transaction list widget is used in our main Dart file, in our state class there, here as part of this column where we have the chart and then the transaction list. Now you learned what you can do to make sure that this takes all the height it can get in this container, in this column I should say. We can wrap it with flexible and flex fit tight, or therefore also just with expanded. We can either wrap expanded here around our transaction list widget as we use it here, or, since that's basically the same, inside of the transaction list around that container. Because in both cases, it's the direct child of this column then. Our widget here is just a wrapper around these other widgets which are actually printed to the screen. So therefore, it's the direct child either way. I'll use it here, since we can then immediately see that it belongs to this column here. And therefore, I'll wrap this in an expanded widget here, my transaction list. And if we save that, we now get an error though. We get an error, which basically means that it's having problems expanding here. And why is it having these problems? It has these problems because in the transaction list, we have our list view here. And as you learned earlier in this module, the list view has an infinite height. That means that if we have various items, various transactions, the list view is configured, or is always configured, to have an infinite height. And if we have transactions, we display this list view, of course. And previously, we controlled that with height 300 here. Now that height of this container is overwritten by our expanded widget, which wraps our transaction list and which therefore wraps this container with height 300. And as you also learned earlier in the course, expanded forces the child to take all the available height it can get, in this case, in the column. Now, if we force a child to take all the height it can get, and our child, in the end, is a list view, which takes an infinite amount of height, then we have exactly the problem we have here. We're telling it, take all the height you can get, all the available space, and at the same time, our child says, okay, I take everything, I take an infinite amount of height. And these two pieces of information don't fit together, which is why we can't really use expanded there. Now, what could we do, though, to still make sure that we take the available remaining space here with our list view? Well, we'll later in the next section learn about a way of calculating how much height we have available, and then we can manually calculate pixel values, percentage shares of that total height to use a fixed height on our container here, but actually derive that fixed height dynamically on the available height, which we're now trying with expanded, but expanded works a bit differently. It's not setting a fixed pixel height. It's, telling the child, please take all the available space. Later, when we can calculate a fixed height, but change that fixed height depending on the viewport height, then we'll have a tool to make sure that we can actually take up the available space and at the same time not run into this issue. For the moment, we can't do this, and therefore we'll have to set a fixed height. And so to simply have a bit of a better looking app right now, I'll set a fixed height of 400 here, which means that here now this is getting cut off a bit further down, and we can kind of maybe use 450. And of course, this now only looks good on this device. That's the problem here. And if we had a bigger or a smaller device, it would not look good, but that's exactly what we'll tackle in the next course section, where we will actually not hard code this to find a value that works for this device, but where we can exactly calculate this for all kinds of device screens. Still, for this device, this now looks better, and I hope it's clear, or I could convey what the issue here is with expanded and the list view. With that, I think the app is looking good. We can certainly work with that. Let's add one other transaction to see whether everything is working correctly with our changed list height here. If I do this, yeah, we can scroll here. We can scroll the overall page. Of course, that only scrolls the size of the chart in this bottom container, however. And in that container, we then have an extra scroller with our list. So that is all looking good, is all working great as it should. We can delete items, that's also working. With that, that's it for this module, and we'll next have a look at how we can adjust this in a more flexible way to different device sizes and to different platforms. So that's it for this module. We added a bunch of custom widgets composed of built-in widgets Flutter ships us, and there you learned about many new widgets and how to configure them, like the text field widgets, containers, expanded, different buttons, the list tile widget here, the list view widget, and hopefully all these pieces together form a bigger picture that allows you to use these widgets in your own apps. Now, as I also emphasized throughout this module, it's normal that you have so many widgets and configuration options that you sometimes forget about a widget or that you're not sure how to use a widget. And in such cases, the official docs and there the widgets catalog is really a crucial tool to work with. In addition, also be aware that in the official docs here, once you are in the API reference here, where you get to when you choose a widget from the widget catalog, you can always search the docs up there and, for example, search for a list tile to find more information about that, on how to configure that, and also find demos, examples, and more. So really use these docs to get the most out of this course and, most importantly, to get the most out of Flutter. Because that is what Flutter is all about and what this module was all about. You learned more about the Flutter fundamentals, about how to compose user interfaces from built-in and custom widgets, and that custom widgets are also composed from built-in and other custom widgets. You learned how to style and configure widgets with their arguments, and as I just mentioned, to use the docs and the IDE support you're getting by hitting Control Space and by hovering over things, and that really should get you very far. Now, when we talk about styling and configuring widgets, it's important that there is a broad variety of how you can configure and style widgets. For some widgets, you need an extra constructor. Other widgets are configured with enums or by instantiating some class with its main constructor. And there again, the docs and the IDE help you understand what you can pass for which argument. And often there's more than one widget or more than one option that gets the job done, and that's also fine and perfectly normal in Flutter. We also had a look at theming, which is the idea of defining that global theme in your material app widget, which you then can tap into from anywhere in your app with theme of context, which allows you to define your global colors or your main text theme once and then use it anywhere in the app where you want to use it, so that when you ever change that main color, it changes everywhere. And the built-in widgets, a lot of the built-in widgets also use these theme settings automatically. So you get the nice styling there automatically without any extra setup. Last but not least, we added some business logic to this app as well. We added methods, we managed data, we used stateful widgets. And there you learned that lifting state up is an important concept, that you need to manage state on the common denominator widget, which holds all the other widgets that need that data or that trigger a change that should change that data, like in the example with our main widget and then the transaction list and the new transaction widget. And you also learned how to pass function references and data around so that every part in your widget tree, every widget there, can do exactly the things it needs to do, be that outputting content or registering events. Last but not least, you also learned how to adjust the user interface to your logic. For example, showing that bottom modal sheet to have a nicer way of presenting that editing area to your users, which allows the users to add new transactions in our example app here.